Give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone, give me the phone,
Give me that stuff, that funk, that sweet, that funky stuff. Give me that stuff, that funk, that sweet, that funky stuff.
Give it to me, baby.
Give me that stuff, that funk, that sweet, that funky stuff.
Give me the funk, give me the funk, give me the funk, give me the funk, give me the funk.
Give me that stuff, that funk, that sweet, that funky stuff. Give me that stuff, that funk, that sweet, that funky stuff.
Give it to me, baby.
Give me that stuff, that funk, that sweet, that funky stuff.
Give me the funk, give me the funk, give me the funk, give me the funk. Give me the funk, give me the funk, give me the funk. Give me the funk, give me the funk, give me the funk. Give me the funk, give me the funk.
Why do I do the things I do?
Give me the funk, give me the funk.
Why do I do the things I do?
Give me the funk, give me the funk.
Awesome. Thank you, DJ Desired State. Hey, Damani. Hey, Stefan. How's it going?
Hey.
We had to start a couple minutes late there because we couldn't cut into the Daft Punk. I was like, oh, that's so good. What a great way to start the morning, which is morning here in the West Coast. And for you, Damani,
It's morning. It's top of the morning here in New York.
Yes. And
Yes.
Stefan, thanks for joining us for your evening. Or is it late afternoon? We're a bit early.
Late afternoon. Yeah.
Late afternoon. Excellent. From Romania. So thanks. So if anybody knows, this is GitOps Days Day 2. And this is our pre-show because we've got Stefan out, like I said, in the evening, late afternoon in Romania. And as many of you love to do Flux deep dives. And also Stefan did a very, very successful deep dive part of KubeCon. But if anybody missed it, we thought it'd be a great chance to do a pre-show and answer any or all of your questions about Flux and how it provides fantastic GitOps. So Stefan can talk a lot. Stefan can talk for a long time. So that's why I said, let's bracket a whole morning for me, a late morning for Damani and any of you who are joining. So why don't we get right into it? And I'll be monitoring our Slack channel for any questions. So if you haven't joined yet, hopefully you can see the link down below on our YouTube page, and we'll be monitoring the questions there. So with that, I'll hand it over to Stefan.
Great, thank you, Tamao. I'll share my screen now. Okay, so going to talk about Flux today. I'm Stefan Prodan. I'm a Flux maintainer, and I'm working for WeWorks together with Tamao in the developer experience team. So let's start with the basics. What is Flux? Flux is a tool that helps you build GitOps pipelines across your clusters for infrastructure, for apps, and so on. The whole idea is quite simple. You define your cluster state in a Git repo or an S3 bucket or something like that. And you install Flux on your cluster. Then you tell Flux, hey, keep my cluster in sync with whatever changes are made into the source, be it a repo or an S3 bucket. Who is Flux for? We have three categories of users. So the first one is platform engineers who build continuous delivery tools for developer teams. And second, we have cluster operators who have to maintain the cluster feed. They have to automate the provision of clusters and all their add-ons. And finally, we have app developers who rely on continuous delivery to get their code changes shipped to production or to different stages. First, I'm going to talk about platform engineers. So Flux has evolved over time. The current Flux version is built on top of SDK that we call the GitOps toolkit. And this toolkit is made out of Kubernetes APIs, Kubernetes API extensions called custom resource definitions, and specialized tools, which are Kubernetes controllers. And Flux is an opinionated way of how you bundle these controllers and these APIs and how you make them work together. Now, you can extend the GitOps toolkit with other things if you feel like you need a particular feature that Flux doesn't allow you to do. At the core of the GitOps toolkit is a controller called source controller, and this tool is managing sources. What it does, it reaches out outside the cluster. It fetches things like Git repositories, Helm charts from Helm repositories, S3 buckets, and so on, and it brings those manifests, those definitions inside the cluster, and it bundles them under a thing called artifacts. What are artifacts? In Flux are tars which contain those particular manifests. Now, you can configure source controller with custom resources. For example, if you want to bring a repo content inside your cluster, you'll be creating a Git repository custom resource where you specify there how source controller should do authentication, maybe validation of the commits, authenticity using, let's say, OpenPGP code signing. You can also define Helm repositories from where Helm charts will be pulled. And you can also register buckets, being a cloud-hosted bucket like Amazon S3, or maybe your own S3 compatible storage like Minio. So everything else that needs to interact with these sources, instead of reaching directly to them, will be talking to the source controller, and source controller will notify any consumer if a source changes. So if, let's say, you push a commit to your Git repo, source controller monitors that repo, it pulls the latest change, then it notifies the other controllers in your cluster, hey, there is a change, you have to act on it. And let's see which consumers we have implemented. So the source controller consumers are called specialized reconcilers, and they are like these tools that are made particular for a single purpose. For example, if you, in your Git repositories, you define customized overlays, or maybe you have plain YAMLs, then you'll be using customized controller to reconcile those manifests on the cluster. But if you want to manage Helm releases, then you'll be using Helm controller. And this is the part of where you pull changes from outside and you apply them on the cluster. But Flux also has a feature called image automation update. And how that works is Flux, through the image reflector controller, can monitor container registries. And it can detect that a new image has been pushed to the registry, then the image automation controller will apply changes in your Git repos based on policies. For example, you can say, every time there is a stable release of Redis on Docker Hub, I want to automatically upgrade my Redis clusters. So the image automation controller will patch your YAMLs using the new version that has detected, and will commit those YAMLs back to your Git repo. Then, be it customized or Helm controller, will apply those changes on the cluster, and this is how you can fully automate, let's say, patch releases, CVEs, and so on your cluster without any kind of manual intervention. So if you want to extend Flux with other things, like a Terraform controller or JSON and stuff, or maybe you want to handle pull requests and so on. Until we get to those, or maybe we will never get to those because they're out of scope, you can use the client SDK that we have. We have also some guides on how you can create your own specialized reconciler. And there is a link here. I'll be sharing these slides. There is a link here to documentation and an example repo on how you can use controller runtime and kube builder to create a controller, a Kubernetes controller from scratch. And then you can subscribe to the source controller events, get those manifests. Maybe in there are not Kubernetes YAMLs. Maybe there are, I don't know, Terraform files or whatever else is there, and then you can do your own thing. Okay, back to the Flux users groups. The second use case that we target are cluster operators. So what a cluster operator has to do is create cluster definitions, being through cluster API, or maybe you have a Nikes cattle config file, or something like that that defines your clusters. Then you have to pick and choose cluster add-ons, configure those. Then you have to onboard tenants like dev teams or other applications that are maybe not even managed by your own organization, are managed by someone else. And once you have that all defined in a Git repository, then you can use that repo to target clusters and define the desired state of your whole cluster fleet through that repo. So in this approach, what I've described here is where you have a monorepo with everything inside, and the clusters where Flux runs, and it applies all the things in there. Now, of course, there are many more approaches to this. You can also have a monorepo only for your infrastructure items. And when it comes to the apps themselves, you can tell Flux to register those app repos onside the cluster. So in a way, you can delegate responsibility for operations to other teams while still running a single Flux instance on your cluster that connects to all these external sources that define the final cluster state. And here is where the challenge comes in. When you as a cluster operator, your team collaborates on this repo, right? So everything that changes there is approved with pull requests and so on. But if you don't have control over the app deployments, maybe some other teams are in charge of it, maybe you want to enforce some boundaries around what those repositories can contain and how they can affect your whole cluster state. And this is what I want to show you today. First, we are going to provision a cluster. We are going to install some cluster add-ons, and then we are going to deploy applications from other repositories that we have no control over. But we can, I'll show you how with Flux you can restrict whatever is in there, and how you can also apply policies and other things for what you don't actually manage. So how does a cluster admin spins off Flux? So we have this procedure called bootstrap, and you can bootstrap Flux on your clusters with either the Flux CLI or with our Terraform provider. What Bootstrap offers is one-click provisioning for creating Git repositories, setting up deploy keys, granting access to teams for that particular repo, and of course, configuring and installing all the Flux components, all the controllers from the GitOps toolkit that you can pick and choose. For example, maybe you don't want to automate image updates, then you don't have to install those controllers and so on. Or maybe you don't want to, you don't use Helm, so you can install Flux without the Helm component and so on. The Bootstrap commands works with GitHub and GitLab APIs. So we actually call those APIs, we create the repos for you and so on. But Flux Bootstrap also works with a local clone and with your SSH agent. So you are not locked into only these two options, GitHub and GitLab. It works with any other Git provider that supports SSH, as long as you have an SSH agent. And let's say you don't have SSH enabled, you can also use Git over HTTPS as well with tokens and so on. So going to stop here with the presentation. I'm going to go back to it. I'm going to show you how Flux Bootstrap works. So I have a cluster here. Going to list all the namespaces. Okay, so I have an empty cluster. And now I want to create a repo on GitHub. and I want to install Flux on my cluster and drive all the other things, installing cluster add-ons and so on, only through Git operations. So the first thing I will do, I'll run the Flux bootstrap command. Let me know if the text is visible for everybody. If you write on the GitOps Days Slack channel, I can see your messages. Okay, so the Flux bootstrap command takes the owner of GitHub, what repository I want to create. In my case, is my Kubernetes fleet. You can also tell Flux if you want this repository to be created private or public, if it's on your personal account, which branch should be used for the cluster sync, and if you want to give Flux write access to the repo or not. If you are using the image automation components, you have to give Flux write access because it needs to patch your YAMLs and write them back to Git.
Hey, Stefan, can you hear us?
Let me run this.
Stefan, can you hear us? I think Stefan might have lost his audio.
Hey, now we see that the CLI has created my repository. Now it does a local clone. It generates all the Flux manifests, all the components and so on. Then it pushes those manifests to Git. And now it has generated the SSH private and public key, and it has used the public key to set up a deploy key on GitHub. So that's how Flux gains access to that repo. Of course, you could also run the bootstrap for HTTPS and tell Flux to use a personal access token. So you can create, let's say, a bot account for Flux in your GitHub organization and assign Flux that particular token, and then you don't need to set up deploy keys and so on. There are different approaches. I feel like the deploy key is one of the most straightforward. So let's see what happened on my cluster. If I'm looking at the namespaces, see that here is the Flux system namespace. If I'm going to look inside the namespace, get pods Flux system, see that I have 4 controllers running. This is the default Flux installation. The image automation controllers are still under development. They are in alpha stage, so you have to tell Flux Bootstrap to install them if you want those. But we are getting very close on releasing a stable version of the image automation. We have a proposal to promote our current V1 Alpha 2 APIs to V1 Beta 1, and once that's done, I expect it by the end of this month. Then when you'll be installing the next version of Flux, you'll get the image automation in there by default. So okay, so I have Flux running on my cluster. Let's see what happened on GitHub. So if I'm going to look at my repositories, I should see the repository that Flux created. So I'm going to make this bigger. Okay, so Flux created this repository for me, and it has created also a directory structure here, clusters, staging, and in here we have all the YAMLs that are making up Flux. These are all namespaces, custom resource definition, deployments, and so on for all the GitOps toolkit controllers. And I also have here the main sync manifest for this whole repository. And in order to clone this repository inside the cluster, there is a Git repository definition. And to apply everything inside the staging directory, there is a customization object. So what this customization object does, it tells Flux on my staging cluster, hey, apply whatever is in here. So now if I add the YAML file, let's say, I don't know, a pod definition or whatever, next to the Flux system directory, then Flux will create it on the cluster. So anything outside the staging path, Flux will not look at it. It will only synchronize that. Why Bootstrap creates this structure is for allowing you to manage multiple clusters from a single repo. So you can rerun Bootstrap, use a different cluster as the target, give it a different path, I don't know, clusters, production, and then you will be syncing with the production cluster as well from the same repo. But that's not a requirement. You can create different repositories for your production environment, and you could use the same repository, I don't know, for staging and development and so on. This is just one way to get started. There are many other options. Flux is not opinionated in that way, so you can do it whatever you want. Also, the Flux Bootstrap command is not an absolute requirement to set up Flux. We provide plain YAMLs, and you can do this whole thing manual, or you can use the Terraform provider, which can do quite the same thing as the Bootstrap command. Okay, let's move forward. I'll try to use the GitHub code spaces. Let's hope that works. Going to okay. So this will launch Visual Studio Code in my browser, and I can do all the operations from my browser. Okay, I have all the structure here. Let me make this bigger. So first thing, what I'm going to do, I'm going to install the Flux CLI also here in the VM provisioned by GitHub. So now if I do Flux -v, okay, I have the latest Flux version installed. And as I've shown you, you have the initial manifests here. Now, let's say I want to install some infrastructure items on my cluster, and today I'm going to use Kyverno to demo this. Kyverno is a policy operator. You can, for example, with Kyverno, you can define something like pod security policy, since that is deprecated in Kubernetes itself, and you can create all sorts of custom policies for your teams, workloads, and so on. Right? This can be anything. It can be, I don't know, a cert manager or whatever else. So I'm going to use the Flux CLI to generate YAMLs because I'm a very bad typist. I'm going to make a lot of mistakes. So the CLI has basically two functions. One is to generate YAMLs for you, the Flux custom resources, and the other one is for introspection, debugging, and so on. So in here, in Visual Studio Code, I'll only use Flux to generate YAMLs, while on my machine, I'm going to use the Flux CLI to look at the cluster and see what's going on. Okay, so let's start first by creating a Flux customization object in my staging directory. And what this does, it tells Flux, hey, apply whatever is in this top level directory called infrastructure. So let me also create the infrastructure directory. So I have this one here, and inside is another directory called Kyverno. Now, how can I install something from a repo that I don't have control over? There are basically two options. I can go to the Kyverno repository, get their install YAMLs from there, and copy them in my Fleet repository. But if I'm doing that, then every time there is a new release, I have to keep tabs on it. I have to, copy paste everything back, and so on. Let's say I trust the Kyverno team to test their releases, and I want to, instead of doing all this copy paste thing, I want to use their repository as the source of truth for when deploying Kyverno. So how can I do that? First, I'm going to create a Git repository object that points to the Kyverno GitHub repo. So if we look here, what the Flux command generated is, as I said, a Git repository custom resource that has here an URL, which is the Kyverno repo. And here is the interesting part. So instead of reconciling the Kyverno manifest from a branch, I'm going to use Git tags in the Semver format. And here I define the Semver range. And what this does, it tells Flux, hey, look at all the Git tags in the Semver format. And if it matches this expression, let's say there is a new stable release, pull that release inside the cluster. Right, so let's commit these changes to my main branch. Okay, I have committed my changes. Now, if I'm going to look at my cluster, Flux get sources, for example, all, I want to see all sources. I see that I have only one source, which is Flux system, which points to my repo. Now I can tell Flux to pull the latest commit that I did. And one command is Flux reconcile source git Flux system. And this is telling Flux, hey, pull the latest version. Now, you don't have to run this command unless you do demos like me. Flux will periodically scan the repo for new changes. And this configuration is here when we set the interval, and here is 1 minute. So if I would have waited 1 minute, Flux would have pulled those changes on its own. Now, if I run the get sources command again, I see that now I have a new Git repository defined on my cluster, and Flux has pulled the latest stable release of Kyverno from their repo. And here is the revision. The revision is composed out of the branch name or the tag name and the actual commit that's being pulled in the cluster. So now I have the source of my main repo, my Fleet repo, and I've also added some other external repo on my cluster. Now, if I'm going to look at the namespaces, there is no Kyverno namespace, right? Because I haven't told Flux what to do with this source. How can I tell Flux to act on it is through a customization object, the Flux customization object, and let's create it inside my repo here. Okay, so I created a new definition under Kyverno. So I have the source. Now, using the source, I'm creating a customization object that takes this source Kyverno. And I'm telling Flux, hey, apply the manifests at this path definitions release. That's where the Kyverno manifests are. Reconcile this on the cluster every 10 minutes. So what this does, let's say Flux applies the Kyverno manifests as they are in the source, in the Git repo. Then someone from your team with cluster admin roles goes in there, does a kubectl edit of some Kyverno object, let's say the deployment or service or the webhook or something like that. Flux every 10 minutes will check your cluster state and it will correct that divergency. If you edit something, Flux will undo it. And there is also a catch to this. Flux under the hood uses kubectl and the three-way merge algorithm. So it will only override what things are defined in Git. If, let's say, you have an array list, a list inside some definition, and you add an item to that array, Flux will not override it. Let's say you add a new environment variable. But if you change an environment variable that's already defined in Git, then Flux will override that, that particular setting. So, okay, we've generated this file. Oh, one more thing here, you see that there is a validation field inside the customization. What this tells Flux is, hey, before you try to apply any manifest from this path, do a dry run apply first and check if there are any things that the Kubernetes API will reject. Let's say maybe you have some custom resource in your Git repo, but there is no custom resource definition on the cluster, right? Turning on validation means that the commits that are made in your sources, in your Git repos, are atomically applied on the cluster. And validation is what makes this happen. If anything is wrong in your manifest, no matter how many there are, nothing will get applied. That particular commit contains something invalid, so the cluster state will not move to that commit at all. If you disable validation, then what Flux will do, it will no longer do the dry run. It will try to apply. Some things will get applied, others wouldn't. So you'll get up in this state where some parts of the latest commit are in the cluster and some aren't. So there are two options here for validation. One is client-side validation, and the other one is server-side validation. So you can set here server. And when you use the server-side validation, you also trigger all the webhooks that you have installed inside the cluster. So for example, let's say use a Kyverno policy to block pods that are running as root, or they are running with inside the host network. You'll not get a rejection when you do a client-side dry run, but if you do a server-side run, all the webhooks will be triggered and you'll get that message, hey, you are not allowed to do that. Otherwise, it will just fail when Flux tries to apply it. Okay, so I'm going to push this change and see what happens. Going to tell Flux to synchronize again. So there are two ways on triggering a reconciliation manually. You either can tell Flux, hey, pull the latest version from Git, and what happens is that source controller pulls the latest commit, and if there is something new to what's already in the cluster, it notifies all the other controllers. Or with the CLI, you can do Flux reconcile a particular customization. And here you can say with source. And what will this do is first, it pulls the source, it tells source control, hey, fetch whatever is new there. Then immediately it tells the specialized reconciler, in this case, the customized controller, apply it right now. So let's say the apply will happen a couple of seconds faster if you use this command than the other one. But in the end, everything is event driven inside the GitOps toolkit. So any kind of change will notify the right reconcilers to act upon it. Okay, so we have the new revision. Now, if we are going to look at all the customizations that I have in my cluster, I see now that I have this kernel customization that has applied this revision. So I should see kernel namespace. It's there. If I do get pods, see that the kernel webhook is up and running. So this is how I can install infrastructure items. What's important note here is that when Flux reconciles this customization, it will do it under the cluster admin role. Why do we need cluster admin? Let's look at kernel. So if we go to definitions, release, we have here install YAML, and we can see that it has namespace, custom resource definitions, webhooks, and so on. So for example, to install a custom resource definition, you have to have a cluster admin. A restricted account that can only target a namespace cannot create such a global resource. So right now, by default, Flux reconciles things under cluster admin, but I'll show you how we can change that, and I'm going to talk a little bit about the changes in the future to this behavior. Okay, so now I have my my infrastructure set up. Let's say I want to install an application that belongs to a particular team. Let's say we have a dev team that's in charge of developing apps, and the Kubernetes manifests for installing that particular app is in their own repo. So it's not a repo that I own, but is also not a repository from outside, like it's in my organization. But still, I want to enforce some boundaries around what the dev team can do to my cluster. And let's say my app that I want to deploy does not need to create any kind of cluster-wide resources. My app is made out of deployment services and so on, which can be restricted to a single namespace or multiple namespaces. And I'm going to use demo app that I wrote and maintained for a long time, Spodinfo. And I have here, so let's assume this application is developed by some team, and I want to take from this repository a directory that contains the deploy manifest, and I want to install it on my cluster. And Podinfo has a bunch of options of how you can deploy it. For example, here is a customized overlay that contains a deployment spec. It's a simple deployment manifest, an horizontal pod autoscaler, and a service. So I want to configure Flux in such a way that it will watch this directory inside this repository, and it will reconcile everything from here on my cluster. But I don't want to do it on my default namespace. like there is no namespace specified here, so it will go to default. Maybe I don't want to do that. Don't want to install apps in the default namespace because that's, I guess, quite bad. Don't use the default namespace. Create namespaces for workloads. So one option is I'm going to talk to the dev team and ask them, hey, can you put here a namespace, let's say apps, right? And they can do that change for you. And then you will be configuring that particular synchronization. But let's assume we don't want to change anything in our app repo. We want to make this change in our fleet infrastructure. Me as a platform admin, I decide where the apps go in which namespace. So how can I do that? First, so I'm going to go back to my fleet repo here. And first thing that I will do is I'm going to create a new top level Flux customization for my apps. So I'm saying, hey, apply whatever is in the apps directory. Now let's create that directory. I'm going to create apps pod info, where I'm going to configure how that particular application is going to be installed and reconciled on my cluster. But I don't want to use cluster admin when I'm applying manifest from this particular repo. So Flux allows you to map teams repositories to an identity inside Kubernetes. And there are two ways of defining identities in Kubernetes. One each is through a service account, and another one is through a Kubernetes user. I'm going to use the service account. So I'm going to run this command, Flux create tenant. I'm going to name my tenant dev team, and I'm saying, hey, the dev team owns the namespace apps, and export this as a definition. And let's see what the create tenant command did. So if we go here in the apps directory, we see that there is a new YAML called dev team, and the Flux create tenant command created all these Kubernetes objects for me. It has created a namespace, has added a label, so with a tenant, so we can easily query with kubectl which namespaces belong to which tenant. And it has also created a service account for me in the apps namespace called dev team, and a role binding that grants the service account access to the apps namespace, nothing else, only to this namespace. Now, if a tenant, your team, let's say, deploys apps not in a single namespace, but multiple namespaces, the create tenant command accepts multiple namespaces, and it will create all this boilerplate for you. Of course, you can go in here and fine tune the role binding. You can do whatever you want here. This is pure Kubernetes RBAC. The Flux CLI just gives you a quick way of provisioning tenants, but this is not something specific to Flux. This is pure Kubernetes role-based access. Okay, so I have created the namespace and the service account. Great. Now, going to register the pod info Git repository in my cluster. Let's do this. Okay, so inside the pod info directory, now I have a Git repository that points to my repo. And let's say we want to synchronize not with Semverse this time. I want to synchronize with a branch. with the master branch. And I want to I want to pull from this branch every 30 seconds. Of course, you can set up here whatever interval you want and so on. Okay, let's first push this. Great. Now tell Flux to synchronize everything. Okay, now let's look at namespaces. Look at namespaces, see that, okay, the apps namespace has been created. And if you look inside of it, you'll see the service account, the role binding, and so on. Now let's look at sources. Now, if you do Flux get sources all, we'll still see only two sources, because unlike kubectl that defaults to the default namespace, the Flux CLI defaults to the Flux system namespace. But in here, in my definition, I haven't created the source in my in the namespace meant for platform admins. I've created this source in the apps namespace. So if we want to list all the sources from everywhere inside my cluster, I can do get sources all namespaces. And now I see, okay, have this source registered, and it has pulled this particular commit. Of course, there is still nothing in the apps namespace because I've just registered the source, right? Now, I want to apply all these things and modify the namespace. I don't want to deploy podinfo in the default namespace. I want to deploy it in the apps one. So how can I do that? I have a create customization command that tells Flux how to reconcile podinfo. Let's run this one. And let's look what it has generated. So I'm using this time the Git repository source. I have here defined health checks. So Flux, after it applies everything, it will also wait for the deployment rollout. If there is an error, if that deployment doesn't roll out, Flux will trigger a Kubernetes event. And you can also configure external notifications to Slack, Discord, Microsoft Teams. You could also write back to Git as Git commit status. And all of that is made through Flux notification controller. We'll probably talk about that later on. But the idea is you can tell Flux to look after the workloads that are supposed to run, and Flux will be aware if everything goes wrong. And we support here any Kubernetes kind that's compatible with a library called kstatus. And so you can use all the native Kubernetes resources, config maps, secrets, custom resource definitions, and so on, but also other custom resources like the Flux custom resources or the Keptn ones or Knative and so on that subscribe to the kstatus conditions. So you can, if your custom resource exposes a ready condition, then kstatus will look at that. And there are other conditions that you can use to better integrate with kstatus. So the idea here is that the more custom resources will adopt the upstream way of verifying if something has been reconciled on the cluster, the better the Flux integration will be, because it will know how to verify all of those. Okay, so this is about health check. I've told you about the source. Now, there is also a property called target namespace here. And what I'm telling Flux is that no matter the namespace that is set in this path, maybe the customized overlay sets its own namespace, or like in my example with pod info, there is no namespace at all, so it will go to default. Target namespace will basically create a patch, and will set that namespace for all the manifests that are reconciled from here. And of course, I've enabled validation, and I've also set up a timeout for my health check, because this can take a long time, and you should be setting timeouts for this. Okay, let's apply this one and see what happens. Okay, if we tell Flux to reconcile again, so I don't have to wait. Okay, let's look at the Flux customizations in the apps namespace. Okay, we see that it has applied the latest version. Now, if we look at the pods in there, we should see 2 pods, because replica is set to for pod info. Now, what happens if I'm going to the, let's say I'm the one of the dev teams, one of the devs of pod info, and I'm going in that repo because I have access to it. I can push anything I want there, and I'm going to go there and create some cluster role binding, or I'm going to add namespaces there, then delete them, and so on. What will actually happen is nothing. The pod info customization will fail, and will say, I don't have enough permissions to change anything outside the app's namespace. How have we enforced that is through this field here called service account name. Like for deployments or pods or anything like that, you can specify a service account name for a particular Flux customization, and this one is mapped to the dev team. If we look at here at the dev team definition, we see that, okay, there is a service account called dev team inside the app's namespace. And that's why the reconciliation worked. So what Flux is doing when you specify a service account name, Flux, instead of using the cluster admin to apply the manifest, it will use a Kubernetes impersonation. It will find this particular service account. If it exists, it will use this service account identity when it does the apply, the delete, the health check. Every single operation in this customization will run under this service account name. And this is how you basically can define tenants and give them identities inside the cluster, then match some particular source, some particular Git repository. Now, there is a proposal in the Flux organization to also add a different option where Flux, instead of impersonating just service accounts, Flux will also be able to impersonate Kubernetes users. And in a way, impersonating users makes way more sense when you talk about tenants and repositories, right? You want to, service account is something made for machines, but in this case, you may want to tell Flux to run a reconciliation, to run the synchronization for a particular user as that particular user. So in the future, we are working on this as we speak. There is a pull request in customized controller where you can, there is a new field called principal, and you can say impersonate a particular user. And what we are thinking is when you provision a namespace, we'll create that user automatically in that namespace, and Flux by default, when it reconciles a customization in a namespace that, let's say, is not Flux system, it's any other namespace, it will look for that user, even if you don't specify. So in a way, it will enforce this role-based access on everything it does, and that's something it will happen pretty soon. We've been debating this new approach to multi-tenancy for months now. We came to a conclusion that offering this other way of impersonating users is a better mechanism than just service accounts. You will still be able to use service accounts if you want that, but you'll have yet another option. Okay, so I have set this up. Now I can change the target namespace, but what about other things? What if I want to change some other property of pod info? How can I do that? The Flux customization supports inline patches, and like a customized config that you place on your file system and you run, let's say, customized build for it, you can specify strategic merge patches or JSON patches and so on. Flux builds on top of that feature and allows you to do things like this. So here we can add a strategic merge patch for the going to delete the namespace, is not needed, for the pod info deployment. And let's say I want to set up security context for my application. My dev team is not aware of this. They don't know which user they should be choosing, which file system group, and so on. Maybe I have a kernel policy that actually blocks pod info from being deployed on the cluster. Maybe you want to enforce things like run as users and run as group. So instead of going into the app repo, changing all these things there, you can basically create here an overlay and mess up with the initial manifest. Is this the best approach? I think for small changes, it can be super useful. Let's say you want to add security context everywhere to every single workload for a particular customization. That's simple enough to create an inline patch. But if you are changing a dozen things, then you should be using a customized config and place that customization.yaml file inside your repo and import patches from the file system and so on. This is a feature that's more about, I want to do this change, I want to enforce this change anywhere. I don't want to create any customized overlay in my fleet repo. So you can do this kind of inline patches. So let's see if this works. Going to push this change. I'm going to tell Flux to sync again. Okay, let's look now at the pods, see what's happening. Okay, so what we see now is that, okay, there is no change in the original repo where all these manifests are coming from. There is no change in pod info. But because I've added an inline patch, it tells Flux, hey, the source didn't change, but how you should reconcile it, the policy of reconciling it, that changed. So redo the apply. And this is what's happening here. The pods are recreated, and if we look at the pods, see, we look at this one. We should see here the security context that I just patched. So these properties are not in pod info in any way. Like this has no security context on the pod, right? So with this approach, I can onboard applications. Then I can restrict what an app repo can contain with Kubernetes RBAC. I can then assign a service account and in the future a Kubernetes user to the reconciler. And I can also make patches to the upstream manifests. Are there any questions so far? Let me check Slack because I probably can't hear anything. Let me check questions. Okay, one question is, what approaches are people using when your organization needs a higher SLA on the Git repo provider than it gives? Okay. Yeah, that's a good question. Like when you define your cluster state in some Git provider, let's say GitHub, Azure DevOps, whatever, then any downtime of that particular service could have major implications on your deployment pipelines. Now, what we are doing with source controller is the fact that we connect to the source. We take the latest commit or whatever you specify there, your Git tags and so on, and we create a cache inside your cluster called an artifact where we store everything from your Git repo. So let's say the GitHub goes down, or there is a network connection between your cluster and GitHub goes down. That doesn't mean that, let's say, manual changes are not being rolled back on your cluster. Doesn't mean that customization reconciliation doesn't happen. You'll see an event from source controller. Hey, I can no longer clone the repo. Here is the error. I don't know, TCP timeout or whatever it is. But all the other things will keep running. The customizations will keep reconciling and so on with the known last state. Now, when, let's say, GitHub goes back online, source controller will recover, pull if is there something new, and that will be applied. So what we are trying to do with source controller in this approach, where we decoupled the reconciliation side from dealing with sources, is we are trying to make Flux more resilient to outside issues like, okay, my Git goes down. Now, another alternative to Git, and that's new, that's only in the latest Flux version, is the ability to synchronize with, let's say, buckets, being a streaming or whatever. Why we've implemented that is because usually buckets are stored in the same region, in the same zone with your clusters. So they are closer to your cluster. That means less latency, and they are distributed globally. So those type of services are likely to have a better uptime than Git repos. Now, if you use buckets, you lose some things from the whole GitOps thing. For example, you can no longer verify authenticity using commit signs. You can no longer say, I want to go back to this particular commit, right? It's whatever is in that bucket is applied. We create a checksum for everything that we find in the bucket, and that's the, let's say, the ID of the artifact that's being pulled. But yeah, these are currently the two options that we have. Okay, let me go forward. Okay, another question is differences between image repository and image automation. Okay, so going back a little here, have a slide to explain that. So how image automation works? We have, as I said, two controllers. One is called the image reflector, and the one is called the image automation. Image reflector connects to image repositories. So you create an image repository object where you say, hey, this is my image URL. Here is the Docker pull secret for it. Connect the registry and pull all the container image tags that are available on that repository. Then you have a different custom resource called image policy, where you tell Flux, hey, from all these tags that you found on the image repository, you tell Flux which one you want to look for. And there are a couple of options here. For example, you can use Semver range. Let's say you tag your image tags, you tag your images using Semver. So you can create an image policy and tell Flux, hey, if a new tag is pushed, a new container is pushed to the registry, check if the tag matches this Semver range, and if it's a newer image from what we are running on the cluster, then notify the image automation controller. The image automation controller has its own configuration called image update automation, where you tell Flux how to apply changes back to Git. So the image update automation points to a Git repository and to image policies. So what the image automation controller does, if there is a new image tag that matches a policy, it will clone the repo, goes to scans all the manifests in your repo, finds where it needs to bump the image tag, it writes that to the manifest, and then it commits and pushes those changes back to the repo. Now there are two ways of doing this. You can have this fully automated, where the image automation controller will push changes to the same branch, or to the same branch that's being used by Flux to reconcile the cluster. So it will be automatically to change the image tag. Source controller detects, oh, there is a new manifest, pulls the manifest, then customized controller applies the manifest, and this is how you roll out a new image controller version. And the other option is you can tell the image automation controller to push these changes to a different branch than the one that you use for synchronizing. Now, that branch doesn't have to exist. Image automation controller can also create branches for you. And using something like GitHub Actions or GitLab CI or something like that, you can open pull requests from that particular branch where Flux has pushed the change, a pull request for the branch that's being synced. And this is how you can manually approve all these changes. You'll be reviewing the pull request. You see, okay, Flux wants to bump all these versions. You merge it, and only then that particular change will get applied. Okay. Also on this topic, are there some nice ways to integrate the image update automation into CI? Thinking of something like Dependabot. Right. So, of course, you can definitely use Dependabot or any other bot that you are writing to patch manifests in Git. You don't have to necessarily use what we have built here with Flux. I don't know if Dependabot knows about image registries, repositories, policies, and so on, but I'm guessing you could definitely write some bash script that does it. We are offering this as a optional feature to Flux, but definitely you can do it. You can do the band manually. You can do it with other systems that have write access to your Git repo. Can those changes happen in files that won't end up in the cluster? Right. So because all these controllers they work independently from one to another, you could, let's say, have some ephemeral cluster, some kind cluster, for example, where you define image update automation, image policies, and image repositories, and so on. It doesn't have to run on the same cluster where you do the reconciliation. So you can have this the automation part running on a dedicated cluster, or I don't know, kind cluster in GitHub CI or whatever, and these controllers will write back to a repo, and from there it gets synchronized. So you don't have to run them all in the same cluster. Or another approach is you can have a dedicated cluster for image automation that patches manifests in different repositories. Maybe you have a dedicated repository for staging and a dedicated repository for production. You can have this kind of automation running anywhere where is a Kubernetes cluster. Okay, so there is also a question around image automation and namespaces. We require right now for all these objects, all these 4 objects here, the repository, the policy, the Git repository, and the image update automation to be stored in a single namespace. There is no cross namespace reference between these objects. So if you want to update something in the apps namespace, you have to create these custom resources there, right? And it also needs the image pull secret. So you have to bundle all of those in each namespace where you do the automation. There have been many discussions in Flux how we can make this work better, where you eliminate a lot of duplication. Maybe I don't want to create all these things in each namespace. I want to use it in a single namespace and so on. But then you have to copy all the image pull secrets and so on. Now with the new multi-tenancy proposal, if you look in there at the comments, I made a proposal where a Git repository or any kind of source, a bucket or whatever, can have an access list defined in there. And then the image update automation could refer a Git repository in a different namespace, and the controller will check, am I allowed to use this repo? And the access list on the repository itself will enforce this kind of cross namespace access without breaking multi-tenancy, right? Because if we just allow an image automation to reach out to any Git repository in any namespace, then you could see how a tenant could gain write access to another tenant's source. So that's why right now everything is limited to a single namespace, but we are working towards a solution where we allow cross namespace reference, but in a safe way where the owner of the source, the owner of the Git repository, explicitly allows which namespace, which tenant can use the source that he or she created in a particular namespace. Okay, let me check for other questions.
Hey, Stefan. It's Scott. I wanted to
Okay,
help.
doesn't look like it.
Oops. Oh.
Going to show you one more thing, how garbage collection works. Hey, Scott.
Hey, can you hear me? Can you
Going
hear me?
to stop sharing a little so I can fix my audio. 1 second.
How about now? Is it okay?
Yeah, I can hear you now.
Oh, great. All right. I just wanted to note that there were a few other questions in Slack you might not have seen, and just help a little bit with that. I can also repost them in Slack if that's easier for you than stopping the screen share and talking here. What do you think?
Yeah, it's okay. I can look them up now without sharing my
Okay.
screen.
Okay, cool. I can pop off my video then. I just wanted to help you or pass you some questions if that would be helpful. Thanks. It's really interesting so far, by the way.
Thank you.
Yeah.
Okay, so one question. Are there Terraform or cross-plane controller plugins to infra provisioning? I know that crossplane has custom resource definition controller, their own CRD controller. So yeah, you could place those. Maybe I'm mistaken, but if I remember correctly, crossplane offers such a thing. So you can place the crossplane custom resource for a particular infrastructure item inside your inside the repo where that Flux syncs. So it will apply it, the cross-plane controller will react to it, and it will create that particular infrastructure. And then you can use Flux depends on relationship to say, hey, I want first all these infra items to be created first. Maybe add a health check to it, so you can actually, Flux can actually see, okay, everything in there, all that infrastructure is up and running. Then Flux will move to Kubernetes things like deployments, ingress controllers, and so on. That's one thing I didn't mention in the demo, but when I've created the apps customization, I've told it, hey, this app customization depends on the infrastructure customization. And what that happens is, let's say you delete the cluster that you have reconciled, or something really wrong went there. You recreate the cluster using the same repo. Then Flux will install all things in the order that you have described using the depends on relationship. So you can say things like, I want my policy webhook to be installed first, verify that the webhook pod is running, and only then apply other things. So all these other things are subject to the policy, and the policy has been applied first. And this also works not only at install time, but also later on during the life cycle of your app. Let's say you have an app and a database. You want to update the database first and then the app. If you push a commit that changes both things, and you have a depends on relationship between the application and the database, what Flux will do will first apply the changes to the database customization, let's say, or maybe you have a Helm release or other things. It waits for that particular workload to be rolled out, to be healthy, and only then proceeds to the next step. Let's deploy the app or run the migration and so on. So you can imagine how you can define like a dependency tree between infrastructure and apps, and maybe only between apps themselves. We support this kind of dependency structure between Helm releases as well. So let's say you work with Helm releases and you have a bunch of those, you can specify in which order they should be installed. And yeah, that's all about depends on. Can maybe share my screen back to show you. So inside the repo here, if we look at the apps customization, we see that here we have a depends on relationship and tells it, hey, I'm depending on the infrastructure, and the infrastructure is here, right? So it will first apply this one. I can also add health checks here. Let's say I want to verify the Kubernetes pod is running, and only then the apps will be reconciled. And every time you make any change to your Git repo, the depends on is calculated, and all the things are applied in that particular order. So it's not only about install time, it's every time you push a change, all these changes will be executed like this. Now, if a dependency doesn't work, maybe the deployment fails, nothing else will be applied, and all its dependents will pause, will wait for that particular workload to either be healthy, or maybe you do a new commit, you fix that thing, and then it will resume working. Let me check other questions.
Hey there, I have a few other questions that I saw. I'm not sure. I may have missed them, Stefan, but do you want me to read a few of these out?
Yes, please.
Okay, great. Well, one is someone asked, now I know this may not relate to what you were just talking about, but it is related to your talk. The person, Dimitri, was asking, yesterday I was interested, how can I use tenant abstraction? What is it for? And may I ask about a clear description? Oh, sorry. Asked about a clear description and still can't get a clear understanding of it. I thought that might be, you might want to address that. If it's too far off from what you're talking about, we can always do that one separately.
Yeah, I mean, the idea of a tenant in Flux is just a way of defining some identity inside the cluster that matches something from outside. As I said, in our current implementation, a tenant is reflected by namespaces, service account in each namespace, and a role binding for that particular service account, right? So in the create tenant command, just generates all these things for you. And the idea here is that you want to restrict access of what things can happen in a repo, and what are those changes, how are those changes reflected inside the cluster. Like if you don't set up any kind of service accounts or role binding or anything like that, what the tenant could do, let's say they add a namespace definition that matches some other namespace, which is not theirs, and then they will delete the namespace from their repo. What will happen? Flux will actually delete that namespace from the cluster, and then it will recreate that namespace because, well, it's defined in another repo and so on. So to avoid all these conflicts and to put a boundary on what a repo can contain and restrict what kind of operations are translated from manifest to actual things inside the cluster, this is the Kubernetes way of doing it, right? You create role-based access and you define bindings for it, and you bind it to a service account and in the future to a user.
Cool. Hopefully that helped. Hopefully that helps, Dimitri.
Maybe that question was before I did a demo.
maybe, but at least it's good to give a little extra clarity. Yeah. So I know you mentioned something about this, but I don't know if it was fully discussed. Peter Z asked, are there Terraform or cross-plane controllers / plugins to GitOpsify infra provisioning?
Yeah, I answered that. So as long as there is some controller out there that has a custom resource that defines how the Terraform stuff should be applied, or how the cross-plane definition should be made into reality, then yes, you can use it with Flux. We ourselves we don't have our own Terraform controller, we don't have our own cross-plane controller and so on. Don't think those are in scope for Flux right now. What we want to do, what is our, let's say, roadmap, by the end of the year, we want to release version 2 GA. We want to, before that, we want to have all our APIs stable, deal with any bug that there is there. So in terms of new features, you will not see so many new features in the coming months. We are focusing on making version 2 as stable as possible before the GA release. There are many discussions on Flux GitHub. So we use GitHub discussions to debate features and so on. There are a couple of good proposals, like, okay, people want to have some controller that listens to pull requests. Once a pull request is made, Flux should pull all the changes from that pull request, maybe create a cluster using cluster API, and run all those changes there and write back to the pull request API, whatever is there, GitHub, GitLab, whatever. The result of, hey, you've changed that, I've created a cluster, I've run your changes and it broke, or it works, and so on, right? That's one thing that could be in scope for Flux. We are not working on it at the moment. Other things are stuff like manual gating, where you don't want to use pull requests for some reason. You let everybody push things directly to your main branch. And on the Flux side, on the cluster side, you want Flux to notify, hey, there is a new change, should I apply it? And you or someone else manually, you tell Flux, yes, apply it, right? So that's a manual gate proposal there with a specialized controller that deals with this and so on. Also around the manual gating, like people say, hey, I want to disable all my continuous deployment pipelines during weekends, right? Or no deploy Friday, no, all that nonsense. Yeah, so the manual gating could have like a time span where you can say, okay, for this particular period of time, we completely freeze the reconciliation of the cluster to the last known state, and we don't take any more changes. Once the window has expired, only then we resume operations and so on. And yeah, these are all nice proposals that we are looking into, but there will not be working on any of those in the nearest future.
I think we have 2 more questions before we transition into the DJ desired state and the panel, excuse me, not panel, but the discussion. One is any plans for implementing diffs for Helm releases? This is by Eugene Polienchko.
Yeah, this is another interesting topic in Flux around diffs. So there is currently a pull request in customized controller that implements diffs for using kubectl diff. And this is more about making the notifications better. Like we try to eliminate things that Flux itself, the changes that Flux makes to the manifest, and only send the notification, hey, this is what changed, by eliminating those. Because, for example, Flux garbage collection, how it works, it labels all objects. So the Kubernetes API will say, everything changed because the checksum label has changed, but that doesn't mean you actually made that change in your repo. You change only one file, but the whole thing has a different, like the whole thing has a different checksum, right? So we are someone is contributing this to customized controller, and we'll probably have it in Helm controller at some point as well. But it's more about notifications than blocking the reconciliation. What I understand from the diff request is that you want to be presented with a diff. Flux should not actually apply any change. You should approve that diff, and only then Flux will apply. For that, we need a UI, and there is a lot of work around the Flux UI. Right now, the Flux UI is all about observability and showing you what things are reconciled in the cluster. But maybe at some point, the Flux UI will be that tool that can show you the diff and give you some kind of mechanism where you can approve or block a particular change. Yet again, this is not something that will happen this year, if you ask me.
Okay, and the last question is, it's by Daniel. Can we see your dog, Stefan?
My what?
Your dog. You have such a cute dog. Or am I going to disappoint the audience if your dog's not around?
It's not around. She's
Oh. All right, we'll have to send out.
playing.
We'll send out pictures to Slack. How about that?
Okay. I can do that.
And I pasted the link that you were just describing to that PR into Slack as well for anyone interested, and we can follow up on the Helm diff topic in Slack as well. Stefan, thank you so much. This was so interesting, and there were many people commenting, and thanks a lot. This was great.
Thank you very much for being with me here. Take care. Bye.
Thanks. Bye-bye. All right, we're gonna get on now with again with DJ Desired State, the most GitOpsy DJ name ever. Check Slack for anything upcoming around this time period.
Свою жизнь для тебя превратил в цветы. Миллионы, миллионы, миллионы алых роз. Из окна, из окна, из окна видишь ты. Кто влюблен и всерьез.
seems that I can almost touch your soul. Good morning, you look so lovely. And with your soft hands spread against the pillowcase, sweetest of you surrounding me. It seems that I can almost touch your soul. Good morning, you look so lovely. And with your soft hands spread against the pillowcase,
Lale sümbül boynun eğik, kurt kuzuya kem bakınca köye döner nazo gelin. Yavru ceylan gibi kaçar, seke seke çaydan geçer. Nazo gelin ayağına takar hal hal. Ayağında gümüş hal hal. Ayağında gümüş hal hal. İnce nakış gümüş hal hal. İnce nakış gümüş hal hal. Yavru ceylan gibi kaçar, seke seke çaydan geçer. Nazo gelin ayağına takar hal hal. Beyaz kocaman bir duvar, çıplak bir çıplak, çıplak bir çıplak. Üzerinde bir merdiven, yüksek mi yüksek, yüksek mi yüksek. Duvar dibinde bir ciroz, kuru mu kuru mu kuru. Bir herifler elleri, kirli mi kirli mi kirli, kirli mi kirli mi kirli. Tutmuş bir çekiç bir çivi, sivri mi sivri mi sivri, sivri mi sivri mi sivri. Bir büyük yumak gazetecim, zorlu mu zorlu mu zorlu. Çıktı merdivene derken yüksek mi yüksek, yüksek mi yüksek. Mıhladı sivri çiviyi, tak tak tak tak tak, tak tak tak tak tak. Duvarın tepesine çıplak bir çıplak, çıplak bir çıplak. Attı çekici elinden, dışarılarım düş. Kalktı çiviye secimi, uzun mu uzun. Astı ucuna çirozu, çirozu kuru mu kuru. Astı ucuna çirozu, kuru mu kuru mu kuru.
Hey, that was so great. So lucky to have 2 days of DJ Desired State. How's it going, Damani?
It's amazing. It's amazing. Well, one, I want to shout out a DJ Desire State Flux shirt today. I just noticed that we're in the store. I didn't get my order. I gotta figure that out.
Yes, yeah, that was a new thing. And that's a good call out because to remind people that Flux is an incubation. That's one of the things that comes with being an incubation. And we're definitely on our way to graduation as well. So if you don't know, Flux CD not only is in the CNCF, is an incubation and going toward graduation right now, but was also in the adopt category. In fact, we're really excited if you saw Scott earlier. Scott's on our team and a Helm maintainer, and only Flux and Helm were in the adopt category from the CNCF Tech Radar review for CI/CD. So that was really exciting to see that recognition and the great work that not only has the team been doing for Flux on the engineering side, but you see DJ Desired State, Daniel and Stacy, our community managers who've been helping out, and we have a lot of great maintainers from different companies and contributors. So it's really, really exciting to see that. And one perk, like I said, you get to see Flux swag in the CNCF store.
Listen, out of everything you just said, Tomo, that's all that really mattered. The swag in the store.
Yes.
But
And in
listen,
fact,
I'm really pumped up about the excitement yesterday. I mean, to have our cloud providers jump on board, showing their support for GitOps, to have so many great customers come on board and really tell their story and talk about their journey with GitOps thus far has just been really amazing. I think even the start of today to have Stefan start off in our pre-show doing a deep dive hands-on into Flux has been really beneficial just to start kick off the day. So I'm pumped. What about you?
yes, great stuff. Yeah, and to review, if anybody missed yesterday, no worries at all. This is a 2-day event, but I think actually what we normally do is we have the live stream on YouTube. So there's a link for yesterday's stream, and then we have a link today. So thanks for joining us. And so we leave that up for maybe like 24 hours. That way you get the full experience of the music and all that. And then later, Stacy will be editing these out for our playlist, so you won't miss any of these talks. And so overview, as I kind of went through yesterday, this is the second time that we're doing the GitOps Days NA. It's actually the third time that we're doing the event because we did an EMEA event in the fall. And last year was sort of, hey, it's COVID times, let's put this online event. We know that people are kind of hungry for seeing material and seeing talks about GitOps. So that was sort of the ideation and putting it out there, everything from intro to GitOps and what the principles are to seeing different people being able to move the needle forward with GitOps in their company. And this year, yesterday was day one, and it was really great to see such a huge advancement in just 12, 13 months, right? From last
Yeah.
year, where we have many more major companies not only showing how they're doing GitOps, they've clearly moved the needle within their company, and they're really, telling people like, really take advantage of this. This is really a necessary thing that you need to do for business value, for team value, for technical value, for transparency, et cetera, within the company. And that GitOps is really being pushed now. We're not like a company that coined the term. We're part of the GitOps working group that's in the CNCF. Cornelia Davis, our CTO, talked about how the DevOps forum is also involved in sort of putting out publications out there around GitOps. And then today you'll see, last year was sort of this event we put together within the company. This year we did a call for papers. So you'll see so many amazing technologies and companies represented here, open source, proprietary, a range of things that people are offering that go around this new movement that we're moving forward around GitOps. So today is a really, really exciting day of great talks.
And folks are already asking what's going to happen next year, Tomo. I'm just letting you know, folks are picking me, asking me what's happening. So we got
Yes.
to put some thought to it.
Yes, and we've already been thinking about how great it'll be if we can all meet in person, and we'll have Daniel Day DJing, and then that's pretty much going to be the whole show. We'll be like, oh, forget the talks. We'll just listen to music. No, will be amazing. Imagine where we're going to be in 12 months if we've moved so much forward in the last 12, which is a great segue to this opening panel that we have, because I think many of you are thinking, maybe Damani, you get these questions like, what's so new about GitOps? A lot of people are like, we've been doing this before. We've done versions of this. And is it just this fancy new term? We were watching a great Twitter feed of people like, is GitOps just marketing? And in a lot of ways, obviously, the fact that so many companies are all saying GitOps, I think they're seeing the value of using that term. And hey, you know, there's no problem in developing or leveraging that for your marketing needs. However, I think Justin Cormack yesterday, who's in the CNCF and at Docker, really, I think, kicked off a great starting point of seeing how certainly there's always an evolution and there might be some repetition, but we didn't have all these technologies 10 years ago or even 5 years ago. We didn't have them in the place that they were in these previous timeframes. So we thought it'd be very, very valid. It's a totally valid question for people to ask. So we wanted to kick off today with a panel with great people who will represent these different positions on, you know, what exactly is the reason that GitOps is so vibrant and exciting right now, and why people are really focusing on it. What's an evolution from the past, and you know what's different, and what's maybe a continuation in the same. So we're really, really excited to have these great panelists. That's moderated by Cornelia, who will have come on first. Maybe you want to introduce your panelists and share with us how you're looking to have the conversation go. We can have the other panelists join as well, but I thought
yes, please
have you introduce them.
Sneha and Kief, do please join us.
Yes, I'm sure that they'll. If people don't know who they are, they'll explain their reasons. And we're really excited for this. So thanks you both for joining, and thanks Cornelia for moderating. And we will hand it off to you.
All right, thank you, Tamao. Damani. All right, so good morning, everyone. Thank you for joining us on day 2 of GitOps Days. I'm so delighted to be able to kick off the day again today with this panel. And so without opining too long on that, let me just jump right over to our panelists and have them introduce themselves. And then I'll talk a little bit about the program for the next 25 minutes or so. So first, I'd like to have you, Sneha, introduce yourself. Please tell our listeners a bit about yourself.
Sure thing. Well, thank you for having me here. My name is Sneha Rao. It's spelled and pronounced the same way. And I am a product lead in a team called Core Infrastructure at Spotify. My team is responsible for building and managing the service platform, as we call it, that powers thousands of features and millions of users and their experiences. So think of our team or my team as a microservice architecture within Spotify. And while developer productivity is my team's top priority, we also counterbalance all of the productivity measures with cost, reliability, and latency in mind. So we're constantly making those hard choices, and infrastructure is the key. And finding ways to unpack that, unlock that is how we do it. I've been working in infrastructure as a service and IaaS for pretty much my whole career. I've worked at Comcast, a NASA data center, and New York Times. So ask me anything. I'm here.
Wow.
All ears.
Excellent. Thank you. All right. And Kief, can you please introduce yourself to our listeners?
Sure, thanks. And yeah, thanks for inviting me to participate in the panel, which should be good fun. My name is Kief Morris. I work for ThoughtWorks, so I'm a consultant. I head up our global kind of cloud and infrastructure engineering community. I also wrote a book on infrastructure as code, published by O'Reilly. I've actually had 2 editions. The second edition came out just at the beginning of this year or end of last year. So I was interested in the evolution of infrastructure as code and how we do this stuff. I've been working with clients at ThoughtWorks for more than 10 years now, and in other companies before that. And it's always just kind of struck me how the tools and technologies emerge, and people try to come to grips with what are good ways to use these tools, what are effective ways to use them. So certainly between the 2 editions of the book, which were about 4.5 years apart, a lot changed. A lot's changed in that time, and a lot is still changing. So it's quite exciting to kind of talk with you about where things are going and may go.
Excellent. So for those of you listening in, you might notice that both of our panelists come from an infrastructure background. They have a focus on optimizing the way that infrastructure is done to Sneha's point, enhance developer productivity. And so we do, this is GitOps Days. So we spent some time yesterday talking about, the GitOps and supporting the application developer directly in the way that they have their software development lifecycle. But here we're also talking about how does GitOps play into the whole platform that supports those developer activities. So that infrastructure platform. So you did, like you said, you literally wrote the book on infrastructure as code, Kief. So can you maybe start out by giving us just a high level summary, first of all, of what were the goals of infrastructure as code? Even if they weren't clear at the very beginning, what are the things that infrastructure as code is delivering now? And what are kind of the key practices, if you will, in a nutshell?
I think infrastructure as code kind of emerged from the ideas of thinking about how to make environments and infrastructure more consistent, where we used to and often still do build and manage environments by hand. Things get very messy, and especially when you think about that kind of path to production of going from development to testing to staging to production or whatever you may have. Differences between those environments, causes a lot of friction and makes things take a lot longer, and the experience very poor. So, I think infrastructure as code for me in the early days was about how to smooth that out, and in order to do that, it was about thinking about if we can define our infrastructure as code, then that means we can take tools and practices and so on from software development and figure out, well, how can we use these for our infrastructure? So things like testing and so on. So I think that's been kind of one of the drivers for me personally. I've always kind of really focused in on like how do we take agile engineering practices in particular to our infrastructure code. So how can we do things like test-driven development for our infrastructure code? Can we use pipelines to deliver changes to our infrastructure as code, and all that kind of good stuff, and then design patterns. How can we build as infrastructure projects get larger and larger? How can we manage them more sensibly by drawing from things that we may have learned in areas like, say, microservices?
Awesome. Now, Sneha, you called out developer productivity, developer enablement right from the beginning. And I love what you just said, Kief, about environments being more consistent. I will share anecdotally with you all. My son, 26 years old, he's a software engineer early in his career. He is at an organization that has not nailed that. And so I'm constantly getting these texts from him that say, damn it, it runs on my colleague's machine, but it won't build on my machine. So no consistent environment. And it's brutal. It hits the developer productivity and also morale. It is just so frustrating when you can't make progress because it just won't build and you don't have consistent environments. So tell me about how you're realizing that for your developers. And I know a little bit about Spotify and the development practices there. And I think you really have achieved that, optimizing the developer workflow through the work that you do. Can you tell us a little bit more about that?
Yes, I think one way to describe our world is to just unpack the target audience that we think of from an infrastructure team perspective. So let me describe feature developers and a segmentation that we have drawn in order to improve that experience. There are brand new engineers like perhaps your son who has just started off in a workforce in a new company, in a new ecosystem. And they find themselves not having a lot of tribal knowledge to work off of, and having to build and understand practices from a few threads of golden path tutorials and some knowledge tidbits that their teams may share with them. What we've realized, the biggest hindrance for productivity in their case is that uphill battle of learning a new environment and a new ecosystem. So even if we have this environment created, the way Spotify develops and deploys and runs their code is quite unique. And you cannot expect somebody coming from the outside, net new, to understand that. So a way to sort of address that is, and I think Kief kind of alluded to it, is building design patterns. taking an engineer who is hired to build features to enable the business to focus on just that and not have to worry on infrastructure details, the nuts and bolts and the configurations and the specific panel adjustments that need to be made in order to make sure that their code works in the cloud as expected. That's some of the low variance work that my team, core infrastructure, is really well positioned to take. So we sort of create what we call blueprints or architectural patterns to enable these common design patterns. Another persona is the more experienced engineer. They've been around. Spotify is about 15 years old. They have years of experience on their hand. They have tons of tribal knowledge at their exposure. They're used to working with infrastructure. They're used to having more controls. Well, what we find in their particular scenario is that it's actually quite counterproductive to give them all those controls. Because when it comes to moving applications from one domain to another, an example of that is moving a language platform, like moving from one version of Java to another, or moving from Python language framework, or moving from like an Oracle database. These are migrations that are require a lot of work. And the more susceptible or the older the application, the more dependencies that those applications have over time. So for them, the biggest hindrance is moving and shifting to stay in sync with the best practices that infrastructure teams create. For that particular persona, we have created a program called Fleet Management, where we take away all those operations and we manage them declaratively. We use infrastructure as code. We have a mechanism to manage configuration, and we manage all of that through declarative infrastructure that we've built over time. So now all of this sounds pretty complex. I shared a lot of detail, and I recognize that sounds like, all right, that worked for Spotify. How does that work here? Well, I think the context matters, and which is why I'm diving into the details here. I think it matters. And in our particular scenario, and I'm hoping that maybe this is helpful for those who are listening, is that we've created our own open source development portal. It's called Backstage. And that is where we manage these workloads. We manage the tooling to support fleet management. We manage the patterns and the designs in one seamless interface that all developers share. So as we grow and scale up the number of engineers in the enterprise, we're 7,500 employees. We need to have a way to replicate what works and deprecate what doesn't. And this seems to be working really well. And it's an open source project, so everyone has access to it.
Okay, excellent. Now, I'm hearing both of you talk about consistency. Consistent operational practices, consistent development environments, and those types of things. Now, I work for Weaveworks, and we talk about GitOps, and that's exactly the theme that we talk about as well. We talk about the consistent operational practices. We talk about empowering the developer, about not burdening them with certain details, about having the platform team, or as you're calling it, the infrastructure team, codifying the best practices and those types of things. So is GitOps the new infrastructure as code? Is it infrastructure as code versus GitOps? Who wants to start?
I'll talk about that.
Great.
So I think it's interesting when I kind of see infrastructure as code and GitOps in the same way that I see like Agile. If you look at Agile as software development, there are kind of specific ways of doing Agile, specific kind of methodologies. So think about Scrum, think about Kanban, think about some of these kind of things where Scrum is not Agile. Well, it is not the only way to do Agile. It's one of the ways you can do Agile, right? And these different methodologies tend to focus on different areas and different aspects and different problems. So Scrum tends to be a little bit more on how to manage projects and so on versus, say, extreme programming, which is a little bit more on the kind of testing and developer practices. And so you can often combine them, right? So with infrastructure as code, I kind of see they're kind of different schools, maybe you could think of it that way, schools of thought on that. So GitOps is one, and the one that's obviously going gangbusters, or we wouldn't all be here with so much things that people have to say about it, yesterday and today. You also have, you could say, immutable infrastructure. People, still talk about a fair bit. There's the stuff that the likes of Pulumi and Amazon and HashiCorp are working on, where you're kind of using more programming languages to more either dynamically generate code as with the CDK, or dynamically generate infrastructure as with the kind of Pulumi approach, which I think are quite interesting. I think all of these kind of different approaches probably have different areas and different strengths where you might bring them to bear. So GitOps is obviously highly relevant in the cloud native world, and with systems like Kubernetes. And I do see people applying it, or variations of it, let's say, to other types of infrastructure code as well, even outside of cloud native infrastructure.
Yeah, and so I'll admit that in the pre-show, in the chat we were having pre-show, Sneha talked a little bit about the practices that she uses at Spotify, which she talked about a breadth of different things, including GitOps. So maybe Sneha, you can share some of those comments with our listeners now to give a perspective of the broad range of things that you do and how you see GitOps in relation to infrastructure as code at your organization.
Absolutely. So one of the things I said before the pre-show is I don't necessarily see these as two separate pieces. I don't see it as GitOps versus infrastructure as code. I see these as a very complementary ecosystem. In what's worked at Spotify, and I recognize that that's not necessarily true for every enterprise, but if at our scale and companies similar to our scale, like Shopify, Netflix, I do happen to talk to them all, what we're finding is consistency in those frameworks is very important. So GitOps adoption is pretty mature. And so is the practice of writing infrastructure as code, managing your configuration, setting up declarative infra pipelines, and managing through all of that through a continuous integration and continuous deployment framework for a consistent and high feature velocity outcome, so that the feedback loop of what works and what doesn't work, pulling back from rescoping what experiments and what bets are made, and when you make new feature releases as an application team, is very much dependent on the infrastructure and the foundation that it's built on. So if the foundation is not resilient to change and it cannot adapt to change by like a continuous feedback loop from CI/CD, then it's too brittle. And it just doesn't work. So the agility and the agile principles that Kief mentioned, I think it squarely applies to infrastructure as well. And it's something we live and breathe by. All of the teams that I manage, we all have agile as like a principle that we work within. So that's one more framework for how projects come in and for how projects are delivered against. And another framework is GitOps, and IAC just happens to be one of the pieces of that framework. At least that's the way, in my experience, that's how I've seen it.
Okay, now you've both talked about declarative configuration. So declarative is, I think, very central to this. It's part of what gives us that repeatability that we were talking about. And behind that, of course, there's automation. Now, one of the more interesting dialogues that we have around the GitOps is that we characterize the type of automation that is associated with GitOps as convergent automation. So we talk about these convergent loops, these control loops. And when we're applying it to Kubernetes, we've got controllers that are running in an infinite loop. And not all of infrastructure as code ascribes to this convergent, constantly, adapting way. Infrastructure as code, arguably, you could check in something into, let's say, a Git repository, and it runs some script. And to some extent, that's definitely infrastructure as code. So can either of you or both of you maybe remark on that element that GitOps brings of, no, we actually insist that this is done in a convergent mechanism. We know that things are always changing and we know that we're constantly adapting. Any comments on that element of GitOps, that convergent automation?
Definitely talk about it, but I don't want to kind of always jump in and
Go for it.
Okay. Yeah, I think it's in the first edition of the Infrastructure as Code book, I used the phrase configuration synchronization. I think I called it. I think Martin Fowler on his Blicky had an entry about that. And so I think it's like I see kind of a couple different patterns for how people use infrastructure as code in order how they synchronize. One is kind of I think as you allude to the old school way of just treating it like a script. So I've seen people using even like Chef and Puppet code to say, I'm going to edit the code and then I'm going to apply it when I need to make a change. Then I'm not going to apply it again until the next change that I need to make. And then I've used the term, what did I call it? There's a kind of synchronization gap or configure, where the longer it's a kind of a, whether it's infrastructure as code or automated tests or those kind of things, the longer you go between running your automation, the more things are going to diverge and the more likely it is to break. And it causes this kind of thing of people get very afraid of their infrastructure as code tools because it's like, oh, we run it and it breaks all the time. And it's like, well, it's because you if you do just continuously applying and reapplying it, then that avoids that, because if something creeps in to make a difference, it either eliminates it and brings it back into sync, or it tells you right away. And obviously you need to have good mature monitoring and those kind of things to let you know. So I strongly advocate that approach. I think an alternative, if you think about the immutable infrastructure that I mentioned before, is kind of completely different, which is to say we're not going to change an existing instance. We'll always build a new instance and then swap it out, which is an approach. I don't see that getting as much traction, certainly not as widely as other modes. But it's like, to me, I think about the kind of three different, I guess those as three different ways that you can apply infrastructure code.
Yeah, interesting. So Sneha, you've been talking about you have a number of different practices, GitOps only being one of the practices in infrastructure as code. Do you have, like, where do you use this convergent automation, and where does something like immutable infrastructure, or just immutable infrastructure perhaps together with an imperative script, do you have certain use cases where one is working really well, or you've started experimenting? Can you talk a little bit about that?
Absolutely. We've tried both. And our learning from the immutable form of operations is, it goes back to a point I was making earlier, it's too brittle. It doesn't scale. And so the convergent automation seems to be the direction we're heading in. I can't say that the verdict is out yet, because this is a constantly shifting world. And there are a lot of dynamics at play that perhaps we haven't touched on, which is worth noting. The concept of giving more control to application developers versus pulling back controls as it relates to infrastructure. Where do you draw that line? And if you don't draw a very discrete line on where does application development start and end, and where does infrastructure start and end, then is that a healthy environment? Because cloud native providers are providing solutions that are function based. They're moving towards serverless. So to not be thinking about those like the future, which is very much current, it's kind of pigeonholing yourself to just one set method. So you have to kind of think about the dynamics, and which is why I don't have like, oh yeah, this is the only way sort of response to this question. But I'm just opening up the discussion to the fact that there's several factors to be considered as we define what the future is.
Yeah. Okay. And that future is a really great segue. I love that you brought up, functions as a service as well. So excellent. Well, believe it or not, our time is already drawing to a close. That feels like it was about 2 minutes ago that we started. But in closing, I would love for each of you to tell us as a community, what do you need from GitOps? Where can we go from here? What's the most compelling thing today? And what are the biggest gaps? Who wants to go first?
I'll go ahead if we keep our pattern.
Sounds good.
So I think for me, the issue I often see, so at ThoughtWorks client, projects that I've kind of come across with our clients, a lot of times I think what tends to be missing when people talk about GitOps, first of all, a lot of people say they're using GitOps and they're not, particularly the convergence thing that you're talking about. So they're saying, oh, our infrastructure code is in Git, and we have branches for each of our environments, and we use pull requests to manage changes to them. So we're doing GitOps, but they don't, they still only kind of apply it, when they're ready, right?
Yep.
And so that's one issue. I think the other thing is to go to that thing with the branches is how do we manage changes, make changes across environments. So my understanding of GitOps, which is incomplete, I'll say, but is that it largely is focused on, I've got an instance, I've got an environment, and I've got the code for that. And as you say, it's declarative and it's continuously synchronized, and we're not kind of managing, we're not doing anything more interactive to make changes or to do, kind of maintenance activities. But then the question is, so when I want to make a change to infrastructure, let's assume that I want to put it in a test environment first and maybe progress it through different environments. How do we manage that? And this is where I run across a lot of messiness, because what tends to happen is people have essentially separate copies of code, separate projects for each of their environments. And that doesn't really help with that whole consistency thing we've talked about. You're essentially not really doing anything different than we did in the old days of building each environment by hand and then saying, I'm going to make the change here, and then once that's good, I'll make the same change here and hope I don't mess it up. Or remember the differences. Remember, when you copy your code or merge your branch from one to the other, don't forget you have to change all the strings from dev to staging, or else it'll blow up, right? Or whatever it is, right? And
changing namespaces, that's one that bites me all the time. Changing a namespace somewhere. Yep.
So I'm really keen that we have ways to manage changes, ways to manage our code, to think about code as a reusable thing the same way we think about our application, right? We don't have a separate project for our application code for each environment and then copy and paste changes between them, or even merge changes and branches between them. We build an artifact and then we promote it. Now, artifacts for infrastructure is not really so much a thing. I mean, I've certainly done it, and I know lots of people who do it. But yeah, I think this is an area that, as an industry, whether it's GitOps or other approaches, I think we need to get better at, because like I said, on projects that I've been on with our ThoughtWorks clients, this is so common to run across people with these just kind of chaos between their environment configurations.
Yep. Excellent. And Sneha, last word.
Word.
No, not one word. Last words, plural.
I think what I can leave the panel with is some of the struggles that we see, and perhaps there are solutions that can be thought of by the hive minds here. Environment changes in the context of moving from one cloud to another is something we constantly think about. We through acquisitions, we have inherited companies and workloads that run in various different clouds. So to create an environment where everything is decoupled, that the code can come from an application developer, the configurations can be managed through a seamless operations model, and that the environment is a plug and play. Conceptually, that sounds great. In reality, it isn't. It isn't as seamless as that. So multi-cloud operations through frameworks like GitOps is something that I think is fairly nascent and can improve. And then another area that is fairly foundational is moving between language frameworks. How does a company at our scale adopt and stay relevant across the fleet? We haven't found a way to automate that function, but if we could, it would be brilliant.
Yeah.
So.
Yeah. Well, thank you both, because I feel like you just wrote our backlog for the next year or so. So I appreciate that feedback. Thank you both so much for joining us here today. I think this was just a phenomenal way to kick off the day. There's lots more great talks coming, but once again, thank you for joining us and sharing your very real world perspectives with our audience. Thank you so much.
Thank you so much. I was typing in the Slack channel. Like, I love your very thoughtful responses. They're really, really helpful. And it's great to see other people complying. So thank you. Thanks for our great panelists. And now we'll move on to our keynote speaker for my morning and Katie Gamanji's evening. Thank you. Katie, are you there?
Hello, everyone. Yes,
hey.
I'm here.
Thanks for speaking. We're really excited. So yes, we've got Katie Gamanji here, who's from the CNCF. You're one of our three. We kind of, in the beginning when we were planning our 2021, sort of just put out a couple of the feelers out, and it was just took me later to realize, like, oh wow, we've got three people from the CNCF as our keynotes, and so I think that kind of also just keeps founding this idea, right? Like this is something that's really in the ecosystem and in the foundations and really growing. So I'm really glad that the CNCF has been behind this. And so thank you for speaking. I'm very excited to hear your talk. Take it away.
Thank you for having me. And let me start by sharing my screen. Yeah, cool. Hello, everyone. My name is Katie Gamanji, and currently I am the Ecosystem Advocate at CNCF, or Cloud Native Computing Foundation. As well, I am one of the advisory member for Keptn, which currently is a sandbox CNCF project. However, within my ecosystem advocate role, I wanted to mention that currently I'm representing and leading the end user community. And one of my responsibilities as well is to bridge the gap between the project maintainers and the practitioners of the community. I am working with OpenEK to make sure that open standards are used fairly across data, hardware, and software. And recently, I have been working with Udacity to create the Cloud Native Fundamentals course to make sure that anyone is able to onboard the Cloud Native journey. I have mentioned the end user community, and I would like to provide a bit more information about it. The CNCF end user community is constructed of more than 145 vendor-neutral organizations that use cloud-native technologies to build and distribute their services. This is the largest end-user open-source community that is out there, and it is at the center of CNCF's goal of end-user-driven open source. What it actually means is that we're looking towards these organizations to define the production experience, but at the same time to grow and further nurture these projects within the ecosystem. If you'd like to find out more information about our end user community, you'll be able to find more details on cncf.io/end user. We've recently completely redesigned the page, so you'll find more information of what our community does, and you'll find information on how can you join as an end user as well. Today, however, I would like to talk about GitOps, but more specifically how it unlocks a new level when we can use the GitOps towards the edge and infrastructure provisioning. And to do so, I'm going to start by talking or introducing the cloud-native GitOps tools. And here I'm going to usually emphasize the Argo CD and Flux CD. Then I'm going to focus on more realistic examples of how can we use GitOps to actual real case scenarios, such as infrastructure provisioning and propagation of the application to the edge. So in the first scenario, I'm going to talk about cluster API and how can we associate it with Flux CD to provision our infrastructure. And in the second scenario, I'm going to focus on how can we push our application to the edge by using a tool which is KubeEdge and the association of it with Argo CD. Before I move forward, I would like to introduce the ecosystem that allowed this GitOps strategy and models to be constructed or to appear within the community. Now, if we take a step back and look 7 years ago, the container orchestrator framework space was very heavily diversified. We had tools such as Sudoku Swarm, Apache Mesos, Chorus Fleet, Kubernetes, and all of them provided a viable solution to run containers at scale. However, Kubernetes took the lead in defining the principles of how to run these containerized workloads. Nowadays, Kubernetes is known for its portability and adaptability, but more importantly for its approach towards declarative configuration and automation. And we can even see this in numbers. Based on the State of Kubernetes report, which appeared in May 2021 from VMware Cansu, we can see that 65% of the organizations are using Kubernetes in production. But as well, we can see that the reasoning of using Kubernetes is that it provides an easy deployment and management of the resources. But more importantly, when we look into the feature of Kubernetes, we can see that more and more organizations are looking into building this multi-cloud strategy and how can they deploy Kubernetes in on multiple cloud providers. And this growing community has been extremely beneficial for Kubernetes because over time, multiple tools were built around it to extend its functionalities. And this created what today we know as the cloud native landscape, which resides under the CNCF umbrella or Cloud Native Computing Foundation. Now, at this stage, we can see that the cloud native landscape is quite expansive, and it offers multiple tools to extend functionalities and it provides different integrations. However, the community focused on how to enhance the developer experience while deploying cloud native tools. And here we have to redefine and create new processes to do so. And this is where the GitOps model appeared within the ecosystem. Now, when we refer to GitOps, usually this is a methodology that has the Git repositories as the source of truth for defining the desired state of the application. And by default, we have a few advantages. One of them is that we have a PR-based rollout. That means that the delta between the local environment and the production cluster is just 1 PR away. As well, we have the ability to have this automatic reconciliation. A GitOps tool usually watches a Git repository, and if new changes are identified, these are going to be extrapolated and applied to the cluster straight away. But more importantly, with GitOps, we have a version state of our cluster. That means we have historical data points of different versions of our manifest or application configuration, and we can easily roll back to those versions by using Git commands. Now, when you're looking into the cloud native ecosystem, the GitOps methodology is represented by Flux CD and Argo CD. Flux has been donated by Weaveworks and currently is an incubating CNCF project, and Argo CD has been donated by Intuit, which is one of our end user members, and currently is an incubated project as well, but it's undergoing the graduation vote, so hopefully we're going to see it as a graduated tool. By default, with Flux and Argo CD, we're going to have a bit of different functionalities. With Argo CD, we have support for multi-tenancy. That means that with one instance of Argo CD, we'll be able to manage the applications for different teams and domains. As well, Argo has support for multiple configuration tools, so pretty much how we define the state of our application. So by default, of course, we're going to have support for plain YAML, but we're going to have support for Helm customized JSONet. As well, Argo provides support for multi-cluster deployment. That means that with one instance of Argo CD, we'll be able to deploy our applications to clusters in different regions and even different cloud providers. And as well with Argo CD, we have the user interface or the UI, which means that in addition to deploying our resources, we'll be able to visualize them and have this graphical representation and even analyze or research the state of our resources. Flux, on the other side, is a more lightweight tool, and this is because it provides one installation per repository. So by default, we're going to remove the support for multi-tenancy. If you'd like to have support for or manage multiple applications with Flux, that means we're going to have multiple installations of Flux within a cluster. As well, Flux has support for multiple tools, such as plain YAML, Helm, and Customize. And what is different about Flux is the fact that it actually provides the support for automatic deployment of new images. So if you deploy your application using Flux, and if a new version of that image is available, Flux will be able to identify it and roll it out within a cluster. Now, at this stage, we have pretty much basic information of what the cloud-native GitOps tools are at the moment. And as mentioned, I would like to provide a bit more of a practical example of how can we use these GitOps tools. In the first scenario, I would like to focus on the infrastructure provisioning with Cluster API and Flux CD. Now, before I move forward, I would like to provide a bit more information about Cluster API, just to make sure that we have the terminology set up from the beginning. Cluster API is a tool that provides a set of declarative APIs for cluster creation, configuration, management, deletion across different cloud providers. Now, when we refer to a Cluster API, we refer to SIG Cluster Lifecycle, which had its first initial release in April 2019. Since then, it had 2 more releases and currently is in V1 Alpha Free endpoint. I've mentioned that Cluster API integrates with multiple cloud providers, and currently we have more than a dozen of them, from which we have some of the most popular cloud providers such as AWS, Azure, Google Cloud. We even have the initiatives to deploy it on bare metal through providers such as Metal Free, Packet, and association with Tinker. And we even have support for Chinese cloud providers such as Tencent, Baidu Cloud, and Alibaba Cloud. To understand how Cluster API works, supposedly we would like to deploy clusters in different regions, different cloud providers. The first thing that we'll need to do is to provision a management cluster. Now, for testing purposes, it is recommended to use Kind to provision this cluster, and Kind is pretty much a Dockerized version of Kubernetes. If you'd like to use Cluster API in production, it is recommended to use a fully fledged Kubernetes cluster, and this is because it comes with a more sophisticated rolling out strategy. Now, once we have our management cluster up and running, we'll require our dependencies, or the controller managers. And currently we have 3 sets of these controller managers, one for Cluster API CRDs, or customer resource definition, one for the bootstrap providers, and the last one for the infrastructure providers. Cluster API introduces 5 new customer resource definition, and we will need to make sure that we have a controller for all of them to add, delete, or reconcile any changes to these resources. The second set of controller managers are going to be the bootstrap provider, and this is the component that translates the YAML configuration into Cloud Init script, and it makes sure to attach the instance to the cluster as a node. And this current functionality is supported by kubeadm and Talus. And the last particle is going to be, or control managers, is going to be the infrastructure provider. And this is the component which really talks to the cloud provider API and provisions the actual infrastructure, such as instances, VPC, subnets, and so forth. And if you'd like to deploy a clusters in different cloud providers, you'll require the controller for every single cloud provider that you would like to use. Now, once we have our controller managers up and running, we'll be able to provision the target clusters. And these are going to be the clusters that we'll offer to the engineering teams to deploy their application on top of. And these are going to be the clusters that the customers will interact with when they use your products and services. Now, I've mentioned the Cluster API introduces 5 new customer resource definition, and this brings a new idea to the stage where we can think of our cluster as a resource, and we can completely define our clusters in YAML manifests. So to begin with, we'll require a cluster YAML manifest, which pretty much takes care of the networking components. We'll be able to specify the CIDR for our pods and any DNS suffix if we have any. With the cluster by default, we're going to have a control plane associated with it. Control plane resource has been introduced in the last release and pretty much allows us to have this declarative management of our master nodes. And of course, with the control plane, we're going to have the machines or the actual instances, which has the configurations very similar to a node. We are able to specify the version of Kubernetes or the instance type, the region that we would like to deploy this instance into. Now, once we have our control plane, we might require a data plane as well. And this is where our workloads are going to be deployed. With Cluster API, this is managed with a machine deployment. Machine deployment resource is very similar to a deployment. It's pretty much coming with a very powerful rolling out strategy between 2 different versions of machine sets. Machine sets is are very similar to replica sets. It will make sure that the amount of machine resources are up and running at all time. And machine again here is going to be an instance, but in this case, it's going to have a different label or a different role with the name worker. Before I move to the live demo, I would like to showcase the current setup that I have. So as I mentioned, with Cluster API, we can pretty much represent our infrastructure in YAML manifests. Once we have these YAML manifests, we'll be able to store them within a Git repository, which means we're going to have different historical data points of the version or the state of our infrastructure. In addition to that, we can add an extra layer of abstraction, which is going to be templating with Helm in this particular case. So I'm going to have a Helm chart, which is going to help me to parameterize some of the variables within my YAML manifests. And all of these components are going to be deployed using Flux. It is worth to mention that the cluster API components on Flux have been installed on the management cluster. So once we reconcile all of the resources that we have, we're going to provision the target cluster. So this is going to be the final result. Now, I have to disclose here that I've already provisioned the target cluster, mainly because it takes around 10 minutes to have it up and running. So in the demo, what I'm going to do, I will change the input file or the values file for the Helm chart, and I'm going to change the amount of worker nodes we have within a cluster. And these changes are going to be picked up by Flux, and we'll be able to see new nodes added to the cluster. But before I move to that, I would like to showcase the Flux CD resources, custom resource definitions or configuration that I'm going to use. Now, when working with Flux, we require two sets of configuration. One which is going to define the location of our manifest and where we actually store the desired state of our infrastructure. And the second set of configuration is going to be the release strategy, how we'd like to deploy these resources. In my particular example, I'm going to store my Helm chart within a Git repository. As such, my source is going to be a Git repository resource, which is going to be having the name cluster API, CAPI AWS. Now, in the spec section, I'm going to have an interval of 30 seconds. That means that every single 30 seconds, I'm going to look for this source and identify any new changes. And towards the end, you can see that we actually reference the repository, the actual full path of our repository with the name cluster API Helm chart, and we're going to check out on the main branch. The second set of configuration is going to be how we're going to release our Helm chart. Because I'm going to use Helm, I'll require to use the Helm controller, and in this case, I'm going to have a Helm release custom resource definition with the name copy AWS. In the spec section, again, I'm going to have an interval of 30 seconds to make sure that within 30 seconds, I'm going to be able to identify any changes and apply them. Now, if you look into the chart section, here's where we actually reference the source we've defined in the previous slide. So here we define the source of or specify our GitHub repository. But more importantly, we specify a relative path within this GitHub repository where the Helm chart is stored. So here we have it under the charts / copy AWS folder. And towards the end, you can see that we have a custom values file that we'd like to use for this Helm chart. And here I'm going to use the values-demo.yaml file. Now, without any further ado, let's actually see how can we provision this cluster, how can we make changes to our infrastructure using Flux. So to begin with, let's go to GitHub. So currently I have the Helm chart, and you'll be able to see those YAML manifests that represent our infrastructure. So for example, in the cluster resource, we're going to have the CIDR for our pods, and we're going to have for example, the control plane resource associated with it. Because we have a Helm chart, we'll be able to template some of the variables. As such, for example, here you can see that within the machine deployment resource, I am templating the amount of replicas I have, so the amount of worker nodes that I'm going to have for a cluster. And of course, with the Helm chart, we're going to have an input values file. Here I'm going to use the values-demo file. And we just have a Kubernetes, which is going to run in version 1.19. I'm going to have 3 master nodes, and I'm going to have 1 worker node. Now, this is representing our configuration. Let's actually look within the terminal how it looks like. So within the first half of the terminal, you'll be able to see the machines that we currently have. So we have 4 machines, from which 3 of them are going to be the master nodes, and 1 of them is going to represent our worker node. And towards the lower half of the terminal, you'll be able to see all of the logs that we currently source from our Flux source controller. let's actually make some changes to our infrastructure. So here, I would like to change the amount of workers that I have within a cluster. And I'm going to change this to 4, for example. With Flux as well, it's quite important to, especially when you're using a Helm chart, it's quite important to up the version of our chart. Otherwise, it's not going to be able to identify the changes within the chart. So if I do a git diff, the only changes that I've done was to change the chart version and the amount of replicas that we have for our worker nodes. I'm just going to commit these changes with a very meaningful message, demo, and let's do a git push. Cool. Going back to the previous view, at some point we'll be able to see that the source controller will pick up these new changes. We have the interval of 30 seconds, so there's going to be the maximum amount of time that we need to wait for it to actually identify these changes. So hopefully soon it will be able to see them, and we'll be able to see new resources over here. And if this doesn't work, I have the pre-recorded demo as well, so we'll be able to see it there. Cool. So we see it being able to identify those changes, and we see that 3 new machines are being provisioned at the moment, and these are in AWS. Now, if I go to AWS console, ideally here I should see 3 new instances that are initializing. So as you can see, 1, 2, 3 instances that currently are within the initializing stage. So if we wait for another minute, we'll be able to see these instances up and running, and this is pretty much how we'll be able to change and provision our infrastructure using the power of GitOps. We're not going to wait for this to get into an up and running state. Just going to go to the second scenario. Cool. Now, the second kind of scenario I wanted to present is how can we propagate our application to the edge using the power of GitOps. And in this particular case, I'm going to focus on KubeEdge and Argo City. Again, to begin with, I would like to give a brief introduction of KubeEdge just to make sure that we have the terminology set up from the beginning. So KubeEdge has been built upon Kubernetes, and it provides support for the synchronization of application, metadata, and networking between the cloud and the edge. Now, when we're using KubeEdge, we're going to have the ability to have this seamless communication between the cloud and the edge. What it actually means is that when you deploy an application, you just need to interact with the cloud component, and the request is going to be propagated to the edge, and it's going to be completely abstracted from the user. As well with KubeEdge, we have this edge autonomy. What it actually means is that if the cloud gets disconnected from the edge or if the cloud components gets down, the application on the edge is still going to be able to be running at all time without any impact. As well, KubeEdge has been designed to run in a low resource environment, such as CPU, memory, and bandwidth. When you're looking into the KubeEdge architecture, there are 3 main areas that we can identify: the cloud, edge, and the devices. Now, usually speaking, the edge and the devices represents the edge, the entire component. But because the devices are the physical components that are with the consumers, I still like to differentiate them as a separate category. Now, when you look into the cloud side, you're going to have a Kubernetes cluster up and running, and we're going to have the cloud core components installed on top of it. The cloud core components will communicate with Kubernetes API, and at the same time, it will make sure to proxy any request to the edge using a WebSocket. When you're looking into the edge, here's where we have the edge core components, and this is communicating or is integrating with a container runtime and is going to communicate with the MQTT client. Now, when you're talking about the edge, we still need to manage our containers, and this is going to be done by a container runtime such as Docker, Containerd, CRI-O, and Vertlet. And as well, if you'd like to synchronize the status of the actual physical device, we're going to use the MQTT client for these abilities. Again, before I move forward with a live demo, I'd like to showcase the actual setup that I currently have. So in this instance, I'm going to have 2 nodes. One of them is going to represent the cloud. The other one is going to represent the edge. On the cloud, I have the Kubernetes cluster up and running, and I have the cloud core components installed on top of it. As well, here I'm going to have Argo CD installed, and we'll be able to interact with the UI and to have this graphical representation of our resources which are deployed. On the edge side, I'm going to have the edge core components already installed, and I'm going to use Docker to manage any new applications that I'm going to have on the edge. That means that if I'm pushing any applications towards the edge, they're going to be managed as Docker containers. And again, before moving forward to the actual demo environment, we'll require to use Argo CD CRDs or customer source definition to define how our application is going to be deployed. So with Argo CD applications, we're going to have configurations for our destination, so where we'd like to deploy this application. We're going to have a source, so where is the desired state of our application. And of course, we're going to have a policy, which pretty much defines how we would like these resources to be deployed. So in this instance, I have an application CRD with the name Nginx Edge that is going to be deployed within the Argo CD namespace. In the spec here, I've trimmed the output for destination just to shorten the output of this YAML manifest. But in this case, we choose the destination to be our current cluster. In the source, we define where our manifests are stored. So here I'm going to have a KubeEdge Argo CD demo folder, and I'm going to store the YAML manifest within the manifest folder, and we can see this within the path variable. And towards the end, we actually choose a synchronized policy. And in this case, it's automated, which means that if we deploy any new changes to our applications, they're going to be applied straight away to the cluster. However, here we have the ability to choose a manual synchronization in case we want to validate the changes before applying them. So without any further ado, let's go back to the live environment. We can see that actually the instances that we've deployed earlier are up and running, but let's go to KubeEdge. So here, as mentioned, I have two instances. One of them is going to represent the cloud, and the other one is going to represent the edge. On the cloud side, we have a Kubernetes cluster installed, which means we'll be able to operate with kubectl commands. So if I do a kubectl get pods, for example, I'll get no pods at the moment, but I'll be able to issue kubectl commands. What I would like to showcase here is the nodes that I currently have. So you'll be able to see that I have two nodes. One of them is the actual master node, which was provisioned with the Kubernetes cluster. However, the other node is the edge node that we have been putting to the cluster using the edge core components. When I'm looking towards the edge, if I do a kubectl command, I'll be able to do nothing with it. And this is because on the edge, we don't have Kubernetes. We're going to have a container runtime engine. And as mentioned, for this demo, I'm going to use Docker. So if I would like to inspect any applications I have on the edge, I have to do a Docker PS. And currently, I have no applications deployed to the edge at this moment. So just as a quick overview, I have the application CRD here. And I would like to showcase that we have a destination. We just choose the current cluster. We're going to have a source, which is our KubeEdge Argo CD demo, and we're going to have our automated sync policy. And before I deploy that, I would like to go to the Argo CD UI. Currently, we have no applications deployed as needed. However, I would like to showcase what I actually have in the manifest folder. So currently, I just have one Nginx deployment, a very simple application, a deployment, which is going to have one replica, and is going to deploy an Nginx Alpine image. So without any further ado, let's go back to the terminal and apply this particular application CRD. So for that, I'm going to use a kubectl apply command and referencing our application configuration. Going back to the UI, already clicked on it, we'll be able to see that we have an Nginx Edge application. And if we expand it, we'll see a deployment with one pod, and it's already up and running. Now let's go back to our terminal. And if we issue a kubectl get pods, we'll be able to see that we have our application, Nginx application, which has been created 23 seconds ago. However, what is interesting is that when I get the white output of this command, we'll see that it has been pushed towards the edge node. So this already has been pushed towards the edge node, completely abstracted from the user. And we can further validate that by issuing a Docker command on the edge side. So if we do a Docker PS, we'll be able to see that we have our application here, which is up and running straight away. So this is how we can use Argo CD to enable the propagation of the application to the edge, completely abstracted from the user. And going back to my slides, this is pretty much what I wanted to showcase to you today. We started by talking about the cloud-native GitOps tools that we currently have within the ecosystem, and we talked about tools such as Argo CD and Flux CD. But more importantly, we showcased practical examples of how can we use these tools. In this case, we looked into how can we provision our infrastructure using Cluster API and Flux CD, and how can we proxy our application to the edge using KubeEdge and Argo CD. And this has been possible because currently GitOps is the moving force that redefines the deployment of cloud-native components. But more importantly, it is based on declarative, automatic, and reliable fundamentals. If you'd like to find out more about today's talk, I'm going to write a Medium article with more details where you'll be able to research some of these components that I've been talking today. And if you have further questions, I'll be able on social media such as Twitter and LinkedIn. Thank you very much and enjoy the rest of the conference.
Katie, thank you so much. That was a great talk. That was a great talk. Many folks that come in, obviously, come to us and talk to us about Flux, but also the obvious, question is, hey, Flux Argo. So I think you did a great job of explaining, some of the differences between Flux and Argo, but then also breaking down some easy to comprehend use cases. So thank you very much.
Thank you very much for having me. And another thing I wanted to mention is that we can completely interchange the way we use the GitOps tools. So you can use Cluster API and Argo, and you can use KubeEdge and Flux. So it's not just one tool that's working with the other. You can completely combine them and switch them. Depends on your use case. Just wanted to point that out as well.
That's great. That's great.
Awesome.
Thank you. And I hope that any questions that you may have for Katie, please drop them into the Slack channel. She'll be around to answer any questions. And I know that there are quite a number of folks that are interested in getting on the GitOps journey and understanding that the tools that are out there today for successfully deploying GitOps in production are Flux and Argo CD. And next up to the stage is Viktor Farcic, and really excited to have him. He knows the tools really well, and is quite active on YouTube and putting out a lot of educational videos and such. So I'm really excited to hear his talk as he tells us how to apply GitOps to infrastructure the real way, or for real. Viktor, how are you?
Excellent.
Good to see
Always
you.
good. It's immutable.
Indeed. Listen, the stage is yours. Thank you so much for joining us.
Thank you. So before I do the introduction and explain what I'm going to do, I'm going to execute a single command because it will take a bit of time until magic happens. So bear with me. I'm going to execute kubectl apply -- file name and then some YAML file, which happens to be called gk YAML. I will let that run in the background. It will take a couple of minutes, just enough time for me to explain what I want to do and so on and so forth. So infrastructure, right? Infrastructure as code. We are living in 2021. Everybody's defining their infrastructure as code. That's not a new thing. You're picking one tool over the other. I'm not going to enter into discussion which one is better, which one is worse. Just to say that basically all the tools in the market are now taking into account that infrastructure is defined as code, simply because everything is defined as code today. But I feel that we need more than what the, let's say, commonly used tools are bringing to the table, right? Yes, define infrastructure as code, execute some commands, some magic happens, things are created, deleted, updated, what's not. We do that. That's a done story. Now, what I think we need additional, right, are a couple of things. First of all, I would really like to see unification of the API. I use Kubernetes. Everybody uses Kubernetes. Why not leverage Kubernetes API for more than creating Kubernetes resources? And we've seen that trend for a while now. We've been using Kubernetes API to create virtual machines. We've been using Kubernetes API to manage Mac OS servers, right? And so on and so forth. So the whole idea is, hey, how about I do everything through Kube API, and that everything includes my infrastructure? How about I communicate with Kubernetes, tell it what to do, or not what to do. Sorry, that's bad. Not tell it what to do, but what is my desired state. And then it creates. Sometimes it creates pods, sometimes it creates clusters, sometimes it creates networking, and so on and so forth, right? Extend Kubernetes API to everything. And in this specific case, that everything includes infrastructure. And that, if we can manage that, right? If we can manage to enable our need to manage infrastructure to Kubernetes API, that means that we can leverage Kubernetes ecosystem, which happens to be the biggest ecosystem known to man right now, right? So if we can manage our infrastructure through the calls to the API, we can manage Kubernetes ecosystem. And that means that we can use all the good tools, all their favorite stuff. Doesn't matter whether that's Flux or Argo CD or Helm or Customize or Prometheus. Doesn't matter what it is. If we can make infrastructure definitions Kubernetes native, then we can leverage the whole ecosystem. And finally, the third thing that I think is kind of embarrassingly missing from the current landscape, and that's automatic drift detection and reconciliation, right? Same things that you're seeing in Flux throughout this session. Hey, there is the state, desired state defined somewhere. There is the actual state of something. How about we reconcile those two states the moment there is a drift, instead of waiting for somebody to push something to a Git repository, which might happen 5 seconds later or 5 days later, right? So Kubernetes API, Kubernetes ecosystem, and drift detection and reconciliation. If we can get, and by the way, the third one, we had it in the past. We had it with Chef, we had it with Puppet, but we somehow lost that ability in the meantime. So one potential solution to do everything we do with infrastructure today, the typical things, plus those additional potential requirements like Kube API ecosystem, drift detection, reconciliation, could be done, at least the project I know, is Crossplane. So what I'm going to show you is precisely that. I'm going to show you how we can leverage Crossplane to do the things that I mentioned before, the things that typically infrastructure as code tools do not do, and potentially tied to GitOps soon afterwards. So bear with me. I'm going to share my screen again. And let me check whether first the effects of this file were correct. So what I did when I executed this GK YAML, I'm going to show you definition. Basically, what I did is defined 2 different Kubernetes resources, right? I defined GK cluster. You can probably guess by the name what that something is. And that GK cluster, you can probably guess, will create a GK, in this case, GK cluster. It could be any other type of cluster or infrastructure resource. It will do it in certain location, US East 1, and it will create a node pool in US East 1B with specific name, some arguments like what is the minimum and maximum number of nodes, and so on and so forth, right? This is standard stuff. This is, if you ignore that this is YAML, this would be almost the same as what you would define in HCL if you would be using Terraform, or it wouldn't look the same, but conceptually the same arguments as what you would do in Pulumi, simply because most of those tools are using the same API at the end of the day, and then those definitions are reflecting that API. So I executed that. I created those 2 Kubernetes resources, and I did that in my Minikube cluster. So this is Minikube running on my laptop, right? It's not even a real cluster, or I'm not sure whether you call Minikube a real cluster, right? Now, if I go to my GCP console, you should see that this cluster was created. And actually, it wasn't created. It is still being created. Or maybe it's finished. Let's double check whether the cluster was created. Yes, it was created. And I have a cluster that is in US East region 1, US East 1 region, meaning that there are 3 or 4, I'm not sure how many, 3 zones, right? So it is a regional cluster spread in 3 zones. And it should work, right? If I go to nodes, I can see that I have my nodes created. But let me double check. Yes, but there seems to be missing 2 nodes, right? I have one node, and since this is a regional cluster, it should have 3 nodes because there are 3 zones in that region. So let me double check what's going on, right? Now, what's going on is obviously that in my YAML definition, I forgot to specify all the zones of the cluster, right? I specified only US East 1B instead of 1B and C and D. So I'm going to correct that. I'm going to save the change, and my cluster should now be corrected. Now, don't start yelling immediately, Victor, you're doing things through the web UI, you should do things as code. I'm doing this intentionally, and you can probably guess why. So in a minute or two, my cluster should now be running in 3 zones instead of 1 because I made a mistake. So let me just see. Let me take a look at what's going on, right? And I can see what's going on by executing commands. And this is now the same Kubernetes way of operating like anything else, like kubectl, get GK clusters. I can see that I have a cluster. It is reconciling. I can retrieve the nodes, node pools. Here it is. It is provisioning the node pools. And since I created my cluster using crossplane and then modified manually, which was a bad idea, but I'm going to get back to that. I'm going to retrieve the kubeconfig and double check whether everything is working. So kubectl get nodes, right? Oh, wrong command, nodes. Come on. And you can see that there are 3 nodes, right? There are 3 nodes because I, by mistake, created a single zone cluster, which is 1 node, and then I went manually to change my configuration through GCP console. And you can see by the age, right, that those 2 nodes are younger, like 10 and 17 seconds old, right? So let me see what's happening right now, right? And the reason why I want to see what's happening, there we go. The 2 nodes that were created were now were being removed from the node pool. And the reason why that is happening is because I broke the whole promise, the whole idea that my infrastructure should be defined as code, right? I defined my infrastructure as code, and then I went and did manual changes. And then Crossplane did something that similar tools in the space do not do. And that something is that it is constantly monitoring this desired state, in this case as Kubernetes resources, and the actual state. And as a result, it is doing more or less the same thing what Flux is doing, let's say, except that it is not monitoring Git repository, it is monitoring resources in the control type of cluster where Crossplane is running. And it said, hey, my cluster is not what you specified you want it to be. I'm going to revert to the changes that you did manually because that's just silly. You're not supposed to do that, right? So it is continuously monitoring the 2 states and making sure that the desired and the actual state are converged. Now, as a good citizen, what I should really have done is, instead of manually changing something from the web UI, from the console, I should have changed the file. I should have changed the definition in a file that defines that, and that is stored in a Git repository. So I'm going to do that right now, right? I'm going to go, and actually I already did that. I'm going to show you the changes that I'm going to do to the cluster. GK region is 1 and YAML 1 other, right? So I already prepared in advance a file that has a correct number of zones. And all I need to do really is to push this. What I could do right now is execute kubectl apply, just as I did at the very beginning of this session, say, hey, this is the new definition of the cluster, and Crossplane would pick up those changes, do whatever needs to be done, and my cluster would be regional finally. But that's not a good idea either, right? I shouldn't be doing that, because all the GitOps principles and the talks that you're almost certainly have been hearing in the previous session, what we can do better. And that better means that we can define everything, all the Kubernetes resources, we can keep them in Git, right? And we can let Flux or Argo CD monitor that Git repository and do what needs to be done. So instead of us executing commands, we're pushing changes to Git so that we always know what our desired state is, and we can collaborate and do all the jazz that we normally do. So that's what I'm going to do right now. I'm going to move this file, GK region, to the production directory. Production directory is where I configured my Argo CD to monitor, right? That's one of the directories in my Git repository that it is monitoring. So I'm going to add that change. I'm going to commit that change, and I'm going to say, I'm too lazy to think what to write here. And I'm going to push that change to a Git repository. Now, while that is happening, and everything I'm showing you right now is going to be based on Argo CD, the logic is exactly the same, right? No differences between Argo CD and, from conceptually at least, between Argo CD and Flux. And what is happening is that here I have my Argo CD UI. It has only one application. It has production environment with only one application, which is Argo CD itself, right? So it is managing itself. And right now it is waiting. I think that I configured it by default to synchronize Git repository with its own internal database every 3 minutes. So I'm going to speed up. I'm going to press sync. You should never do this. Never press sync. The Argo CD will do the job for you, but I'm too lazy now I'm too impatient to wait for it. So I did it. So what it did is that it synchronized my Git repository with its internal definitions, what it knows about the desired state. And if I go back to my console, it should probably start doing something. And that something should be that it should create all the missing nodes. kubectl get nodes. Let's see whether it is still not doing that. It will probably take a couple of more seconds or moments until it synchronizes. And from there on, once it's the 3 states, actually in this case, we had 3 states to be synchronized. And those 3 states is the desired state, which is Git repository. And the second state would be the internal state of the tooling, in this case, Argo CD. And the third state would be the actual state. And that actual state is in this case, is infrastructure. So once the first set of synchronization happens, once the Git and in cluster, where Argo CD and Crossplane are running, are synchronized, then Crossplane will take that as a new desired state. It will compare it. From there on, it will continue comparing it. Actually, it will be continuously comparing the 2 states, and it will detect that there is something wrong, that infrastructure is not as I want it to be, and it will create the nodes. And there we are. If I go back to my terminal, the missing nodes are there. It synchronized the 2 states. I combined Argo CD with what is it? Crossplane, GitOps all the way. And the only API I'm using, the only type of YAML I need to think about is Kubernetes. And that's my short pitch. I think that I'm just on time.
Viktor, yes, you are. So I think you're actually, I know because we started a few minutes late, so thanks for being so prompt. It's really great to see the comparison there. So yeah, and just a reminder to everybody, I apologize, we were chatting a little bit, so I lost track on whether there were questions, but reminder to everybody, please, yeah, go to Slack. In fact, I see a few. So Viktor, hopefully we'll see you there at the GitOps Days Slack channel to answer a lot of the questions that have come in. So it's great to see an active discussion. Damani, are you in? I think we're ready for a little bit of a break for with DJ Desired State. So to move my camera a little bit, where I'm in California where the sun moves a little bit now, so I'm a little close. But yeah, right now we have about a 15-minute break until we have some upcoming talks. Like I said, today was the day that most of our call for papers talks ended up, because day 2 is sort of more of the technical deep dives, and a lot of the great submissions that we got came in from them. So stick around. We've got a break in, and then we've got 3 different speakers who'll be talking about a variety of technologies. We've got Miguel, Fontanilla, and Jose Talavera. Actually, they're coming in second. And there's quite a bit of discussion in the background. I hope I'm not butchering his name. Jürgen Etzlstorfer. I was getting some help from Daniel Holbach there. Will be actually coming up right after the break, and then Giovanni Galloro. So stick around. I mean, between then, if you need a bathroom break or a tea break or something like me, we've got some great beats from DJ Desired States. So take it away.
So the bass is just wobbling away. I just can't find the beats. Dubstep, who cares? It's dubstep. Relax. that, steal money. That's that, steal money. That's that, steal money. That's that, steal money. That's that. That's that. That's that. That's that. That's that. That's that. That's that. That's that. That's that. That's that. That's that. That's that. That's that. That's that. That's that. That's that.
Kate, olala libana egolia golia sera pasio. Maya komela e kama kosomba sena mbongo. Kwanga yango yo kotulao. Nyama na zamba eko lukana ni akende koboba. Misina ebale eko lukana ni asola
Ugly idol, see yourself in the eyes of rivals, rivalries on the sea of title, repeating defeat the 66 Godard. We don't want to die without any scars. Found patience in the bazaar. We shine like the most common star. Still far, we are. I am two sides of the same coin, and that phrase coin to the death drives are the main point. You get no choice, old boy. That's a bold order. Cold quarter, white night, then a black day. They say always in, always on, all days. This game will stay the same, stay the same. From birth to hearse, no reversing, can't rehearse. Don't call the nurse in, only gonna make it worse. Get there first, don't get the curse, kid. Passive and active, past the impact of spirit in action. Split down the center of bodies is packed in. Two faces mirrored in fractions, bastard. back again. Grabbing the phone, restarting the engine, get back in the zone. Shout out to Rumble, we'll never stay humble. Two countries aligned, missing piece of the puzzle. That's double the danger and double the trouble. The whole team together, no breaking the huddle. Doubling down what we bet on a hustle. So underground, I'll sand, I'll channel the tunnel. I'm the wolf man with the moon out. Hear voices, too many, tune out. Stay way too close, need to zoom out. Got to reboot Batman with the boom pow. Let it breathe. Way too split than I care to be. I'm two pots, ketamine, one pop, every scene, but the benefit is the adrenaline is settling. Let it be. There's no such thing as a secret identity. I'm flexibly dexterous, flexing on all of the best and the rest. I'm swallowing enough. Still find life in a hollow stump. Still creating a vicious slump. Rows in the road, but enough's enough. Side of the light in the light of the dark. In a time when the market is missing the mark. In a world where commerce kills off art, but the other side rises, finds their fun. Switch up guns and stand and cruise. Doppelganger ancient leaves the news. Pay attention, catch the news. Two rows out, time to choose.
Thank you, Daniel, DJ Desired State. I hope you're all enjoying these breaks as much as we are enjoying Daniel wearing the Flux shirt, as we mentioned earlier. So yes, hopefully make sure everybody's got some time to get water. I know we're jam-packed with so many talks. We had so many great talks that we had to select from. Sorry we couldn't accept everybody because this is a 2-day event, but we'll see how things work in the future. But what we have today, we're very, very excited for all our many speakers. And next up, I've been working on this, Jürgen Etzlstorfer. I hope I didn't tangle your name too much. We're really excited to have you on board. Are you able to open your camera?
Think so. I am. Yeah. Hi.
Yes. All right. Great to see you.
Great
yes.
to be here. Yeah.
And thanks. Yeah. Thanks for submitting. We're really excited to see your talk on orchestrating SLO-driven multi-stage delivery with Keptn. A lot of hyphens there. And there's even a subtitle, Merging GitOps and Data-Driven Delivery. I think a very important topic. So take it away.
Thank you so much. Let me just start with sharing my screen here and probably go into full screen. And here we go. So thanks a lot, and thanks for the great music. It was really, really great to be there backstage and listen to the great music. So that really makes this event very, very special, I think. Yes, the title, you already mentioned, title is quite long. But I will go into everything into detail. I will explain everything that's written here into this in these 2 sentences. My name is Jürgen. I work for a company called Dynatrace, and I'm also maintainer of the Keptn project, which is an open source CNCF project. And today I want to talk about how to kind of merge the concepts of Keptn, which is more data-driven, event-based delivery, with GitOps tools. And with this, we can then orchestrate multi-stage delivery with quality gates based on SLO. So there's a couple of those big words, but I will go into all of them in more detail in the next couple of minutes. So let me start with basically with a very basic introduction of GitOps. So I know at the GitOps days, we don't need an introduction of GitOps, but what I really want to highlight here is the power of this concept, that it's not the software deployment is not about doing a kubectl apply on my dev environment, or even worse, on my staging or production environment, but it's the other way around, that it's actually the dev environment is looking for changes and then we'll pull the changes. And all the changes, everything that we want to deploy, all the configuration, this is in Git. Everything is versioned, stored in Git. And we have this as our single source of truth. I think that's the biggest power of GitOps. But what kind of we need in addition to this is some way how to manage our tests, performance tests, smoke tests, functional tests, how to do an evaluation of our tests. We might run tests for 2 hours, and then we have to figure out, okay, what is the actual data we need to evaluate if we can approve this, this version, and then actually apply this new version tag in our staging environment. Or that there are so many other things that are in the whole life cycle of our applications, and we have to figure out a way how we want to orchestrate all these different tasks. So what I want to talk about today is how we can, how Keptn concepts can enrich the GitOps experience to also orchestrate the testing, the evaluation, and automated or manual approval, and then basically based on the approval, rewrite the state in the Git repository, or write the new states to the Git repository for, let's say, a staging. And then again, the GitOps approach can do its magic and pull this this new change and apply everything in staging, not only the image tag, but of course all the configuration that has to be applied in staging and might be different from your dev environments. But this is the whole power, I think, of GitOps, then combined with an orchestration layer on top of it that can be data driven. And this actually already brings me to Keptn. This is a application lifecycle orchestrator, and there is more to it that I will go to mention in this presentation today. But the big part for this presentation is how to orchestrate the multi-stage delivery with GitOps tools, and also have quality gates that make sure that we do not deploy anything into production that should not go into production, because maybe the error rate is way too high, or maybe our new version is way too slow, and it would kill our clusters if a lot of our customers would use it. So this is the main part that I want to focus on, but there's more to it. We can even use Keptn for automating parts of the operations, where Keptn can automatically roll back by, again, setting an image tag that has been approved earlier and has been into the Git repository, and then the GitOps operator will again apply this, or by orchestrating also remediation action in response to any alerts that are coming in, and then orchestrating some parts of the remediation. So this is what can be done, and for today I want to focus how we can combine this all with the GitOps approach. So here on the more right-hand side of the picture, I want to focus on the small text here, on our favorite format YAML. I want to just focus here on how in Keptn we define a process and how we define an environment. And basically, we in this shipyard file, I have defined a multi-stage environment with dev and staging, and the whole delivery process with the deployment, testing, evaluation, approval, and the release stage to the next environment. And maybe you've already noticed, I'm not a native speaker in English. I am from Austria. We speak German, and Keptn for us sounds like the captain of a ship. So we also have a couple of those terms, like the shipyard that builds the environment. Is the definition of the environment, or we will hear later on the lighthouse, or some other terms like the captain's uniform, which is like what the captain is wearing, the tooling that is applied to Keptn, and a couple of those things to just be you have been warned now that there will be a couple of those expressions. But now let's take a look at the at this shipyard file. So we do have the deployment, we have a test, we have an evaluation, we have a couple of other different tasks. And the important part here is that these tasks, they will get sequentially triggered by Keptn, and the whole interaction between the different tools. And I've just put in here some example tools, like we can do it with Flux, for example. I just put it in here. So this interaction between those tools can work with cloud events. So for example, when Keptn wants to trigger deployment, let's say with Helm, it will send to the Helm integration, will send this event. And once this deployment is finished, it will return that the deployment is finished. And then Keptn can move on to the next stage and trigger the tests with JMeter, low-cost artillery, even with chaos tests, with Litmus, for example. And in this file, we do not define what is the actual test file or test configuration, but again, it's more about what is the test strategy. Same goes for the deployment strategy. Do we want to have blue-green or canary release? So this really defines the process and not so much the tooling. The tooling goes into another concept, which is the Keptn's uniform. And just on this slide, I've kind of combined those two a little bit. So I put here already the tools that can be used. And we can also see here that the Keptn part, that is really the built-in capabilities of Keptn for evaluation, for approval, and for release, where usually there is no other tool needed that can be done directly within Keptn. And for the other tools, Keptn does not want to replace any other deployment tool or testing tool. Keptn wants to integrate and use the power of GitOps, for example, of a GitOps operator, or the power of already established and matured performance and then load testing tools. So we do have this configuration here or definition here for a dev environment. And also here, a little bit below, we can see for a staging environment, we have also a sequence of tasks. And again, this is called the delivery sequence. It will be triggered once the delivery in our dev environment is finished. And we do have our deployment strategy. So we are able to change the testing strategy. I have here now performance tests instead of functional tests, but also that different tasks can be completely different. Just gives you an idea that you can really easily build multi-stage delivery with one simple file here. So let's take a look. How is this kind of implemented? The conceptual point of view and the conceptual architecture of Keptn looks like this, that we have the Keptn control plane in the Kubernetes cluster, and the Keptn control plane interacts with other tools via cloud events. So there is the communication going on back and forth from the control plane to the execution plane. And one of those execution plane services could be, for example, JMeter or artillery for executing the tests. It could be even some kind of a chat bot or notification service or a collaboration platform such as, let's say, Slack, listening maybe only for finished or successfully finished deployment events, or only for failed deployments, or only for needed approvals. So there might be all these different ways to interact with the control plane, and everything here is defined on cloud events, which is also in CNCF project. And we defined, I think, like 20 plus different events, how to control a continuous delivery sequence. And all these different tools, they can subscribe to these events, and then you will get notified if such event occurs, and they can act upon this event. And with this, Keptn can manage then multi-stage deliveries, even on one cluster or multiple clusters. Dev, staging, production. I have just here kind of the same example that I also had in the slides previously. So we can connect all these tools, but how does it look like? How does the deployment then actually look like? So we do have in Git, we have stored all of the configuration. So it might be a little bit small here, but we only need here for this first part, we actually only need here one line, and it's just called Helm here, or it can also be a manifest folder. So when it comes to the deployment, Keptn will have a Git repository where all the deployment information for one specific microservice or application is stored. And Keptn can also update this configuration. So it can act as a promoter from one stage to the other whenever there is a quality gate passed, for example. Or you could also just trigger a deployment by updating this Git repository. I've here the trigger deployment with a dashed line. So there might be integrations where Keptn directly triggers the deployment, such as with Helm, because it's not an operator and looking for changes. Or we can skip this part and we have some kind of GitOps operator like Flux listening or basically watching the Git repository, and whenever there's a change, then it will start the deployment. It will apply this change into the Kubernetes cluster. And once it's finished, let's say by rolling out the pods, it can inform Keptn, and Keptn can then move on to the next task in the sequence that we've seen earlier defined in the shipyard file. And the next task could be, for example, a test. So we can execute some tests here. And again, the high-level overview looks very, very similar to the deployment, because again, everything is stored in the Git repository. In this example, I have two different kinds of tests stored here for my hello service. It's a JMeter test and it's a Litmus chaos test. So they are stored in this Git repository, and the test configuration and the test files, they are then passed to the tool integrations of Keptn, to the Keptn execution plane, and then they can act. They can execute whatever they want to execute, like running the JMeter test or executing the chaos that is defined in the Litmus CRDs. So this is how Keptn can orchestrate these tools, because only when both testing tools are finished, then Keptn can trigger the evaluation. Again, it's not necessary to trigger the evaluation, but it's just when we recall the shipyard file that we saw earlier, it was a deployment, it was a test, and it was an evaluation, it was an approval, and then it was released. So the next part would be to do the evaluation. And for the evaluation, we again base everything that's needed for evaluation in the Git repository. We can even see it here. We do have the Prometheus folder, and we do have the SLO file here. For Prometheus, I think most of you can imagine it will be the configuration for Prometheus, how to query the data, but the SLO file, what is the SLO file? And let me just explain this. So Keptn uses SRE best practices. Basically, when you're familiar with the SRE handbook, then you might also be familiar with SLIs, SLOs, and SLAs. And we are using the first two concepts heavily in Keptn. The first one is the SLI. We can think of this as a metric. And the second one are SLOs that are, let's say, objectives for these metrics. And I do have an example also on the next slide, but also here that the metric could be the error rate of particularly requests like login requests. And the objective is then that this error rate has to be less than 2%, or must not increase more than 5% to the previous runs, something like this. And we can now define SLIs and SLOs again in a declarative format that we put into our Git repository. So for the indicators, it's basically a list and a key value for the name of the indicator and how to retrieve this the value for this indicator, like by a PromQL, for example. And for SLOs, we can then use the name of the SLI and define concrete objectives for our SLIs. Something like the success percentage of a probe has to be higher than 95%. So that means for a given time frame, the time frame that is evaluated is actually calculated by the length of the tests that were also orchestrated by Keptn. So we can exactly be sure that we are evaluating for the correct time frame. and we need a higher success percentage than, or at least 95% of success to get full points on this evaluation, or we would get like only half the points for it will be a warning if we cannot reach this 95%, but still we are higher than 90%. So this is how we can build quality gates, and this is a very, very simple example. It's actually a valid example. It will work, but of course you can imagine there you might want to have way more indicators and way more objectives for a quality check before you move something into production. So once executed and once triggered, Keptn will use these two definition files, will query the data providers such as Prometheus or Dynatrace or any other data provider that can be integrated with Keptn. We'll then score first all the SLOs individually, and then come up with a total score. And based on the total score, this can be then used in the approval phase if it should be approved, if it's approved automatically in case of a passing score, then it can automatically be promoted to the next stage, maybe even production. Or you could also ask for manual approval, maybe in terms of the PR that still has to be approved by someone because the quality gate evaluation was not that good, but still you might want to be able to push this to production because maybe it was a very important hotfix that slowed down maybe your performance a little bit, but still you have to put it to production. So there are these two concepts that we can combine. The whole GitOps approach that will pull all the configuration that is stored and versioned and controlled in Git and apply it to your Kubernetes cluster. Plus, you can then orchestrate the tests, evaluations, but even more, it was just an example, but you can orchestrate the lifecycle of your applications then with Keptn. So if you are interested, I just put here a couple of links for Keptn. It's an open source project. Currently it's a CNCF project, and we do have quick starts, tutorials. Also, you can follow the project. We always have quite exciting news for new releases. Yeah, I'm mostly tweeting about also the Keptn project since I'm a maintainer, but also all things around GitOps and automation. You will find also on my Twitter profile. So thanks a lot. Hopefully we can hear the DJ again, and thanks for having me here.
Jürgen, thanks for joining us. This was great. And again, you're a fan of the music, so we want to make sure that we got beats going. So make sure that when we're in person that you find me so that we can jam out.
Absolutely.
Thank you. Have a good one.
Thanks, everyone.
So next up to the stage, we have Jose and Miguel. They are going to be talking about continuous deployment, and I'm excited to hear this talk. A lot of folks, breakups, talk a lot about CI/CD, and you guys are going to focus on continuous deployment. So interested, Jose, good to see you.
Good to see you, Damani.
The stage is yours.
Thank you very much. I'm Jose Talavera, a solutions architect at Weaveworks, and because I work for Weaveworks, I'll try to be as quiet as possible during this talk. Now, with me, and a lot more important, is Miguel Fontanilla, and I have been working with him for quite some time now on Kubernetes best practices and on the Spanish community as well. Miguel has been dealing with GitOps extensively and managed to apply his knowledge in multiple companies that he's worked for. So in the next few minutes, we'll be talking about a selection of GitOps tools, open source, most of them, explaining their pros and cons. And with that, we will do a comparison of those tools around multiple areas like scalability, simplicity, degree of automation. And last but not least, we will go over Sender, which is Miguel's company, more detailed implementation of GitOps, and how they combine as well some of those tools, right? And without further ado, over to you, Miguel.
Okay, thank you, Jose. Thank you for the introduction and thank you for presenting the topic. So I'm gonna just go forward and we're gonna start talking about our GitOps tools. And with regards to the tools, it's important to point out that although all the tools that we will review in this presentation do support Kubernetes, role manifest, and several templating languages, this presentation is gonna focus mostly on the usage of Helm with these tools, alongside these tools. So that's something we're gonna have to take into account. And you know, the main idea here is, we're gonna be comparing three main tools here. Of course, there are more tools, but we're gonna be talking about Argo CD, Flux, and Helm file, and you know, offering some of the stronger points of each tool and comparing them. So let's get started with Argo, Argo CD. As you may already know, well, Argo it's deployed in Kubernetes within the cluster. You know, it has several components that make up the application, and it fosters the centralized deployment management of releases when using Helm. Even though you can deploy several Argo servers, you can control multiple clusters from the same server. It does offer its own API server, graphic interface, pretty useful one, and CLI. And it also supports multiple templating languages as well as multiple plugins to extend the functionality. From the GitOps perspective, it does support synchronization, automatic synchronization, drift detection, and even live diffs to check what is happening or what has changed. And there's something which is really interesting, which is that it supports declarative definition of apps via custom resource definitions. So you can also create releases and interact with Argo by talking to the Kubernetes extensions API. So that's let's say, I would say a brief summary of the benefits of Argo. Here you can check, I'm pretty sure there's a lot of people that has already been using it. You can see the graphic interface, which in my opinion is one of the best points of Argo, especially for those developers that wanna check exactly what's happening on the cluster when a synchronization operation is happening and so on. So pretty useful. Then, of course, moving over to the next tool, we would have Flux CD from Weaveworks. We learned yesterday that they already have some implementations for graphic interface going on. Pretty interested in that. And yeah, again, this one is also operator and CRD based. There's a set of cluster components that you need to install. It supports declarative release definition when using Helm 2. It watches changes on different repositories, and it also offers a lot of integrations to trigger deployments based on different events. I'm just commenting here the image changes, image repository watching, which is one of the most useful things for me. And apart from that, you know, it offers a CLI to control it. Support synchronization, automatic synchronization, self-healing, and drift detection. And in this case, it's a little bit more distributed, a more distributed paradigm than Argo CD. But again, you can have multi-tenancy also when using Flux CD. And starting on V2, it's powered by the GitOps toolkit, which is a set of utilities, operators, and pieces of software that make up make up Flux and let you integrate it with a lot of different other pieces. But you can also extend its functionalities by extending the GitOps toolkit. So it's a pretty amazing initiative. Regarding the functionalities offered by Flux, I just wanted to showcase here, just in case you didn't know about it. For example, this auto commit based on an image trigger. So basically, Flux has detected a change on an image repo and has committed a change so that the chart code is up to date with the new image. And with this, we will move to the third tool I want to comment today, which is Helm file, which is a way simpler tool in comparison with the two previous tools, but yet can be really powerful. It's distributed as a CLI, a pretty simple one, and it does support both Customize and Helm. And you can define in a declarative way your charts, your repos, and your environments. So it allows for a lot of customization, and you can use Go templating for templating your value files, overriding them, templating your releases, your environments. So it's pretty flexible. You can reach virtually any configuration you may need with this tool. And by means of external plugins, you can get a Terraform-like diff, which is especially useful when doing bulk upgrades in several clusters across several environments. And it does support the sync operation. However, it is not relying on cluster side components, so you may need to implement a periodic sync in case you wanna have it like that. And here you can see the in this case, a pretty simple example of this diff-like behavior triggered by a change in the code. You can see it has detected a change. And as I said, it's pretty useful specifically for those bulk upgrades of cluster components. And well, that's a pretty brief introduction to each of the tools here. And now let's go to the comparison itself, right? Just for you to know, this comparison is based on an article Jose and I have been working for. So there are some more tools in the comparison, but just for the sake of time, we didn't include them here. Basically, when it comes to selecting the right tool, there's more than one right answer to the question of what is the right GitOps tool for me, right? It will strongly depend on each use case, number of clusters, number of environments, maturity of the teams, the need of observability, etc. So in order to provide a structured comparison of the tools, here we are considering 7 aspects. And as you can see, there's a fourth tool, Werf, that we haven't included in the comparison. Feel free to check it out because it's also a really powerful tool. And yeah, we're just going to comment some of the aspects. For example, when it comes to observability, you can see here that Argo is, even though there are already some graphic interfaces for Flux, as I commented before, Argo is leading this category because it's a pretty graphic and intuitive tool in that sense. When it comes then, for example, to simplicity, here definitely Helmfile is winning the race. Because it's just a simple CLI. But on the other hand, if we compare it on the automation side of things, Helmfile is not as as automated as Argo CD or Flux CD could be. They are basically relying on CRDs and operators, so they are way more complex. But also from the point of view of automation, they react to changes, integrations, and so on in a more complex way, and giving you more the ability to delegate it to the tool. When it comes to secrets encryption, for example, even though you see low scores for Flux, Argo, and Helmfile, it doesn't mean that it's not supported, but it's not natively coming with the tool. You can incorporate it via external plugins and so on, so you can make it work. For example, with a Seal Secret for Flux or the Helm Secret plugin for Helmfile. And well, when it comes to flexibility, all of these 3 tools are really flexible, especially Argo and Flux, because you can interact with them as using Kubernetes API, their own APIs, their CLIs. You can automate quite a lot of things. And same goes for Helmfile. You can customize almost everything to make it suit your needs. And finally, I would say when it comes to CI, probably Flux CD is the tool that you want to have integrated with your CI, since based on the GitOps toolkit, you can do even chat ops based on all the integrations and extensibility. So that would be the comparison.
Miguel, what do you think there? I think it's very interesting comparison, and there's probably a lot of work behind this, but why did you choose those areas, right? Scalability, simplicity, automation. Why did you choose those ones and not some others?
Well, basically the idea here was to find a set of parameters that you could relate to when planning the CD strategy for your specific use case. Of course, you could have some others, but we believe these ones were the one that you could easily relate to your use case, like how fast is this thing gonna scale? How badly do I need secrets encryption? How automated do I need my pipelines to be? These were basically kind of a consensus on what do you need to assess when planning to create a new CD or a new way of implementing CD?
Yeah, I think that's definitely, pretty interesting for those companies that are trying to pick one of the GitOps tools, right? And they don't know really how to assess them, how to evaluate, right? So I think that's a good way of doing it. And also, if any company is trying to maybe thinking about combining them, right? Because there is no such a tool that covers everything that they need. Maybe they are forced to combine some of those tools. So I think that's a good segue for the next slide.
Yeah, definitely. So good anticipation on that. Yeah, so let's keep in mind, as Jose commented, that there might be more than one tool that suits your use case, or maybe depending on the nature of your application or software component that is to be deployed, one tool can be a better choice. You might even have cases where you want to have different life cycles for components in the same cluster. So for this topic, I will focus on a work stream we are currently working on, Sender, on my company. So I would like to give you a short introduction about the issues we face and where we were coming from, so that you can understand why we are now thinking in this way. So Sender as a company has suffered exponential growth in the past year, or in the past year and a half. And the Kubernetes setup and the cloud setup we had was not scaling as fast and was not being updated as fast as the business was growing and creating. So some decisions were made, some let's say patches were added so that we could keep business continuity. So when we arrived, the new team, we inherited a heterogeneous complex setup as a consequence of this rapid growth. And with several ways of deploying software to Kubernetes, pipelines, Python libraries running on pipelines, raw manifests, Helm charts from pipelines, a lot of things. And as a consequence, we would have cluster components, understanding them as add-ons, for example, and application releases all mixed, entangled, and coupled. Plus lack of clear ownership on the resources that were running within the cluster due to this coupling. And basically we could not reproduce or bootstrap new clusters with these components, let's say on demand, in a fast, repeatable, scalable way. So long story short, we needed to redefine how Kubernetes was done at Sender. And that's when we decided to give a look to the GitOps tools. And first we started introducing Helm file so that we could manage Helm releases for the add-ons, such as cluster autoscaler, monitoring agents, and so on across the different environments. And then we asked ourselves, okay, how do we provide something more, a ready-to-use product for our customers, our developers? And that's what we are working right now on. That's what we call the product focus approach. And let me tell you a little bit more about it. So the idea here is, we want to maximize the product we offer to our developers. So the idea is to hand them ready-to-use cluster with all the add-ons and all the common components they might need. And also to reach responsibility and lifecycle segregation between the infra side and the app side. So the infra part would contain also all these add-ons, and all these extra components. So apart from that, we would also like to give some flexibility for the tool of choice for deployments on the let's say customer side. And we have the premise that everything should be managed by Helm in the end. And we will explain later a little bit more on that.
Quick thing, Miguel. So did you have any specific challenges or issues kind of to kick off this project, this kind of evolution to GitOps?
Yeah, definitely. One of the main challenges here has been understanding this product, the product itself that the development teams are going to be expecting. This closed product that they're going to be receiving and starting to deploy to. So understanding what they might need, what common components all the teams are going to need, what components are not common or shared across the teams. So that was one of the things. And we also needed to ensure that the provisioning model was scalable, repeatable, and the developer journey was suitable for both skilled and less skilled users. That's the idea. So with these premises and also with these challenges, we ended up implementing the following approach, this product focus approach. And let me tell you a little bit about it. So here you can see 3 levels. Let's say that the lower level is the infrastructure level. In our case, we are bootstrapping it with Terraform, which basically correlates to the cluster, resources, nodes, etc., and all the EKS part, because we run on AWS, which is bootstrapped with Terraform. And on top of that, we would have all these add-ons that are provisioned using Hellfire. And this is what we call the platform responsibility. We as a platform team bootstrap the cluster and add all these pieces, all these add-ons using Hellfire. And that's the, let's say, the product ready to use that we hand over to the developers. And there are several benefits of using this approach. I mean, it's more scalable, as we can replicate Terraform with a dry approach, and on top of that, with Hellfire, we can have as many environments as we want. And in the case we need to upgrade something across the entire organization, we can just change it with Hellfire, let pipelines run, and that's it. So we have more infra-like control of the releases related to the node components or to the, as you know, the add-ons. And then on top of that, we have what we call the user space, let's say, or the developer space, which is managed by the teams, where they deploy their applications using Helm and using GitOps tools. That's the idea. So here we have to clear, let's say, worlds, a segregation between responsibility and life cycles.
So Miguel, so in there, you know, obviously the most interesting part is the upper layer there, where you have Helm plus Argo or Flux. What does that mean? Does that mean that they have 2 options, or they can pick both, or you know, how is the selection being done?
Here, actually, this is a more generic, schema. Let's say the idea here is to show that you can implement the upper part of this model with the tool that suits you in the best way. I mean, in our company, we have some more experience with Argo, and some developers were already using Argo CD. That's what we are actually working with Argo CD. But again, that's depending on the company. In our case, we are not that big, so I believe for our scenario, it's better to just choose one tool, because we can share common knowledge across the whole company, so that they can get started with this new way of doing things. But of course, if you have a super big company and you want to offer several choices, you can also do it. I mean, in the end, there are 2 different domains, because you're managing, let's say, the core part with your Helm file, and then the tool you want to use on top of it could be based on the team selection choice or the preferences. That the idea is to keep it as flexible as possible.
Yeah, that's pretty interesting. So thanks. I want to thank Miguel for coming, joining us, and presenting this use case and this comparison of multiple GitOps tools. Thank you very much, Miguel. Thanks for your time, and thanks for sharing this work. And back to you, Damani.
Thank you.
Thanks, everybody. That was really great. It's great to see these various comparisons throughout this day. So thanks for closing that out. Hopefully you can join us in the Slack channel if anybody has any follow-up questions. I think it's great to see these different comparisons, like I said. So if you have any specific questions for Jose and Miguel, please see them in the Slack. So I'll see you guys there. So up next, we've got Giovanni Galloro from Google. Are you here? Looking forward to hear your talk. It's great to see so many different companies represented here and different technologies. And then after that, we'll have another music break. Hello, how are you doing?
Hello, hi, fine.
Hi. Are you hailing, I didn't ask you earlier, are you hailing from California or a different time zone?
Rome. So
Rome.
Evening is dinner time.
Oh, okay. Well, thank you very much for joining us in your evening. So
happy to be here.
Excellent. All right, take it away.
Thanks a lot. Thank you. So, okay, so thanks a lot for having me. In this session, I will try to share an example on how to apply some source code management patterns to the management of Kubernetes clusters. I'm Giovanni. I work as a customer engineer at Google Cloud, specializing on app modernization. I will try to describe a way of moving from an imperative way managing Kubernetes clusters, where you typically apply commands to Kubernetes API server through kubectl or any other tool, and this configuration is not repeatable because it doesn't live anywhere besides the clusters, to a declarative way of doing this. No? So I think this is already discussed in these days. So the cluster configuration is inside a central Git repository, and all the clusters sync with this central configuration and apply and enforce what is defined centrally. On Google Cloud, one of the ways of accomplish this is the use of Anthos config management that has three components: config sync, policy controller, and config connector. I will describe more config sync in this talk. Anthos config management is part of Anthos, the Google application modernization platform that has Kubernetes as its foundation. It has other tools that I will not describe here today, and then extends the possibility of having a Google-provided Kubernetes platform outside and beyond Google Cloud. So also inside the enterprise data center, in other clouds. And all these environments can be managed with Anthos config management. Also what we call attached clusters. So clusters that are not GK clusters, that are not provided by Google, clusters like Amazon EKS, Azure Kubernetes Service, OpenShift, that can be onboarded with Anthos and managed with these tools included Anthos config management. Config sync, as I was saying, what is? It's an operator running on the clusters that continuously sync with a central Git repository, any repository that is Git compliant, and keep the clusters configuration, clusters of different types, all the types I mentioned before, and in wherever they are, with this central defined configuration, continuously enforcing that and avoiding that any local drift can happen. So if a local drift happens, this is avoided. As we said at the beginning, this allows you to apply some of the source code management approach to cluster management. For example, every configuration, it's a commit, it's a commit ID. So in case something goes wrong, you can always roll back to a configuration that you know to work well. Let's try to see some of these in actions. I'm doing this for the first time from a Windows PC. I'm not used to that. Please, demagogues, be with me. Here you can see that I have two clusters in my GCP console. One is a GK cluster living on GCP. And another one is an EKS cluster, so an external cluster, an Amazon EKS cluster registered to run here. Here you can see the EKS cluster also from the EKS console. And both these two clusters have been configured to use Anthos config management. So they are configured to synchronize their configuration with a Git repository that is this one. This is just an example, is a repository living in my personal GitHub account, okay, that I have here. But let's see the local version of this repository. At the moment, this is almost empty. An interesting directory is the namespace directory. I will try to populate this with some configuration and then describe what it does. Let's copy some manifest there. Okay. As you can see, inside this namespace configuration, I have two folders, two other directories, application 1 and application 2. If when you create a folder inside the namespace folder, and if this folder contains, as you see here, a resource manifest defining a namespace, this triggers the creation of a namespace on the managed cluster. And all the resource manifests that are inside the folder identify the namespace triggers the creation of specific resources inside that namespace. So we have this resource manifest triggering the creation of this application one namespace, and we have this role binding, actually binding a user is Leonardo at agilework.info, is a fantasy character. I'm using Renaissance characters here, bound to the admin cluster role. So basic this will allow this user to deploy application in this specific namespace, have admin privileges in this specific namespace. In the reality, probably you will bound this to a service account running a continuous delivery deployment of applications. But this is just to show how to implement role-based access control from the central repository for each namespace. I have an application to folder with a similar structure, creating a second namespace for the application with another role binding for another user. This is for each namespace, and on top of that, if I want to apply some configuration and resources to all the namespaces contained in this folder, I can create a resource manifest in the parent folder. So in my case, I want to have a quota applied to all the namespaces. So I create a resource quota defining a number of pods of CPU that should not be go above that, and a network policy specifying that only inbound connections from the same namespace are allowed, and the outbound connections are allowed only to inside the cluster and into this specific IP address that represent a backend system where my application needs to connect. So saying that, I can stage my changes, I can apply these changes. I just configured the integration of VS Code. Let's see how this works, and I can commit this to create these namespaces. So this is basically, this represents a platform admin. Is the commit going? Yeah. This represents the platform admin actually creating the landing zones for applications. I prepared a command to see to do a kubectl get namespace for the kube contest, for the GCP cluster and the EKS cluster, and just to see to getting the namespace of type application to see if these namespaces are created. Oh, sorry, GCP cluster probably is not the right one because I called it GKE cluster. Okay. And this one is for the EKS cluster. Okay, so I applied, I need to push my configuration. And see if this happens. As I said, this is basically to configure landing zones for applications to provide a kind of access to a multi-tenant Kubernetes cluster, okay? So let's hope this happens soon. It was years that I didn't configure VS Code with the Windows subsystem for Linux. It works really well, but let's see. Okay, as you can see, namespaces started to appear here and will start to appear also on the EKS cluster. There is a polling interval. The default is about 20 seconds, but it's possible to tune this. Let's now try to represent the workflow of a user that needs to actually deploy the application. And here you can see also on the EKS. So let's pretend I'm Leonardo. I have access only to my specific namespace. I try to deploy an application, HTTPB, in a simple server test application. I try to do this on my dedicated namespace. I can do that. If I try to do this on the namespace of the other application team, I have errors because I'm not authorized to do that. If I try to see the application namespace configuration of the application one namespace. As you can see, I have applied these resource quotas, where I have a maximum of 2 CPU. I'm already using an alpha CPU. So if I try to deploy a pod that will go above that, I should have an error, no? So I cannot go outside the boundaries of what the platform admin allow it to me. If I try to do the same with the other users, this is Windows. With the other user, if I try to do the same from Michelangelo on, I have, as you see, I have browser windows logged with the users. If I try to do with Michelangelo on application one, I should have the opposite approach. So I'm not authorized to do that. If I go in my dedicated namespace, I can create my application. I can deploy my application. Let's try also to deploy another test application, a client application, to try to do some connection, sleep.yaml, and let's try to execute let's try to do in this way on my namespace, go to the sleep application and try to execute some commands. Okay, maybe 2 of these. Okay, here if I try to connect to HTTP bin, on my namespace, on the port 8000, live demos are always fun. Okay, I got an answer. This is an endpoint just printing the headers of the request. If I try to do the same on the application one namespace, I get no response back. I get no reply. Why this happens? This happens because I have this network policy applied. Okay, it's this NS isolation network policy that, as we recall, avoid block all connection from that come from other namespaces. As you can see, network policy is here. If the Leonardo tried to delete that, he cannot do that because this is centrally managed. So what can be done? One thing that can be done is to, as we said, try to apply some of the approach related to the source code management approach. So Michelangelo could fork. Let me see if I have the Zoom monitor. Okay, Michelangelo can try to fork the configuration repository. In that case, in his own account, this is just to show, and make a local copy of it. Okay. And create a new branch and work in this branch to work on the network policy. So change the network policy to try to request the network connectivity he needs. So let's see if we can change this to something that could work for him. Okay, let's try to copy that in order to try to allow traffic, at least from other application namespace. So I have ingress allowed only from the same pods. And let's try to add this namespace selector also to the ingress. Okay. Okay. And have this push. Now Michelangelo could open a pull request to the main repository to ask for this permission. It's like the GitOps way could be of requesting a network file war rule, no? In my account, myself, pretending to be the platform admin or the security admin, I can review this pull request, review the files changed, and see, okay, they want to allow the application namespace to have connectivity each other. This doesn't seem to me this seems reasonable. I can merge this pull request, and I should see that this will be a new commit, and this should produce an update of the network policy. I should be able to see that. Oh, sorry. With that. With the describe of the network policy, I see that I have this 435B19 commit is the same. So this should be applied. So in this case, if Michelangelo try again to connect to the application one, he should be able to connect. So there is a flow where this has been implemented. Saying that, and back to the slide quickly, there are other two components. I don't have time to go in deep in this, but you can find documentation about that, and I will hang in the Slack channel to answer this. The other one is policy controller, that besides centrally configuring Kubernetes resources, it is an admission webhook based on Open Policy Agent Gatekeeper that evaluate all requests done on the API server, on Kubernetes API server, to enforce central defined policy, and config connector, that is a connector that allow you to configure non-Kubernetes resources with a Kubernetes resource model. And with this, I finished it. I hope I stayed on time. I don't think we have time, if I understood correctly, for question and answer here, but I will hang out in the Slack channel if you want to ask questions. Thanks a lot.
Perfect. Thank you, Giovanni. Yes.
Thank you, Giovanni.
There's been good active discussions on the Slack. So please, a reminder, if anybody has questions, Giovanni will come visit there. And the great thing about Slack is also that, you know, if you kind of ruminate over and you come up with a question tomorrow, then you can definitely come back and ask, and we'll have our speakers continue to discuss, which we've done at previous GitOps days. So good stuff, Damani. Good stuff so far. It's been a
Yeah, good day so far. Good day so far, Giovanni. Great stuff. I know there's going to be a lot of comments there. You know, folks interested in Anthos and what it brings to the table, and a lot of those features being explained. So good stuff.
Absolutely. Yes. Didn't mean to
No,
cut you off.
I was saying some folks was asking about where's the music. That some folks was pinging me that they need a little bit of an interlude to grab a coffee or
Yes,
something. So
absolutely. So yes, we've got a break now again with DJ Desired State, but stay tuned because we've got tons of great speakers coming up on a variety of technologies, and of course we'll be ending with a great keynote that I'm looking forward to from Alibaba. We'll be talking about how they do GitOps at scale. So we've got so much in the remainder of the day, so stay tuned. And with that, yes, people are asking for music. We want it as well. So take it away, Daniel.
DJ Desired State.
outside, it's a rather glorious, magnificent thing. Inside, it's the absolute opposite of that. It's 137 decibels. It's shaking. Everything is shaking.
So awesome. I love how you really brought the tempo up there. It's the late night vibes out in Berlin. It's great. Yes. So thanks everybody for joining back. Hopefully you enjoyed the break. Got some dancing in there, get some steps. Always got to make sure everybody's got to get their steps. And as I mentioned, we've still got many, many great speakers coming along. And so stick around, stay for the rest of the afternoon. And like I said, we'll be closing with a fantastic keynote with Alibaba. With that, Damani, you want to introduce our next speaker?
Indeed, indeed. We have Saiyam coming to the stage. We're really excited for this talk. We know that many people, many organizations are at various different stages of their GitOps adoption. And I think that it's good to get this talk to really talk about how do we get to scale? How do we get to scale with Fleet? So looking forward to listening to this, Saiyam. This floor is yours.
Awesome. Thank you so much, everyone. Hope you're able to hear me loud and clear. I'll quickly present the screen and get started. So hello, everyone. And well, I'm so excited to be here on GitOps Days. And today's talk is about GitOps at scale using Fleet. So my name is Saiyam Pathak, and I'm working as Director of Technical Evangelism at Civo. And you can find me on Twitter at @Saiyam Pathak. And I'm a CNCF Traffic Portainer Ambassador. I'm CKAADS certified Docker community leader. And yes, I do a lot of meetups. I organize a lot of, used to organize a lot of in-person. Now everything is virtual. And yeah, I'm in Flux Ace. I run my own YouTube channel at saiyambarak.com/YouTube. So make sure you check out. It's all about cloud native streams. And I wrote a book on CKS certification that you can check out. So before we dive into actually what Fleet is, let's go into the bit of history behind Fleet. So as you all know, K3s is a Kubernetes distribution. It was gaining quite the adoption in the industry. Basically, more for the edge ones where people are using more than thousands and thousands of clusters. And so the problem quickly became like, how do we manage those clusters? So that's where the whole concept of Fleet, that we actually want to manage the clusters. So the Rancher team was thinking like, how do we manage the clusters? Because from the requests of their user base was demanding that. So more than 1,000+ clusters running, then obviously the need for managing the clusters at scale increases. And then came the Fleet. So Fleet on initial grounds was just developed as an engine for syncing the cluster states. So that the first step was to sync the cluster states throughout all the fleet of clusters, which is more than thousands and thousands. And it has been actually there has been blog of up to 1 million kind of it can manage that, but that's a different kind of story that I'll touch on later. And then it, due to the rise of adoption of the GitOps that was there, and more and more popular tools becoming popular, so GitOps at scale, then it eventually turned down to GitOps at scale, because you manage them, you can now do GitOps with them, and obviously at scale. So what is Fleet? Originally, Fleet was just an engine to sync the cluster scale, and with GitOps being being with the bigger picture, and vworks pioneering that GitOps field, so Fleet also turned into GitOps at scale. Now Fleet is GitOps at scale, and it is designed to manage up to 1 million clusters. That is the official documentation, official definition from the documentation. So they actually wrote a blog like how they did up to that 1 million clusters, because it's more than a lot of millions of objects that Kubernetes has to manage, and it cannot be done with the regular things. You have to use Kine and other stuffs. So now the first questions that eventually comes to your mind, why you want to create a new something new with respect to GitOps at scale, when Flux and Argo is already there, they are doing good in their own space in GitOps field, then why do we need to create more? So this particular slide is actually from Rancher's point of view, like how they were thinking, how the team initially was thinking. So Flux, as we all know, it's kind of a pull-based approach where you give a path to monitor in the repository or Git repository, and it's a kind of pull-based model for that. And basically, it's more of a single cluster kind of oriented. And Argo on the other hand, is a push-based approach, and it's multi-cluster capable. Yes, it is multi-cluster capable, but it doesn't scale to that level because when you talk about K3s at edge, so it is running, more than thousands and thousands of clusters, so which becomes difficult to do GitOps with at scale. So Fleet is similar to Argo. On initial grounds, yes, it is similar to Argo. It is meant for scale, and it is also meant for disconnected clusters. So that's also another plus point. So you can also use Fleet for the disconnected clusters. So these are some of the highlights for that. Now, before diving into the architecture and I explain all the components, I want to touch on actually the namespaces that gets created. So obviously Fleet will be installed as Helm charts within a Kubernetes cluster, and it will create certain namespaces. Now it will create a few namespaces like say you have cluster A and you don't have a multi-cluster kind of environment. So you will be having certain namespaces which will be pre-installed when you install Fleet. So first will be the Fleet local, which is created with one cluster, which is the initial cluster where actually the Fleet is running. So it will be the Fleet local with one cluster, which is local, and one cluster group. So there will be one cluster group default. So these two things will already be pre-created for you, where the default cluster local will already be there. Next comes the cluster namespace. Now this is created for every registered cluster. So now what happens is, consider of a multi-cluster scenario. Now you have a Fleet cluster running, and you want to register another cluster towards Fleet. So that becomes a registered cluster. So that namespace also gets created in the form of this format, like cluster, then the namespace, then the cluster, and the random string, and all the bundle deployments for that particular cluster is put there. I'll talk about bundle deployments next. Then comes the Fleet system. Fleet system is actually the controller which is running, and even the Fleet agent which is running on the registered clusters, they run in the Fleet system namespace. And last, you have the Fleet clusters namespace. It is basically for storing the secrets for the cluster registration process, and nothing else runs apart from this in this particular namespace. So that's overall, how the Fleet, the namespaces work. Now let's see actually how Fleet works and what exactly it is in a more kind of diagrammatic way. Now Fleet is basically a two-stage pull model, and Fleet controller will pull from Git. So this is the Fleet controller. So this particular architecture kind of depicts the multi-cluster environment where you have many clusters to manage. Now what happens is, there can be a single cluster. You can call it a Fleet manager, or you can call it Fleet controller. They both are kind of interchangeable terms. So it uses all the power of Kubernetes APIs, and this Fleet cluster controller will be doing the actual GitOps. So this will be connected to a Git repo. That's how the connection is there. And what it is a bunch of Kubernetes API custom resources, and you can interact with kubectl. So this is the Fleet controller. Next comes like the Fleet agents. Now Fleet agents actually run on the downstream clusters. What do you mean by downstream clusters? The clusters that you are connecting to the Fleet controller or Fleet manager. So this particular is a cluster group, and there are multiple clusters in that group, and you can have multiple cluster groups, and you can have hundreds and hundreds of cluster per cluster group. So that's how you do the grouping. So you have cluster group, you have few clusters in that, and then you create then you have the bundles. Now what happens is, Fleet agent will run on these clusters. This Fleet agent is also another Kubernetes controller. So everything is in kind of a Kubernetes way. So it's a Kubernetes controller that watches the upstream. So it does two things. It watches the upstream, the Fleet manager, and it also manages the local cluster. So it manages, it watches two things. So that's the kind of Fleet architecture. And I'll explain you more with the demo, because that's where things get interesting, and that's where you will be learning more. So let's move to the demo. So basically, one is a live demo. If live demo doesn't work, then I have a backup demo. I have a backup demo for that. So what happens is, I have two clusters already there. So these are actually the let me just escape it. Yeah. So these are two clusters, Fleet main one. So it is CVO Kubernetes clusters, which are K3s based. So it is using K3s version v1.20, and another one is Fleet agent one. So fleet main one will be running the controller, and fleet agent, obviously, as the name depicts, it will be running the agent. And so this is the gist of things that I have already prepared, and we'll run it step by step on the cluster. So what we are going to do is we are doing if you see over the documentation, we'll be doing a multi-cluster install. We are not doing a very simple install with a single cluster. We are doing a multi-cluster install, just like this particular diagram that I explained to you. So first is just getting the certificate. So let me see if I'm in the right. Yeah, so controller, live C means controller. So we have the certificate generated. Yes, June 11. Yeah, it's 11 for me. And next is the API server URL. You can get it from kubectl config view. And then API server would be the certificate, and fleet again. It's a bunch of the CRDs. So first is the fleet CRDs, and the next will be this one. So it's creating. Okay, it's done. So we'll clear this. And now we give the API server URL and the API server certificate, which we have just created for that, and it will install fleet onto the cluster. So basically now what we have done till now is we have installed fleet controller onto a cluster. So what we have done is, if we go to the documentation, so we have done fleet controller installation. In multi-cluster installation, we have done a fleet controller installation. Obviously, the next part is the fleet manager is ready, and you can now register the clusters. So now we go to the cluster registration process. Everything I have already put that in a guest. So the registration process obviously will run on the cluster that you have to register. So it will be a new cluster where you have to run all these commands. Yeah, before that we have to create a token. So we have to create a token, and this token will be used so that it gets registered with the cluster. So Rancher is already kind of something they have already pioneered this space where you can register clusters. A single Rancher, you can have multiple clusters that can be registered, multiple clusters that can be imported. So agent runs over there and it connects to the Rancher. So similarly, it's the fleet controller, and the agent will be running, and the token will be used to connect to all these clusters. Okay, so we have this deployed. So now what we'll do is we'll create just a namespace. So this is still running on the controller cluster. Cool. So we have the token. Token is simple file I can show you. So it's a simple token file that is there. So we'll quickly run that. So token has been created. And now we will get the values from the token in the values.yaml file. Now, this values.yaml file is important because this will be used when we register the agent. Now we have to run it on a agent cluster. Oops, I'm not able to copy it. Okay. So we have to run it on the agent cluster. Where is that? Before that, we also have to create a cluster group. Yes. So cat cluster group cg.yaml. So basically, cluster group is this particular thing. If we go back here, now what we are doing is we are creating a cluster group. We are creating this particular boundary where we'll define what all clusters will be part of this group based on the labels. So we are saying that we create a production group in the namespace cluster, and all the clusters having a label env prod which are connected to the controller should be part of this particular cluster group. I hope that makes sense. kubectl create -fcg. Awesome. So we have the cluster group ready. We have everything ready. So let's go to our agent. So this is our agent, live agent. And now we go back here and we run this command. And while running, we set the environment label, and we also use the values.yaml file that we just generated from the token. From the token, we created a values.yaml file. So it will install Fleet agent. I hope the components ran successfully for the Fleet system. Yeah, everything is running. So you can see the namespace Fleet system. It has a good job. Fleet agent is there. Fleet controller. The controller is also there. That is good. Awesome. So we already have for the Fleet agent also deployed on the cluster. And we can actually see if the cluster, we get the clusters. Yes. So the cluster got registered, and you can see 3 out of 3 nodes is, are ready. So it means it has registered the cluster. So that cluster is also registered. Now what we do is, now we enable GitOps. So now the GitOps part comes into play. So we enable Git repo. We create an object Git repo, and in the namespace cluster. So everything in Fleet is namespaced scope. So all the things will be happening in the clusters namespace, and you have to create different namespace for different cluster groups. If you want, then you have to create their own Git repos. And the targets, and so the repository. So this is the repository. It is Fleet demo. I'll show you that as well. The branch is main. The target is the cluster group. We specify the cluster group as a target, and we just created previously, as you can see above, we created the production group cluster. And the path is basically which path, whenever that the files in that particular path gets changed, so it deploys that. Now the good part is, Fleet can deploy manifests, Helm chart, and customize. So anything, it will automatically pick it up and deploy it. But internally, how it is doing is, if anything you specify, it will convert it into Helm and then deploy. So even if it's a YAML file, it will convert to Helm and then deploy, because it's easy to manage. The releases are easy to manage. So let's do kubectl apply -f repo. So basically the thing that I'm showing you is a standalone one. So usually you must have seen everything. Sorry, just let me see. Oh, sorry, I ran it in a wrong cluster. So this has to obviously run in the controller cluster, or the Fleet manager. You can call that any. So the repo is created. Now we can see get pod -a. So it should create a pod. Okay, it created in the cluster namespace. It has created a pod which is initializing 2 things. And once it's completed, we can see kubectl get pods. So this is the agent cluster, the target cluster, and we can see the cluster, our service is already getting deployed. So what we'll do is watch kubectl get pods, and we can see the service is getting deployed. And yeah, GitOps is enabled. You can add n number of clusters to different cluster groups, and it'll automatically deploy anything that is there. So even if, and the service is here. So if you go here, this is a service. So you can see it is working. And even if we change to V2 and we commit the changes, so that's how the whole GitOps process is. So it is automatically watching the demo repository, and I have changed the deploy.yaml file, changed the image to V2. Obviously, this can be done using the GitHub Actions. So you can have GitHub Actions, commit the code, and it will create a new file in the deploy.yaml, and then it will be deployed over the it will be redeployed to this particular agent cluster, which it is, you can see it is happening right now. So I think I'm about time, and the demo is also concluded, that I have done kind of shown you GitOps, like if I change anything, it reflects here. You can connect n number of clusters in different cluster groups and connect to Fleet. So that's how the Fleet manager will be managing a multi-cluster deployment across all the clusters for help, customize, or even the plain YAML files. So yes, you can use it with Rancher as well. So like this, in the dashboard, you can enable GitOps. It is pre-enabled when you install Rancher for a particular cluster. It already comes with a default namespace. That also I have prepared just to show you the UI. It is already getting done via the UI. You can see continuous delivery section is actually Fleet in the behind the scenes. Cool. So that's pretty much it. And hope you liked the Fleet concept and where they're heading to, more integrated towards Rancher, but can be used easily as a standalone project as well.
Very cool. Thank you so much, Saiyam. Very nice and great to see a live demo all work very well. Nice preparation. And also
Thankfully
good to have,
worked.
yeah, and always good to be prepared with a recording in case something goes wrong. So thanks so much. And reminder to everybody, if you have any questions either now or you ruminate and you have some questions later, we'll make sure that all the speakers return and can answer your questions. So make sure to join the Slack. It should be down below in our YouTube channel. And thanks so much, Saiyam. I'll start introducing the next speakers. So
Thank you all. Bye.
Thank you. We're very excited to have two speakers for the next one. And we'll bring on, I've been working on this. So it's Cansu, Kavili, Örnek, and Donald Spring. I'm now glad I know how to pronounce Donald Gleason's name correctly. I've been saying it all wrong with that actor, so. Yeah, exactly. Closer. But yes, thanks so much for joining. And yeah, you're both from Red Hat, and we'd love to see what you have to demo. So I'll give the stage to you.
Cool. Thank you very much. So Cansu, I think you're going to screen share, and then we're both going to talk short for a few minutes.
Yep. Can you see the screen now?
Yep. Yeah. You can
That's
see
great.
GitOpsify all the things.
So, okay, let's start then. Well, welcome everyone. Today we're going to talk about GitOpsify, all the things, not just the tools, not just the apps, but also your organization. So yeah, first let's a little bit introduction about ourselves. My name is Cansu. I'm at Red Hat working as a site reliability engineering in Open Innovation Labs EMEA team. And these are our handles if you need to reach out to us.
Cool. My name is Donald Spring. So I'm an architect working in the Red Hat Open Innovation Labs team as well. Cool.
So let's start. Okay, so as well, we are in GitOps Days, and we know that GitOps is on the rise, and we have all our own GitOps tools inside the cluster. And oh, shoot, sorry, this was a live one, right? I need to switch the screen, not the recording one. Sorry. So apparently we have all our we all have our own favorite GitOps tools inside the clusters, and we all doing this, right? We just come to let's say Argo CD to create our applications through GitOps, because we have our source code repositories, we have our applications definitions, and all we need to do is just to point that and say that I want to deploy it to my cluster, and Argo CD will takes care of the rest.
Magic. Wowzers.
Yeah.
That's pretty cool. So we thought, yeah, that's pretty cool. I can go to a UI and I can click a few buttons. We're Kubernetes people through OpenShift, so we've been doing this shit for years, right? We've been clicking buttons in the UI, and we thought, well, there's got to be more to this GitOps thing than just clicking a few buttons in a controller's UI. So we thought, we have a problem whereby we do a lot of like rapid prototyping and enablement with our customers on Kubernetes using OpenShift, and we thought there's got to be a way that we can kickstart our development. And so with that is born what we call the ubiquitous journey. So the ubiquitous journey is what we use as our kind of project Kickstarter. We like to think of it as like the big bang at the beginning of our projects. So we roll out a bunch of tooling. It's all based on some experience we had with some customers, whereby, if a customer wants to use some cool new tools, some cool new, I don't know, a thing in a pipeline, like a packed broker or a hoverfly or something like that. They want to use some tool. We would basically write this as infrastructure as code, and we would then add it to our Git repos in order to be able to kind of automate the deployment of it. So the Ubiquitous Journey is a project that we've been working on for a little bit over a year now, Cansu, I guess is fair to say. And it's broken down into kind of two parts. The first part is sort of scaffolding some stuff inside of our cluster. It's sort of like we've got like a chicken and an egg scenario, whereby we want to GitOpsify all the things that we have in our cluster. So in order to do that, we need to deploy a controller. We've chosen Argo as our controller. Sorry, Weaveworks. But we've chosen Argo CD. And what it does is our Bootstrap will spin up some projects that will be managed by Argo and some tools that we spin up the things required in order to enable GitOps. And then we have on the right-hand side here, you can see kind of the list of tools that we have for doing things like CI/CD. You have things like Jenkins, Nexus, Selenium for doing browser testing, as well as like collaboration tools. So in this like post-COVID world, we found that moving things into like distributed mode is quite important to us. So being able to do pair programming in a shared space in a cluster became an important collaboration aspect for us. So this is the tooling that we spin up. If anybody's interested, they can scan the QR code up the top right, which I think takes them to an example of a customer using this, which was the World Health Organization. Am I correct?
Yeah, I guess so. Yeah.
Yeah. Okay. Cool. So yeah. So let's get into it. Let's see what this thing looks like.
I'm sorry again. I will remove them after this. So okay. So let's see.
Cool. So what you've got here. So Cansu has gone to our Git repo, which again is public. She's cloned the Ubiquitous Journey project. And the way our Ubiquitous Journey project is made up of, it's basically a little bit of what I would think is just clever glue, really. So we've got one template in our chart, which is just an Argo CD application definition. And that Argo CD application definition, right at the top, you can see it says range in app of values.applications. So in our Argo app of apps, in our values tooling file, we've basically got this applications array where we can put in anything we want, from just some straight up Kubernetes YAML to a Helm chart to some customize or any other sort of tool, either that we write a chart for ourselves or we pull from the internet. And with doing that, we basically tell Argo that this Git repo exists, where it'll find this list. So for example, on SonarQube there, we have just a little flag that says, enable true, where to find the chart, what version of the chart to use, and where to deploy it. And then the values there on the on line 157 is any customizations or any overrides we want to pass to that chart specific for running it in OpenShift or the way we want to configure it. So Cansu, do you think it's pretty easy to show people how we can extend this?
Of course, we just need to find another application to add at the end of this file by saying that here is the new Helm chart we would like to deploy as a part of our tooling, for example, Powerfly. So
cool.
In here, yeah, it's an open source Helm chart. We point to the right version we want, and we have some override values that we would like to apply to this Helm chart. So all I need to do is
specifically in here, we're passing in stuff to make it work with ingress in OpenShift, which is also known as root, because OpenShift.
So Powerfly is added from the demo,
cool.
And the emojis, and I push it. So now I need to go to our Ubiquitous Journey. You see that those are the old toolings that we just showed in the file, and now we just add Powerfly in here magically. So you see that this is the commit I did.
I can see the previous commit says removing hoverfly.
Yeah, because I was trying right before the demo.
Spectacular. Cool. So this is the Ubiquitous Journey project, and it's really customizable. And that was what I kind of wanted to show off here, was you can kind of use this tool as a GitOps approach to managing all of the things that you might need in supporting CI/CD, or even beyond that. Again, if you think about maybe like project management tools like WeCan for Kanban boards, or code-ready workspaces, or any of the sort of additional things you might want to deploy, Etherpad or Mattermost if you want to do chat, as well as using the same pattern for like adminning inside of your cluster. So we've also got like a day 2 ops YAML file in there, where we've got some commonly used things that we use in OpenShift LAMP to prune old builds or establish network policies. And the important thing here is that we're getting our customers used to a GitOps first driven approach to everything. Cool. So what happened next? So basically we were using this for a couple of gigs, couple of engagements, getting lots of really good feedback. And then we had a customer, a very large airline based somewhere in Dubai. I won't name the name. But a very large airline came around to us and said, this is a really, really great tool. And I really like how it's able to kickstart our development teams really, really fast. But I have 10 agile release trains with up to 19 teams in each one of those. How can I use this same pattern to almost automate the structure of that, as well as onboarding the new applications and their tooling using the same paradigm? And so we kind of locked our heads together and thought, well, I mean, it's basically the same problem, right? We're just if we can define a bit of YAML if we can write a bit of YAML that defines how these teams are structured, then we can define the sandboxes, the projects that they would use. Yeah, so over to you, Cansu. Tell me what we did.
Yeah, that will surprise our listeners, but our response was, why not GitOpsify everything? So we started thinking about it, and like Donald said, for this particular customer, we wanted to come up with a standard team onboarding process for each team within each release team, as well as a standard approach of application onboarding and application lifecycle. So since our ubiquitous journey approach was easy to extensible, and this team that we worked with really liked it as much as we did. So we thought that GitOps methodology is the way that we want to go. So we came up with this release train Gantt chart, which is in the main value file, you define teams and the application they're responsible. You see that if you look at here, we have pirates, we have Vikings, we have cowboys as teams, because why not? And you see that there are also some applications that they are responsible of specifically.
We're definitely in the Cowboys team, because we're definitely Cowboy coders.
But if you look at this, here is the Viking team, they're responsible of these two applications called stations and flight search. And each team can define their own specific applications for each environment, because each team has by default in this case has two different environments. One is called test, one is called staging, and they are defined as folders on the right. And each files in these folders, in these environments, have their own specific values for these environments. Like could be the application version, or could be the database connection information, or some other specific environment variables. And if you would like to, like this type of environment, and if you would like to override add a new team, all we need to do is to extend this values file by adding a new team and the application they're responsible of, and the corresponding folder scheme to this, like test and staging, and then the related values file for these environments. And sorry, I would like to also talk about this. It's easy to replicate each environment. Like let's say that you want to create a similar environment that you have in staging, just to have some performance testing. So all you need to do is to replicate environment testing and extend this values file, and Argo CD will pick it up, and easy to create this environment for you just for some testing. And if you want to clean this up, you just need to update the file. And you might think that this might be not so easy to understand for a new team, maybe while onboarding them to the platform. But the team would already be working either with Helm charts or Kubernetes, or start to doing it, because ideally that is where this customer would like to go, to the cloud native ways of working. And this is just a Helm chart of Argo CD application and Argo CD project definition, but referring to different values file. So based on our application experience, it wasn't really so hard. But additional to that, there is also the application onboarding part of the job.
That's cool. So we've where have we gone so far? So we've talked about playing around with a GitOps controller in the form of Argo CD. Then we said, oh, that's cool, but how can we use it to actually kickstart some development? So we built out our ubiquitous journey project. Oh, actually, anecdote about ubiquitous journey. If you're wondering why it's called the ubiquitous journey, it's not because we're mental and we like challenging people to spell complicated words. It's because we went to GitHub, because we know that the problem with software is it's difficult to define things, and naming things is really difficult thing to do. So while we were trying to decide what this DevX or CI/CD platform was called, we went to GitHub and we hit generate random project name, and it came up with ubiquitous journey. And the first issue on our backlog was obviously to fix that. Only for like maybe 6 weeks of development against the ubiquitous journey for us to all realize that actually it's a really great name and we really like it, and so it's stuck. But anyway, I digress. So we've looked at tooling. We've looked at how you can use like a GitOps approach to sort of infrastructure as code, GitOps approach to drive your organizational structure and use it as an accelerator for onboarding new groups of new teams with new services that they want to deploy to your platform. And so you might be thinking that that's great, but all of this like defines like a pre-built application or like a Helm chart that's been already published. So, you know, how did it get there is the question that you might be thinking to yourself. Maybe you're not, but it's a question I thought when we went through this deck earlier. So what about my apps? So CI, CD, CI/CD, CI/CD squared. I mean, who knows what this stuff is called anymore? But what we do is, besides put emojis in everything, and this is a quick little screenshot of one of our reference pipelines. So we have an approach whereby for any commit that someone makes to any branch, it's kind of deemed to be a sandbox build. And the point I'm trying to show here is that we run through the same pipeline for a sandbox build as we would for like a release candidate. The only difference is that we don't use Argo CD or a GitOps controller if we're just doing like a sort of a lightweight, fast feedback loop to a developer or to an engineer. Instead, if we move on to the release candidate flow, for a release candidate, we will always prepare the environment, run a build, run a bake. So a bake for us is the act of taking the binary and putting it in a box. And then we will package up our Helm chart, you know, tweak versions, manipulate any variables, or update the chart itself if needs be. And then at this point, for deploying to our test environment, we involve slightly more heavyweight tools such as Argo CD. So when we wanted to make a deployment, we have like Jenkins executing synchronously, running a command by updating a value in Git, at which point then Argo CD, which is our GitOps controller, is detecting that change, and then is rolling out that change into the environment. We've got some webhooks and a few other bits and pieces in place so that the synchronous behavior of these two pipelines interacting is pretty much covered. And then what we do is we kick our system test job. And the idea here is that we're trying to disconnect, no, it's fine. The idea is that we're trying to disconnect CI from CD, right? The thing that produces the artifacts that we want to deploy is life cycled a little bit differently from the things that's actually running the deployment for us. So we love emojis, and we didn't know what emoji to put in for testing. We knew cucumbers was obviously only used for cucumber testing. So for our test environment, basically any microservice we have in our system, if you imagine you have 10 microservices, any one of them can push a change, and then they kind of narrow out this funnel into our system tests. And at our system tests, we'll then run our UI tests, we'll run some additional API tests, we'll run some more integration tests, and we're now validating the app as a kind of collection of other apps, or some sort of app of apps, if you will. And once that's been successful, then we sort of say this release has passed the quality gate, so we tag it for release and we promote it to the staging environment. And likewise, we could promote on into production too. So that's kind of how we get our applications through this process. Cansu, do you want to do a quick little tour of what that looks like, maybe?
Before that, I would like to say that Donald mentioned about that how we do these things in Jenkins and then we test it to the Argo CD. Jenkins is not the only tool that you can do it. Jenkins is just there for our CI. The point is here is to separate CI from CD. Now Jenkins is there up to the build point, but then we rely on our GitOps tool to do the deployment and
I remember before we moved to Argo CD and a GitOps approach, we used to use Ansible for a while, but either way, what we were doing is we were just patching to like deployment configs or deployments in a Jenkins file and saying, go do that. And obviously Jenkins was doing it exactly as you would expect. But then the problem was that, you know, someone would go into the deployment config or to the deployment and be like, oh, I forgot to expose this environment variable. They'd go and make that change. And then like 2 weeks later, when we go to move from one cluster to the other, or we delete the environment because we like to kind of practice our infrastructure as code and our ability to recreate all of these things. Well, I think you've got to delete this.
I think we were too hungry while doing it. Sorry.
Yeah, but Jenkins is really good at all those bits on the left, but it sort of struggles a little bit with maintaining the state. Cool. Anyway, Cansu, do you want to show us some appsy stuff?
Yes. For example, this is an application of application definition for this particular test environment, so to say. And it is exactly the same approach as ubiquitous journey. You have an environment definition in here, and you have all these application definitions for each of the components for your application that make of this application to here. And as you see in here in these comments, you see that those comments are coming from Jenkins, not from anyone from the team or any other individual. Yeah. And these are all happening in the automated way.
That's cool. So our our app configs essentially that define this structure is sort of like hands off from a human point of view, and it's all automated. So you just see this big string of automated commits on it. So like Cansu, if I wanted to roll back something, how would I do that?
Oh, well, if you look at the definition of an application, it's in another Helm chart somewhere and a bunch of other parameters about this application. If I would like to roll back, I just need to update this in my Git, or if I would like to go back to an older version of this application, I just need to override these parameters in my Git repository. But and that's all. It's just another commit to the Git repository.
Magic.
Yeah. So we really love this approach. It is really easy for business owners or product owner type of people to see what is running in which environment, in which version, and it is really traceable because of Git. It's highly secure, and you can follow the all process from start to the end.
Yeah, it's really really transparent, right? It's really clear and obvious what's deployed where and how easy it is to roll back. There's no more panic. Oh my God, that version didn't work. How do we go back? It's easy. Just git revert or just put another commit on top of it.
So if you want to know more, visit our website, visit our repos, and reach out to us, either Twitter, from LinkedIn, or any place you will see. We use generally the same handles. So thank you for listening.
Yeah.
This is great. It looks like you guys have a lot of fun at work.
Oh, totally, man.
I think my biggest takeaway is to identify your ubiquitous journey. I think folks need to identify that.
That will be a test. Can you spell it? That's the thing that we find the hardest.
Yeah,
we call it UJ in short, because people like me, non-native people, it's so hard to say.
Nice. Well, thank you so much. Thank you so much for joining us. Really appreciated this conversation. Tamao, how are you feeling?
Yeah, it's great. It's great to see all these technologies represented in different ways. We've been chatting away in the background. So yeah, please check out the Slack. And if anybody has questions, talk to Cansu and Donal. We'll be there. So with that, we have a brief break. Again, with DJ Desired State. This is just one of the shorter breaks. And then we've got some speakers coming up, so stay tuned. Thanks both of you.
Thank you.
See you. Bye now.
Bye.
Bye.
Cuando las serpientes evolucionaron, más rápido que muchos venenos. Noten la diferencia entre una serpiente venenosa y otra que no lo es por las marcas que deja.
1970, 1970, 1970, 1970. Nací un día de junio del año 77, planeta Mercurio y el año de la serpiente. Signo patente tatuado y en mi frente que en el vientre de mi madre marcaba el paso siguiente. Nacer, llorar sin anestesia en la camilla. Mi padre solo dijo esa Ana María. Sí, sería el primer llanto que me probaría, que mandó las heridas y dándome la batería. Solía ser entonces como un libro abierto, pero leí la letra pequeña del texto, como un arquitecto construyendo cada efecto. Correcto, incorrecto, se aprende todo al respecto. Saber que algunas personas quieren el daño, subir peldaño toma tiempo, toma años. Con mi peluche mirando lo cotidiano, dibujos transformaban el invierno en gran verano. Papá me regaló bajo mi insistencia un juego que trataba de compartir la solvencia, pero en el patio hicieron la competencia. Fue cuando sentí mi primera impotencia. 1970 y 1970 y 1970. 1977, no me diga no, que no lo presiento. Todo lo que cambia lo hará diferente en el año que nació la serpiente. 1977, no me diga no, que no lo presiento. Todo lo que cambia lo hará diferente en el año que nació la serpiente. Mi adolescencia fue una etapa bizarra, el cuerpo es batería y la cabeza guitarra. La orquesta narra una tonada quebrada para la mirada de una niña que solo talla espada. Hormona disparada, sobrepobladas de información que cambian temporadas, caminas encrucijada. Cada cual en su morada preparaba la carnada, la sagrada diablada de mirada encabronada. Mi fila la verdad nunca buscó su silla, mi búsqueda fue mero proceso de pura pila. Pupila de poeta que marcó nuestra salida, en la cordillera que miraba la salida. La parada militar de paso monótono, colores policromos, los uniformes de poco tono. De tono mi cuestionamiento, la voz y sonó, no. Mi primera rima que sonó y perdonó. Mi búsqueda no fue para mi cosa de cenar, fue algo necesario que marcaba ya mi fall.
Ooh. DJ Desired State keeping us on our ones and twos. Love it, love it, love it. I love how we could just see his lights dimming in the background from outside. You can see how it's getting later and later in his time. Where
He's having a real evening dance party over there.
I see the neighbors starting to come over with a glass of wine.
Exactly. He should invite his neighbors over for a party. Good. Everybody's vaccinated. Excellent. Thanks for sticking with us, everybody. It's great to see everybody watching us on YouTube. So just want to do a quick shout out. We've got a couple speakers coming up. One, Damani will introduce, who's now an old hat because was with us yesterday during the after hours. But after we have the second speaker, we've got Dan Papandrea who's joining. And I wanted to make sure we let people know that Dan's got a podcast that dropped a new episode yesterday. And it's on Twitter at Popcast Pop. So the handle is Popcast Pop, and interviewed our very own Alexis Richardson, our CEO, and the person who coined GitOps. So I posted that in our GitOps Days Slack. So if you want to see the link or you want to go to the Twitter handle, please go to that. So with that, yeah, Damani, I'll leave it in your hands to introduce our next speaker.
Jason, how are you? Next up to the stage, we have Jason Morgan. I want to see, Jason, do you like my hat or what?
I do. I love it. I've actually got the same one right here. So.
For those of you, I got some comments about the hat, and they think that Jason is paying me off to wear this. But I actually won this at KubeCon 2019 when you guys did that amazing developer experience exercise, and I thought it was pretty neat. So kudos to you and your DX team there at Boyan and Linkerd.
Awesome. Thank you so much.
The floor is yours.
Okay, well, I'm going to start with a really small number of slides, and I'll end with a story of how you can get your own hat if you want it. So today I'm going to be talking to you about using Linkerd or really any service mesh with GitOps, and specifically how we're going to handle dependencies with Flux. Let's see if I can get my laser pointer to work. I can't. Great. So who am I? My name's Jason Morgan. I'm a technical evangelist with Buoyant. You can find me on Twitter, GitHub, or over on the Linkerd Slack. And it's my job to talk to folks about Linkerd and try and encourage you to use it. So before I go into the main topic, what is Linkerd? It is a very lightweight, fast, and security-focused service mesh for Kubernetes. There's a bunch of good stuff that we can say about it in the slides that I'm not going to read out to you. But love for you to go pop in, check out the repo. We are a CNCF project. And yeah, we're used by a bunch of different folks. So just this is almost my last slide here. So let's talk about this real quick. When we think of GitOps, or at least when I first read about GitOps in like 2016 from a Weave blog, right? I really liked the idea of putting everything into Git and having it apply directly to my Kubernetes cluster. But the thing that I figured out after using it for a bit is some steps need to happen in sequence, right? So we've got whatever code we're going to use to launch this environment. We have to bootstrap our Kubernetes clusters. Then we have to install like our GitOps tool if we're using something like Flux. We have to figure out how we're going to load in our secrets. So we're going to use something like sealed secrets, or we're going to connect to another process that's going to load stuff into Kubernetes. Or we're finding a way to safely store secrets in our Git repo. Then we're going to need to install a platform, right? And a platform, especially when you're using a service mesh, is going to include some components that will actually change your applications that get deployed. So the stuff you have in YAML inside your Git repo is going to be different or mutated by that platform, right? So our platform is going to need to be installed and ready before we deploy our apps, whether those are just our normal apps or databases or whatever that may be. So with that, I'm going to pop right into a demo. All right, let me see. Can folks see my screen okay? Awesome. All right, so here I'm running a K3s cluster via a tool called K3D, which lets you spin up Kubernetes clusters on demand. Right now I've got very little installed beyond metric server and an ingress. And we're going to go ahead and add Linkerd add Linkerd's visualization dashboard, and add the Flagger progressive delivery tool. So let's see what that looks like. And of course, first I'm going to install Flux. So because it's a K3s cluster, we're just going to start out by validating that it actually works. So we're going to use the Flux precheck command. Right, all our prereqs passed, which is good. Now we can go ahead and actually install Flux. So it gives it a minute. The tool is going to go ahead and actually check that Flux installed correctly. And you can see our containers popping up here on the right. All right, and that is finished. So now that we've done that, I'm going to go ahead and use the Linkerd CLI, not to actually do the install, but just to validate that this works on my cluster. So once again, we're going to hope for a bunch of green check marks that say everything is good, which we've got that. And now it's time to actually install our platform. So Flux, for those that I assume most of y'all are familiar with it, right? But Flux creates a bunch of custom resource definitions that allow us to manage our environment. So the first thing we're going to do is create a Git repo. So instead of using the Flux CLI, I actually put that directly in Git. So we're just going to take a quick look here. We have a Git repository, which is that custom resource definition from Flux. And then we've got a repo URL, right, as well as the branch. We're going to go ahead and apply that to our Kubernetes cluster. So if I do down here, kget Git repositories. Right, I don't have anything, but then once I create this, we see that now I've got my GitOps repo, where it came from, and that it's now ready to actually be used. All right, so now that I've got that, I'm actually going to go ahead and install my platform. I'm going to kick it off, and then we're going to go in the YAML because this takes a couple of minutes. So what this manifest has is 3 customizations. So let's go ahead and run a watch command here. Watch kubectl get customizations. We're just going to look in all namespaces. So what you're seeing here is Linkerd is installing, but Linkerd, Viz, and Flagger, which are also customizations that got created all at the same time, are waiting because they've got a proper dependency here inside the chart. So let's look at inside the YAML. So let's look at the customization, see how we did that. So we're just going to peek at the YAML that we just created, or that we just applied, and let's see if I can make this just a tiny bit smaller. That still look legible? Awesome. So so we've got a kind customization. It's called Linkerd. It's going to be in the Flux system. We give it a path, so it's just the path that's in our repo. We can take a look at that repo structure here in a minute. We give it the name, right? Which Git repo, which is the one that we just created. Then the key thing, right? And so when I first started messing with Flux, I was really keen to make this dependency chaining work. But I had a bit of a hard time until I dug into the docs and saw this health check thing. So when you're creating your customizations, if you take the time to put in a health check for each deployment or each thing that you want watched right from that given customization, then Flux can wait for it to be fully ready before it does the install. Right, so we list out all the deployments, so proxy injector, identity, whatever else, right? Basically all these things that get created. And we tell Flux that they are part of the health of this particular customization object. Now, I need Linkerd to install before I try and install the Linkerd dashboard, which we call Linkerd Viz, right? So Linkerd Viz, I put here under spec this depends on field, and I say it depends on Linkerd to be installed. Right now, once Linkerd got healthy, right? So we see that Linkerd came to ready true. Right now, Linkerd Viz is going through and doing its install. Right, and then one more step, right? So if you caught any of the stuff last night, we used Flagger with Linkerd. So Flagger relies on the Prometheus instance inside Linkerd Viz to install, right? Or to actually work. So we've chained the Linkerd Viz to Linkerd and the Flagger to Linkerd Viz being completed. So again, with Linkerd viz, we have our depends on, we have the Git repository, and then we have the health checks to make sure that it doesn't install, or nothing that depends on the visualization component installs until it's completed. We go look at Flagger, and we see the same thing. We just put in a health check and say it depends on Linkerd viz. All right, great timing. Our Prometheus just finished, right, which tends to be the long pole on the Linkerd viz install. We have Flagger going, and we can drop out. All right, so now we can just run our Linkerd check, validate that the install is correct. It's going to go through, check the installation. It'll also go ahead and check any installed extensions. And then we can run a separate Linkerd viz check if we want, just to validate that that's ready to go. Now what we're going to do is actually deploy an app, right? And so this app, as you'd expect, right? So remember from that, let me put the diagram back on real quick. Right, so we've got this ordering of things, right? So we had our Kubernetes cluster deployed with K3D. We had Flux installed via the CLI, not actually using any secrets here. Deployed our platform, and now we're going to go ahead and do our applications. In this case, it's just the pod info app. So let's get that out. Pod info is created, and let's take a quick look at what that is. So again, right, we just set that because we want it to use the progressive delivery, we just told it to depend on Flagger. Why are you saying Flagger's not ready? There we go. Oh, no. There we go. We see pod info installing. We can go ahead and launch our Linkerd dashboard. So we can see it coming up. So because we use Flagger, there's some kind of interesting stuff going on. So let's just peek at the repo real quick. I've still got time, right? Yeah. So if we look at this repo, right, inside our pod info folder here. So this is what we just applied with that YAML. Right, we've got a bunch of things from a canary, a front end, a generator just to create some traffic, an ingress rule, namespace, all the stuff that you'd expect, right? But some things that I didn't create are a pod info service. And I also only created one deployment, right? A pod info deployment. But if I look here, KNS pod info. If I go peek around here inside this namespace, I've got some new deployments, right? Specifically pod info primary, which isn't specified anywhere inside my YAML, right? And if I do kgit pods, right? Again, in my YAML, right? Like I only define one container per pod, right? But because I specified on the namespace that we want Linkerd to inject the proxy, right? Each pod has an additional container stuffed into it by Linkerd, right? But if pod info had installed prior to the platform being ready, right, it wouldn't be appropriately injected, right? And same thing like Linkerd viz. Once you install Linkerd viz, it gives you some additional functionality in Linkerd, like the ability to tap traffic in between applications. If we installed the proxy before tap was ready, we wouldn't have that functionality either. So I can go into my dashboard. I can look at pod info. I see, all that stuff I want to see around like success rate, requests per second, latency by latency bucket. I see my pod info primary service. We can actually go in, tap live traffic to that application. See what endpoints are being hit. We can actually go peek in on some calls if we want. Sure. So we can get live traffic, but all this comes because, right, like the apps got installed in the appropriate time, right, and in the appropriate sequence. So I'm running ahead of schedule, so let's go ahead and show, just because we can, let's show a blue-green deploy. So k port dash forward service slash front end. All right. So here we've got pod info deployed, right, with its green background, but we can use the flagger progressive delivery to get us a switch from blue to green. So let's do that. So we'll go in, switch our UI color, and make a git commit. Sorry, give me 1 sec to get my API key off to the side here. All right, so we made a push. We go over here. Let's actually do this one. So we're just going to tell Flux to reconcile. Flux, reconcile, customization, pod info. So it's going to see the change, and then it's going to have Flagger go through the process of, spinning up pods inside the pod info namespace. So let's just do this. Watch. Well, actually, we've got that watch over here. Yeah. So we see now a new pod coming up, right? It's gonna spin it up, and then it's gonna direct traffic to it based on that canary deployment. So if we do watch, well, actually we can see this in the dashboard. So let me pull that back. So now if we go look again at pod info, we can see that there's now front ends pointing actually at 2 pod info instances, right? So we have our generator sending traffic to our front end, which is pointing to pod info primary and pod info. They each now have members, right? And we can see from the traffic split, like how much traffic is going to one versus the other. So the Flagger stuff was kind of just some extra to show you how that works, right? And some of that dependency stuff. But I hope the lesson you take away here is, as you're doing GitOps, right? Like the ordering matters, and so far Flux has made it really simple and straightforward to chain those dependencies. So you can do your platform, you can do your applications, you can even do applications in sequence, right? Like if you need, like, I don't know, your database there before the app starts up or whatever that is, you've got that depends on construct along with the health checks to get the order you want. Now we see that this background changes from blue to green, and it's going to switch as it does that traffic split. And so that's all, Linkerd plus Flux plus Flagger to get you this kind of functionality. And then provided this was interesting, if you're interested in checking out Linkerd, we've got a getting started guide. You can go to linkerd.io/2 getting started to go through a demo to see how to set up Linkerd. And of course, if you get the chance, join us on Slack, slack.linkerd.io. Love to hear from you, and I'll be around in the chat to take questions.
Cool. Thank you, Jason. It's great to see you on both days. And I have to admit, it was after hours, so I stepped away a little bit. And I know you were saying you're a little frustrated that, the demo ended up working out, but in the beginning you had to work on stuff. So good to see it went really smoothly.
I was sweating for sure. And then if you liked if you like that Linkerd hat, if you are a Linkerd production adopter, you can go ahead and just send a pull request to the users page in our Git repo, and we will send you your own free Linkerd swag. Just knocked off the table instead of showing anybody. But.
Yeah, that's fine. And I guess we were talking earlier about being in the CNCF. So I guess that's also at the shop. Do you guys have a Linkerd shop?
Oh, I don't know.
Oh, yeah. Oh, I forgot. What level is Linkerd? Is it sandbox incubating? Or?
Incubating, but we're putting in for graduation. So fingers crossed.
Okay, yes, same here. Yeah, for Flux. So yeah, I believe so. With incubating, we're just going through our checklist as well of all the new things we can do, and we found out that there was a store, so we had just pitched that. So yeah, awesome. maybe your colleagues that have set it up. So if anybody wants to go put in money, they can do that as well. But obviously, there's a free way to win or to earn, right? Much more exciting to earn it. So cool. So thank you so much. Thanks. Great to see you again. And up next, we're going to be talking with Dan, who I had pitched earlier. Dan Papanzea is, hey, how's it going?
How are you, Tamao? How you doing?
All right. As you have a podcast, how long have you had the Pop podcast?
It's been almost a year and 3 months at this point. I think we're at 73 episodes. 75 is coming at the end of this month. We have a lot of stuff going on, but yeah, it's called the Popcast, and it basically is it's about people in cloud native, DevOps, Kubernetes. It's kind of the stories behind the code.
Excellent.
Click that like and subscribe button at Popcast Pop.
Exactly.
Always be pitching.
Yes. I don't know if it's just me, but your audio sounds a little bit low for me. Is it just me? I'm going to just check with Stacy. It's a little bit low. So I'm not sure if there's anything that you can do on your end or project. It sounds like you are.
How's that? Is that good?
Yes.
A little better? Fantastic. Oh, all right. Like to have the booming voice, all y'all. All right.
Exactly.
Hopefully I didn't blow out your eardrums. So.
No, not at all. And it's great to actually meet you in person. We've been on different threads and stuff, and you've been doing great work with Lee on our team. So it's been really exciting to see your talks. So yes, and in fact, you were first working with Lee, and then you guys were going to give a talk, and you said you had some kind of conflict, so you had brought somebody else, and he was also very excited by the person that you brought in. He said, "This is all good." First for a second, he was just like, "Oh, I'm not speaking with Dan," and then he's like, "No, it's great. It's great." So glad it all worked out. So
it was like Pulp Fiction. I was like Marcellus Wallace. It's like I'm sending in the wolf. Don't worry.
Yes, you pretty much.
So
Yeah.
it was good. Yeah.
It sounded like the wolf. So excellent. With that, I'll hand over to you and look forward to your talk.
Awesome. Thank you so much, and thank you for having me on. So I'm going to share my screen, if that's okay with everyone, if you all can see this. So my talk today is GitOps and runtime security. Your cookies need a new recipe. I've given this talk with different technologies through the course of the year, and this is actually my last talk on cookies and GitOps and Cloud Native. My name is Dan Papandrea. I'm the Director of Open Source Community Ecosystem for Sysdig, but I work on the project called Falco, which is a runtime security tool. So when you're baking cookies, right, your first ingredient, right, if you're baking cookies but also talking about runtime security, your first ingredient is syscalls. So what are syscalls and why syscalls? When you run a program, you are making system calls. So when if your program's entering the kernel to perform a task like processes or network or file I/O, those things are touching the kernel, right? And so that's what system calls does. Your second ingredient is eBPF, which stands for Enhanced Berkeley Packet Filtering, and Falco. So what eBPF is, it's safe, efficient Linux kernel access. So that allows you to run kernels into the Linux kernel without having to submit a PR to actual kernel updates, which usually are a lot slower in terms of the delivery aspect of it. You can access kernel activity without risking your system stability or security, and they're very useful for different things like security, monitoring, and troubleshooting. So now let's talk about Falco. So Falco is a CNCF Cloud Native Runtime Security Incubating project. We're also in the process of graduation as well, and it's created by Sysdig in 2016. It basically detects unexpected application behavior and alerts on threats at runtime. And what does Falco do? It uses system calls to secure and monitor system by parsing the system calls from the kernel at runtime, asserting a stream against a powerful rules engine, and then alerts when a rule is violated. So in terms of the architecture, briefly, again, it's where we have this kernel module, and then we have these libs that filter expressions that are suspicious events or alerts and rule sets, and then can output to things like syslog, file, standard out, shell, HTTPS, or gRPC, which you can output to something like Prometheus or Falco Sidekick, which, by the way, is community contributed. And what's great about it is it can connect your Falco to any parts of your ecosystem, the things like, I don't know, Flux or Lambda or, you know, or any of those level of functions. So it's a sidecar that runs, and I'm going to demonstrate that. Falco already ships with a default set of over 120 rules that are syscall level rules, rules like creating symlinks, or, you know, somebody executing into a shell or being in a directory that they shouldn't, but also Kubernetes audit log capability. So if somebody's trying to create a namespace they shouldn't or anything like that, you'll get alerted to that effect. The third ingredient is GitOps. And what I'm going to demonstrate today is a real, with Flux, excuse me, is I'm going to demonstrate a cookie, somebody coming in to take a recipe, right? So like, and so we're going to go in and use GitOps and use Flux to be able to automate a rule change, a Falco rule change in real time. So that being said, I'm going to go ahead and go into Visual Studio. Bear with me 1 second. Okay, hopefully you all are seeing this. So I have, let me go ahead and screen here. I have this cookie recipe that's on screen. So there's GitOps Day cookie recipe, and I've shared this. I'm using something called Civo Cloud, which is a K3S managed service that allows us to just spin up a quick cloud, or spin up a quick Kubernetes cluster. And so let me go ahead and show you. So if I go here, you can see my cluster is up. Let me sec here, and then if I go K get nodes here, and then K get pods, or kubectl, excuse me, all namespaces. I've deployed Flux and Falco, all in this bakery setup here. So if you see here on the left side of the screen, you can see there's my, we're calling it the bakery. We have our recipes, we have our YAML, and this is all being kind of managed by Flux. So this has been deployed. I've also deployed the Falco Sidekick as well. Okay, so nothing is being addressed here. So I'm going to go ahead and I'm going to show you this recipe here. And so if you see here, this is just a standard daemon set deployment. And you can see that I have this mount path of user share nginx HTML. And there's my recipe of the thing I just showed you we deployed. Now, if we go into Helm real quickly, we can see I have this rule. And what I want to do is I want to kind of change this. And so this is the whole point of this. If I have rules, I can use, and I've heard this on a lot of ups, is basically like, well, I have this rule. I want to kind of manage my rules as code. I want to be able to manage these things and be able to say, look, if something happens, like an intrusion or anything was like that, I want to enable this and I want to do it quickly. So from this perspective, I'm just going to try to check in this change here. So I'm going to go emergency. So let me show you the anatomy of briefly about a rule in Falco. You see there's a rule definition. This is all YAML, right? There's a description, detect tampering of cookie recipes. There's a condition. And if you look at the conditioning aspect, this is like a file descriptor name, starts with user nginx. I showed you that's where we've stored in our deployment the detail there. So I'm going to go ahead and save this. And you can see here, I'm going to go ahead and commit my change. I'm going to say change rule to emergency. And I'm going to push. Now, Flux, as it stands, right, is going to kind of look for those changes from customized and all of those things and be able to tell us, okay, well, let me go ahead and get pods. See Falco's running. It's going to make the changes. If we go into our repo, we can see that this has been pushed 24 seconds ago, and this is the time it's been pushed here. We can see. So I'm going to go ahead and get pods, HW. So you see that it terminated because right now those pods are just getting updated based on that rule change because I've changed this priority. Or if I wanted to add additional rules, I'm checking in these rules as code, that happens. So let's go ahead and try to attack our cookie recipe. So we're going to kubens Okay, and if I go kgit pods, there's that Nginx deployment. That is this right here, right? It's exposed on support 6000. And I'm just going to try to exec into the pod. And I'm in the pod. I'm going to do something like this. I'm going to try to moor the Etsy. If I'm an attacker, I'm going to go in there. Because if you, and again, I have Falco running in this deployment. If I didn't have this, I wouldn't know who was coming into my environment, dropping a payload or trying to go in there. So I just did Etsy's shadow, right? And I want to go to user, share, Nginx, HTML. And there's my index.html. If I was a hacker, what would I do? I would probably drop my payload in this directory. I'd come in, I'd curl in and out, grab whatever whatever payload that I want to do, some rootkits or whatever I need to do there, right? So I'm going to try to move this. Call it hacked.html. Can't move it. It's read-only file system. So maybe I go another route. So let's look. We're going to go here. We see our UI is up and running. So we can see here. Look at that. There's our warning. We have our GitOps Day 2021. It also said read sensitive file. And you can see here, this shows us exactly that file descriptive Etsy shadow was touched. It shows us which pod name this happened on when I moored Etsy shadow, right? And then if we look at our GitOps Day, remember that description here? Warning, cookie recipes have tampered. Secure your cookies. That's that description I showed you. So in real time, we were able to show that this basically rule was updated in real time. Let me go ahead and do a refresh here. And there we go. So again, we have this capability for showing, and all of these, again, you have all of these other rules, but all of these rules out of the box, but you can add additional ones as well. So there's other things you can do responding to threats. You can update Falco rules based on threats using Flux, because again, if we think of GitOps, what are we doing? Reacting quickly to things. We're using these functions. We're using rules as code. We can trigger actions. We wrote response engine, and there's a forthcoming one we're writing on Flux as well with Falco, where basically we can have it do trigger actions. Like you can then have it trigger, we call it the response engine, trigger something like a function of some sort. Or maybe have it like do a mem dump or something like that. So those are things, as the sky is the limit. You can use things like Knative. You can use things like Lambda functions. You can use things like even CI/CD functions, right? So there's that. But also you can enable and disable outputs. So Sidekick, as I talked about here, has all of these outputs, right? If we look in our Helm chart that's here, right? We can see that you can enable certain functionalities here. So if I want to output this to Slack or Prometheus or any of those types of things, I can just update this Helm chart and have that in real time. Again, using the power of Flux and Falco. Now, if you want to get involved, and I'm sorry, I'm blazing through this right now, but if you want to contribute to Falco, we're at falco.org. We're also, there's a Falco project in GitHub. So if you go to Falco Securities/Falco, we're on Kubernetes Slack as well. So if you go to the Kubernetes Slack, there's a Falco channel. And also like getting involved in the community in terms of like you can do things like getting involved at the core engine perspective, integration and tools, rule sets, as well as documentation. So that kind of, tells you a little about what's going on with Falco. But again, if you look at like the response engine as a capability, those are things that were actually contributed by the community. And it was not done by maintainers, which is really cool. That repo that I just showed you that had, here, I'm going to go ahead and show you this again. But basically, if you look here, this whole, I just did a git pull, did a couple of changes as you saw here, but you have this beautiful recipe that I showed you here that you can take. It's less than a minute. Again, I spun up something called Sivo Cloud, and it's, I spun that up, and then I just basically used Flux to be able to, use the repo to use like real GitOps functions to deploy this whole cluster, as well as Falco, Flux, and all of those capabilities. So if you go to github.com/danpopsd/falco-flux, you'll be able to do just the same as what I did here and maybe even improve on it. So PR is welcome on that one if you all want to do that. I want to give a shout out to the first time I actually been really working with Flux a lot is based on the Kubernetes at Home group. And they use Flux a lot to be able to show capabilities, and I was floored by the capabilities you can do with Flux, and that's where we got the genesis of trying to work with Flux and Falco, because there's a definite need for this. Because basically, when you, from a security perspective, as a security professional, being able to protect you at runtime, to me is a capability I think that is enhanced by using GitOps functions. That is my talk, everyone. Any questions? Maybe I should go to the Slack channel that has the questions.
Oh, yes. Thanks for that.
Pop is the man, just by the way. I just wanted to insert that. Pop is so cool.
Nah, you are, man. Damani, good to see you, man. It's such a pleasure. I think last I saw you was in an airport somewhere, dude. So,
right.
yeah.
So sorry about that, Tamao.
Yeah, no, it's cool, man. It's cool. It's so pleasure to see you. So
no problem at all. In fact, I'm seeing that people are typing. So if you guys want to chat, we can wait a little bit. Because yeah, we're actually about 5 minutes early, so we have some extra time for questions. So I'm just waiting to see. Also check to see if anybody else has.
Sneha, how are you feeling? I hope you're feeling well. I know you were down for the count for a little bit.
Yes, it's really annoying because, I've been pretty much one of the very shut-in people, very dedicated to the masks and such. And it just felt like we got vaccinated and we were finally like, okay, let's go do some outdoor dining. And we did even a few indoor dining bits. And it's like within days, I was like, oh God, what is this? And it's pretty interesting how clearly it's a cold. It is just not viral, but I went and got tested anyway, just in case. It's pretty exciting. It was a 15-minute test, so I got the results right away. And so, yeah, I don't have COVID, but it was very lingering kind of cold. So but I was glad that it was able to work out before this event. It was basically on a very strict no speaking protocol with all my friends.
Sure.
Yes.
Glad you recovered.
Yes.
To a certain degree. Yeah.
So I see the typing. Oh, here we go. All right, I'll read the question to you. So thanks for the demo. I've used Falco to alert on individual clusters. Is there some mechanism to federate these to a management cluster? Thanks for the great question.
Great question. And what I see is most people will take the outputs and do it to some type of downstream SIM of some sort, right? I know, you can use things like, I think we've had some things that you can also, like Cortex and those type of things. I believe that you all have, capabilities from that perspective. And I think in general, what I see people doing from that perspective is taking the tool and, doing things like outputting to Prometheus and being able to really kind of digest what they're looking to do, but it's mostly through some type of downstream SIM, if that makes sense, Serge.
Oh, yes. Got an alert.
Cool.
Great. Cool. Well, I really appreciate it. Yeah. And
if you're not following Pop on Twitter, make sure you do. Make sure that you get onto the Popcast. Great content being put out there.
Thank you so much. And I'll tell you, I had Alexis this week from Weaveworks, and he's fantastic. It was one of my favorite interviews because he's so candid and he's one of the leaders of seeing, from a cloud native perspective. And it was, I really, shout out to Alexis and the Weaveworks team. I'm very, very pleased to be working with you all and doing this session with you all.
That's great. Yeah, I'm looking forward to listening to it as well. As we mentioned, it's on Twitter. So you have your own handle, but you also have a handle for the podcast, the Popcast Pop.
Yep, at Popcast Pop.
Okay, great. I see more typing happening, but I think we're going to wind down. So we'll go to our music now. And please, continue your questions in Slack, and Dan will see you over there. So thank you, Dan. So with that, DJ Desired State, are you ready?
Mãos para o alto, novinha, mãos para o alto, novinha. Porque hoje Olvidar Feel my spirit traveling into space and time. When a voice commands me, say, seek and ye shall find. Beauty all around me, pretty wonderful miles and miles. Then the voice informed me, say, son, you watching the river Nile. And this land is sacred, seen by very few. And you for appearance, knowledge, now I pass on to you. I am the Orisha, the sacred god of the Yoruba. Use these words to call me where you are, whether near or far, just say. Aladoye, Aladoye, Aladoye, Ayabasha, go worry, loye. Aladoye, Aladoye, Aladoye, Ayabasha, go worry, loye. Aladoye, Aladoye, Aladoye, Ayabasha, go worry, loye. Aladoye, Aladoye, Aladoye, Ayabasha, go worry, loye.
I mean, I've been to a lot of online virtual conferences over the past year, and I got to tell you, I'm maybe a bit biased, but the vibe and the mood that we got here at GitOps at GitOps Days is unmatched.
Definitely great. Well, it's also great not only to have fantastic music, but to see each other, right? Like this is like, we love hanging out, and it's great to see even in the context of a conference and emceeing, and also just seeing these great speakers. It's really inspiring.
It
I'm really
is,
enjoying
it
a
is.
lot. Yeah. And thanks for joining from the East Coast, because I know it's 3 hours later than me. So I really appreciate it. And in fact, I think you might be signing off a little bit soon after this. So I just wanted to make sure you had a chance to.
I'll be around, but I'll be tagging in and out. I got I got the little ones.
Yes, you'll be juggling the little ones.
So I'm trying to.
No, it's great. I forget how many little ones you have.
Three now. Yeah. So our girl, she was born in during GitOps Days last year. So
Yes, that's right. I remember you were like, COVID's not going to stop me. I'm going to be there. That was fantastic. So speaking of speakers, I think you're going to be introducing our next one.
Speaking of visualization, a lot of people want to visualize their journey, and we have the right person coming to the stage. Samaya is going to talk to us about some of the work that she's done in regards to visualizing the GitOps journey and the journey of the container. Samaya, how are you?
I'm good. Thank you so much.
Great.
How are you doing?
Doing well. I'm excited to hear what you have in store for us.
Awesome. Thank you.
The stage is yours.
Thank you so much.
Bye now.
All right. So hello, everyone. Let's talk about visualizing the GitOps container journey.
So a bit more about myself. My name is Samia. I'm a software engineer based out of San Francisco. I work in the commercial software engineering team here at Microsoft. And this is where my journey with Kubernetes began. We help partners with Kubernetes-based solutions and share results as open source projects. So before I jump into any GitOps observability principles, let's do a very quick recap on GitOps. I'm sure you're all familiar with this, but in a very simple GitOps process, the developer pushes code to their Git repository, which kicks off a CI build that pushes a new Docker image for that code change. The cluster is synced to a config repository, and Flux is running on the cluster, which can pull the Docker image and deploy the changes pushed by the developer. So in a typical workflow, you have a release, you have an observation, or your orientation around what you just released, and then you go and make a decision based on your observation. In GitOps observability, we're mainly concerned with the left side of this, which is all about your acting and releasing. And there are already tools out there that people use for in-cluster monitoring. Being able to know how long something takes to get to your cluster, being able to see how it's getting there, if a pull request is blocking deployment, or if a deployment did go into the cluster successfully but introduced a breaking change. All of that is very important. And that's what we want to tie back to the Git commit it came from. So that's the area that we're focusing on. As we've been working with several customers, we have seen problems start to increase with more microservices and organizational complexity. The reality is teams work in branches. Oftentimes, applications will be deployed from branches other than your main branch. And if you're embracing a microservice architecture, you most likely have services across many branches. Coordination between developers and operations teams also increases complexity. This can get even more complicated if you're multi-tenant or you're performing ring deployments. Some teams may perform ring deployments or flight features, which further adds complexity to how we release software. Another thing is inconsistent feedback cycles. Let's say you're working with several teams and a couple of them need to do some rollbacks. How does it look in the GitOps view? How do we know what's going on? These are some of the challenges that we've seen with our partners. Now let's consider a quick scenario where GitOps can be applied. Fabricam Trivia is a small team building a trivia website. They're now trying to increase their usage by integrating several APIs to their website, which are being built by different teams. So let's see what their scenario looks like and how GitOps can help them. So far, they had a monolith application, and now they would like to modernize their setup to include deployment of microservices. Perhaps each of the different API trivia topics could be served by a different API module. And the main idea behind a microservice architecture is applications are simpler to build and maintain when broken down into smaller pieces that can work seamlessly together. So these are the different APIs they will be integrating into their infrastructure. Fabricam Trivia engineers learn about GitOps, and now they start to store Helm charts for their environments in a separate folder in their Git repositories. So the CI/CD pipelines will generate these charts into Kubernetes manifests, and Flux is running on the clusters, which syncs the generated manifests to the cluster. So as we can see in this figure, they have quite a few developer teams pushing code into their repositories, triggering CI builds. It generates several Docker images. Then approvers are another set of individuals who approve the changes to be deployed into the infrastructure by generating the Helm charts through the CD pipelines. So this architecture has finally allowed Fabricam Trivia engineers to incorporate work from several teams. But now, their developer Danny and operator Oliver run into some new problems. They're finding that managing multiple microservices pushing into the same cluster has become complex. There's so many CI/CD pipelines, and tracking is difficult. For example, each microservice has a pipeline for their CI build and one for their CD build, resulting in 2 end pipelines. They also have difficulty versioning. And what that means is developers have trouble testing their beta versions with stable versions of other microservices. So they want to decouple microservices from each other. And lastly, their operator Oliver is lacking observability into what gets deployed, versions, audit logs, and he has trouble fixing issues if something makes it into production. Fabricam Trivia engineers realize they would like to test their features in a single cluster to cut cost because they're a small company. They learn about the concept of deployment rings that allow multiple environments to exist in a single cluster with the help of a service mesh. So deployment rings basically allow you to group users into cohorts based on the features of your application that you wish to expose to them. It's kind of similar to A/B or canary testing, but in a more formalized manner, in which you roll changes from a smaller ring into a larger ring. This would allow them to test their features in the production ring, production cluster within by just setting a header on the ingress routes. And each developer would be able to test features in that production cluster without disturbing the main production ring. So here's how a developer working on a new feature can first test their changes in a ring within the same cluster, and then advance it to a header that's being used by early adopters of the application. And then finally make its way to the production cluster when it's been well tested. This concept of deployment rings has been widely requested in our interactions with all of the customers that we work with that are using GitOps with Azure. Fabricam trivia operator Oliver is on call, and one night he receives a call at 3 a.m. He finds out that there's a bug in production that needs to be addressed immediately. And he probably needs help from the appropriate developer to fix this. So he wants to be able to glance at a page and find out the right contact whose feature recently made it into production. He would also like to know how long it would take for that deployment to go through, approximately, so he can update the customer on the line. So all of this leads us to ask, what is the ideal solution that we want for GitOps observability? We have seen that our customers are using different CI/CD orchestrator tools. Some are using GitHub Actions with GitHub repos. Some are using GitLab. Some are using Bitbucket. Some are using Azure DevOps. The idea is the GitOps observability tool should be portable. Even within a company, sometimes you have different teams using different CI/CD tools. We want to support different storage solutions and container registries. A tool that can be plugged into a new ecosystem easily is desired. Secondly, we want the solution to be lightweight, fast, and plugged anywhere by just launching a Docker image. This kind of ties back with our observation that customers may want to embed this software internally or host it behind an authentication layer. A lightweight solution would allow for easy plug and play. Third, we want it to be secure and not require access to the cluster directly, and also work behind custom security configuration that can be set up by organizations easily. There are already many tools out there that offer in-cluster monitoring, so we don't have to reinvent that wheel here. Fourth, we want this solution to scale easily as microservices grow. One of our recent customers had a really large number of microservices that calls for a very good user-friendly filtering experience, along with the need to handle large deployment data in the storage. Fifth, we want to support different deployment strategies, such as deployment rings and environments. As we were working with a customer who wanted to test features in a dev cluster, we found that developers increase productivity by being able to create a new ring easily by creating a branch with a specific naming convention, and then being able to test their feature and tear down that ring after. It would be ideal to monitor these rings in our observability tool as well. And lastly, we want this tool to help us predict the time and success rate of the deployments by just glancing at a page. This is really helpful if we are able to see durations for the last few recent deployments. Now we look at one way we solve this with our recent attempt at Spectate. So Spectate is our GitOps observability tool that provides a dashboard with a tabular view into the most recent deployments. It helps to answer questions such as, what microservices are running from CI all the way to the cluster? What deployment rings are they tied with? Who are the authors of these deployments? Is there a deployment waiting to be deployed into the cluster? And if it has been deployed, who approved it? What changes were made in the Helm charts or the cluster config? Were these changes synced successfully by Flux? And as we discussed earlier, this gives you insight into the journey it takes before it gets to the cluster. So let's see a quick demo. Danny from the trivia team loads up the dashboard and glances at the activity in the cluster. The image below that you're seeing is a screenshot from Spectate. Yvonne, one of the developers on the team, just merged a new change into the dev branch. And as a result, you see her deployment at the very top, with some columns not filled out to the right, as the deployment is shown to still be in progress under the state column. As the deployment is progressing, we will see more columns be filled out. Once the Docker image is done creating, we can see that the image creation column has turned green. As a metadata update completes, that turns green as well. And actually, this change is made by creating a pull request against that repository to allow someone to approve those changes before they're merged in. At this stage, someone looking at the page can help unblock a pending pull request to allow our developers to test their changes in the cluster. And once that PR is merged, it updates the merge by column with the name of the approver. And that merge kicks off the final step in this deployment process, which uses tools such as Helm, Fabricate, or Customize to generate the Kubernetes manifests and push them into the manifest repository. Flux is watching this manifest repository, and once the change is picked up by Flux, Flux will push a tag to the repository to indicate it has synced to that commit. And it looks like the change was picked up by Flux. So this is our original version of Spectate that is still using Flux v1. It uses the tag name to determine the cluster name. And our assumption here is that there can be multiple clusters syncing against this manifest repo. I just want to add that the experience you're seeing currently is agnostic of the CI/CD tools. So for example, Spectate builds a similar user experience for GitHub Actions, GitLab repositories, and Azure repos. We would love to keep adding support and expanding support for more tools as we work with more partners. So from there, we can, we can go to the cluster and run kubectl get pods, and we can see that the pods were recently updated. Another tool that we created is called the Bedrock CLI. So we can set up the Spectate dashboard using the Bedrock CLI. And this allows you to create GitOps pipelines easily and also hooks them up for observability. This way, Spectate already has all the data it needs to start showing you that dashboard as soon as you launch it. Bedrock is our culmination of experience on how to run workloads in Kubernetes from working with several teams internally and externally. So this is a very simple Bedrock scenario. Our friend Danny wants to download the CLI and launch the dashboard. So he can run the setup command and get the GitOps pipelines going in just a few minutes. And then Danny can pull up Spectate by running the dashboard command. This demystifies GitOps for a lot of people by giving you a rocket to go from point A to point B. So a typical Bedrock process goes as follows. A developer in the team pushes a code change into the code repository, which kicks off the CI build that creates a Docker image and pushes it into a container registry, such as Azure Container Registry. And that change kicks off the second part of the Bedrock process in which metadata is updated, such as the Docker image tag or any other config set up by the team or required by the Helm charts. We have a concept of something called a high-level definition repository and a tool called Fabricate, which relies on Helm. It allows you to deal with higher-level abstractions of YAML, and this is a great way to deal with multi-cluster and multi-region setups. So after this PR gets merged, another pipeline is triggered, which is the final step in the Bedrock process. This tool, again, uses Fabricate to generate that high-level abstract YAML into the Kubernetes YAML. And Flux is running on the cluster, which is able to sync to this change that's pushed into the manifest, and it can pull Docker images from the container registry. And finally, Spectate is powered by a storage, which captures all these steps in the Bedrock process to show the visualization. So what exactly is Bedrock? With our customers, we found that a tool that can automate setup and creation of pipelines, scaffolding of the high-level definition repositories, and a quick way to get the dashboard up and running improve the GitOps onboarding experience. With Bedrock and Fabricate, it's easier to set up a high-level abstract YAML that describes the config in the cluster, and just two simple commands, fab install and fab generate, that generate the YAML into the manifest. Here are two examples of recent projects where we applied Bedrock. So in the project that enabled COVID-19 exposure notifications across the United States, we used it in the continuous integration and deployment of the national key server, which allows for the anonymous identifiers known as temporary exposure keys to be exchanged and users notified if they have been exposed. We also applied it in our most recent Bedrock project to deploy Gen 3, which is a data platform to build data commons used widely by researchers and bioinformaticians. Here's the fun part. Let's see how Flux v2 can improve Spectate even more. So as most of you are already aware, Flux v2 comes with a notification controller that can notify a webhook for alerts in the source, customize, or the Helm controller. These notifications can be utilized in tools such as Spectate to improve them even more. GitOps Connector is a tool built here by a team at Microsoft, which sits between the notification controller and CI/CD tools. It sends enriched notifications as JSON objects to all of these tools that allows for better observability. And it can also notify n number of subscribers with this data as well. This helps to close the observability gap between the orchestrators and Flux. So here's an example of how the GitOps connector improves the observability in Azure DevOps in GitHub Actions. It receives notifications from the notification controller in Flux. It processes it and it sends this JSON to the APIs in Azure DevOps and GitHub Actions. And then the result is a visual on the manifest commit repository that allows the users to see the status of their commit on the cluster. So here's a quick screenshot of how this experience is looking like. Previously, if you recall, Flux v1 in Spectate was just giving us a tag that confirms the manifest commit that it was synced with. And now with the help of Flux v2's notification controller and the GitOps connector, Spectate is able to show notifications from the customized controller with these timestamps. And the user can click under the synced cluster column to open this panel. We're currently still in the process of enriching the notifications from Flux v2 and Spectate, and we applied some of these tools in the Gen 3 project as well. So here's a summary of what we talked about. We learned about the GitOps observability, what we're focusing on inside of that, what an ideal solution could look like. We talked about how we address this in Spectate, and how Flux v2 could improve these even more. Thank you so much for joining today. Happy to take any questions in Slack after.
Thanks, Samia. That was fantastic. Yeah, it was really great to hear your colleagues, Chris and Jonathan, yesterday for some of the opening keynotes and talking about the great GitOps types of things that you've been doing, especially, yeah, your backstage work here has been really fascinating to watch over I guess it's been a couple of years, at least I've been aware of it. I don't know if it's been around for longer, but.
Yeah, I think a couple of years now.
Yeah, excellent. So I'm really glad that you submitted and that you were looking to talk about this. So yeah, if anybody has any questions, we'll continue the conversation in Slack, the GitOps Days Slack. And that reminds me as well, as we'll be wrapping up, we'll have the Slack continue to be open, and Stacey will be posting how, like, a lot of times we'll be continuing the conversation. A lot of people come up with questions later, speakers share with audience members. I'm just seeing a post, someone saying great session to Samia, so I really appreciate it. So yes.
Thank you so much.
Yes, thanks again, and we'll see you next time.
Thank you for having me.
Yes, thanks. So with that, we have our next speaker, also from a company that was represented yesterday in our keynotes. We have Paul Roberts from AWS. It was really great to see Nathan from AWS speaking yesterday for part of our keynotes, to see how, right, like a lot of what we talked about is GitOps is one thing that so many of these speakers are saying is now an essential part of how they set up their teams and operate and communicate. But to be able to do it at scale, right, it's really important to hear from the cloud vendors from Microsoft and AWS on the various areas that they're focusing their energy to bring GitOps to their customers. So Paul, really great to have you here and looking forward to your talk. I'll hand it over to you.
Great, thank you so much. Let me just share my screen, and I hope you can see everything. And perfect, so let me go ahead and kick off. So good afternoon, good evening, everybody. My name is Paul Roberts. I'm a principal architect here at AWS. I work with some really interesting customers and some of the most influential companies in the world. I've been working with the open source community for some time, back even before Kubernetes really got off the ground, and GitOps. I was doing a lot of work with OpenStack, as interesting as that is. Today, I actually sit on the steering committee for the Spinnaker project, so I do a lot of work with the Netflix folks, and I'm just really incredibly excited to be speaking with everyone today. And really in this presentation, I want to talk about some of the tooling that we're seeing here at AWS. I mean, there's a lot of tools out there that folks are using, and I want to drill into a couple of them. But I also want to take a step back in the past and just talk about, how things used to be building up to, where we are today. So with that, I'm going to go ahead and kick off. And I think there's this whole notion of, as engineers and as developers, one of the things that, we often look at is there's folks are building new technologies. And, I see it quite a bit, with teams that I'm working with, both internal and external, is that they don't always understand or appreciate why something was built the way it was built. And, at Amazon, we have this approach, and we call it, and one of our tenets is respecting what came before. And, I think with GitOps and everything that's happening today, it just makes a tremendous amount of sense. But we need to be considerate of how we used to do things previously. And, I saw a prior talk from Kelsey Hightower, and I think he also touched on this a little bit. So I'm going to talk to you a little bit about how it started for me. So I'm going to take you back a little bit to 2006. And in 2006, I was working at Sun Microsystems. And for those of you that aren't familiar with Sun Microsystems, this was, a legacy hardware vendor that, had built a lot of platforms, hardware platforms, Spark. They had an operating system, Solaris. They had technology like file systems like ZFS. And I was brought in to manage data centers for them and manage key infrastructure for them. And one of the first projects I had was, they said, Paul, we want you to come in and we want you to manage this appliance that we have deployed in US data centers all around the country. And I said, well, that's not too difficult to deal with. That's not a big problem. I mean, it's not like we have thousands of data centers. I can easily manage that. And then the team said, well, you know what? Not only do we want to use US data centers, we also want to use EU data centers, and we want to have these appliances running in there. And then the team said, well, we don't only want you to manage the US and EU data centers, we also wanted you to manage the Asia Pac data centers and all the appliances that are running in there. So we had thousands of appliances that were deployed around the globe. And we had a pretty lean team that was responsible for deploying these, managing these, and the full life cycle. And not only was it difficult to manage across all these different locations, and again, this is back in 2006, so it wasn't, AWS multi-region, multi-AZ. This was using, Equinix facilities or even our own facilities. So it was very manual back then. And so not only was it, the scale was kind of interesting, but for those of you that may remember is that Sun didn't only use one operating system. We used both Linux and we used Solaris. And not only did we use just Linux and Solaris, we also were multi-architecture. So we had Spark and we had x86. So it was manage all these appliances in all these facilities around the world, manage 2 operating systems, and manage 2 different architectures to actually do these deployments. So how the heck do you manage all of these devices? It was super stressful. And so what was happening at the time was, every time we would do a deployment across all these devices, it would take teams of 2 or 3 people up to 6 weeks to do these deployments. And why did it take 6 weeks? Well, number one, there wasn't really any automation. There wasn't any reconciliation to make sure that this was actually working correctly. And it generally took 2 to 3 people to do this, because as we all know, like maintenance windows around the world are at different times. And at the time, we could only touch so many devices at once. So it was a huge pain point for us. So what did I do? What did I come up with? So I think, again, going back to the 2006 timeframe, how would people automate back then? So I started thinking about it. I was like, well, I can use some SSH automation. I can push some keys everywhere. We had this really cool file system, and it's still around today, which is the Zettabyte file system, or ZFS. We said, we could create some snapshots. And then the third part of it was pulling out some Perl kung fu here, where it's just like, hey, you know what? I want to leverage that. And I don't think there's a whole lot of Perl today, but I ended up building a lot of tooling that would use SSH, ZFS, and Perl to help build this automation. And so what did that look like? And at the end of the day, I don't know how many of you have seen this, but it was kind of a lot of spaghetti code. And that spaghetti code, it was pretty great when it was out. And it wasn't called the Perl hotness. It was actually called Patchmaster. But these releases, instead of taking 6 weeks and 2 to 3 people, and ended up taking now one person, generally myself, or another on-call engineer, and it would take about 1 to 2 hours. So while this was successful, when we started looking at the code and everything that was being deployed and how everything was being reconciled and how everything was being monitored, it certainly wasn't ideal. So then what was next? So there has to be a better way. And, fast forward, when I think about like Puppet, I think Luke and team, I think Puppet was founded in 2005, and I think their first enterprise release is in 2010 or 2011. So it was very early on where these automation providers started coming on board, but it was really interesting. But you kind of had to learn their own specific languages. They had their own DSLs. There was a lot of boilerplate that you had to work with. But the great thing is that you didn't have to work with my Perl spaghetti code anymore. You could work with something that was easily repeatable. And not only that, people at the time, we weren't just using Perl. There was also things like expect when we were trying to manage and orchestrate network deployments or storage deployments. It just really depends. So using this imperative model with whether it's Chef, Puppet, or Ansible or Salt, it just really was a step in the right direction. And I wish I had that, but there were still gaps. So there needed to be a modern approach. And we're kind of going in that direction today with that modern approach on how we're doing that. Specifically today is how folks are moving from, on-prem or, managed data centers into public clouds. And, even with Chef or Puppet, there's a lot of community engagement there. I think when we started moving to the clouds, we started looking at new patterns. And some of these new patterns really flipped a little bit from declaring the end state, but from an imperative approach to now they wanted to declare an end state. And when you're declaring these end states, you could be using CloudFormation or you could be using Terraform. And not only could you be describing how you want your infrastructure deployed, it could also be your applications. So for me, when I look back, on my past and I had to manage all these appliances, it would have been great to be able to use either of these technologies to lay down, the frameworks and be able to handle the upgrades and be able to automate as much as I could. But, moving forward, there still was more work to be done here. And looking as we're coming up to, modern times, people have been writing their Chef or their Terraform code or templates, and they decided, well, instead of using specific DSLs or writing in YAML, I want to write my infrastructure code or my application code actually by code. And this is something that we're starting to see at AWS. So it doesn't have to be TypeScript. It could be Go, it could be Python, it could be a different language. But now we're actually seeing folks use things like AWS Cloud Development Kit, and we're seeing things like Pulumi. And what's really interesting here is that both of these tools, what they will do is they'll allow an end developer to write their code, and that code, if it's in CDK, it will then be compiled, if you will, or translated to a CloudFormation template. And then on the Pulumi side, Pulumi is doing a really awesome job right now where they're actually building their own native operators. But historically, they've been using the Terraform providers to do this. So you could write your code with Pulumi, and then Pulumi would automatically translate that into your Terraform configurations and then deploy it. So it's saving a lot of time. But all of this is just, how am I going to be deploying my infrastructure or my applications via code? So fast forwarding a little bit, now people are looking at another way to do this, and Kubernetes has certainly become one of the standards for container orchestration and container deployment, and it's also becoming almost a cloud control plane, if you will. And so there's two key technologies that we're starting to see, and that one of them that we're actively developing ourselves here at AWS. And those are both Crossplane and AWS controllers for Kubernetes, or ACK. And what's really unique here is that instead of writing my code, my infrastructure code, or my application code in a specific DSL or a YAML file that's specific to one particular provider, now what I can do is I can say, I want to deploy my infrastructure. Maybe it's a relational database, maybe it's persistent storage, maybe it's a load balancer, and I can configure my infrastructure using Kubernetes APIs and Kubernetes manifests. And so today, both Crossplane and ACK can do this. And what's really neat is that if I start configuring all of this information within Kubernetes, it starts pushing me down the path of like GitOps. How can I fully manage this and deploy this and reconcile all of the changes that are going to happen? So one of the primary differences between ACK and Crossplane is that Crossplane today does support multiple compute primitives. So instead of just focusing on AWS, they enable other primitives and other platforms, such as like using Helm. And ACK, we focus on AWS resources. So whether that's S3 or ELB or a DynamoDB table, but again, all of this can be orchestrated through Kubernetes, which is extremely powerful. So with that said, I wanted to talk a little bit about the tools and the platforms that we have. So we just said Crossplane and using ACK can help quite a bit. But then what are some of the tooling choices that we're seeing our customers use? And there's a few out there. So first, I want to talk about Argo CD. And I think there's been a few talks about Argo today. And there's been a couple things that I've noticed from the community, and what I've heard from when I'm talking to various customers is that there's a lot of support from Intuit. And I think Intuit is a fantastic company, especially around tax day. I certainly love using their platforms, and I think the lessons learned that they've had with their own deployment and their own automation has really given them a lot of insight on how to build some amazing tooling. And so a couple standout and notable things about Argo, which I think is really important, is that it's really easy to get going today with Argo CD. It doesn't take much time at all. And I think another huge benefit for using Argo or Argo CD is that the UI is extremely clean and crisp and super simple to use. And it's really easy for folks to be able to visualize these workflows. One of the things that I really appreciate with Argo is when I'm working with the platform and I can see that something is not in sync, or I can see what my deployment is about to look like, or I can see that there is an issue with my deployment. So all of these are huge benefits. And as we all know, the project was added to the CNCF. And it has been gaining traction across our customer base. So with that said, we actually have some documentation out there for our customers if you want to get going with Argo. So you can integrate Argo with EKS, and there's a link. So I'm sure you can find that in our recording. So the next project I want to talk about is Flux. And I have to say, working with the Weave team, I've been working closely with Cornelia and Alexis. What's really neat is that the Weave team has a lot of complementary projects, and a couple notable ones that stick out to me is Firekube, Ignite, and yesterday the GitOps Core project that was just announced. So I think there's just a lot of thought leadership coming out of here, and I think again Cornelia's work with the CNCF is really helping move the needle forward, and a lot of good things are happening here. So with that, I'm seeing that Flux, I don't want to call it the standard, but we are seeing a lot of adoption here, and our customers are certainly interested in that. And these are customers that perhaps aren't as focused on having a really slick UI, but want to focus more on using the CLI and some of the automation. So we are seeing adoption there. And then I just want to highlight the partnership between Weaveworks and the Kubernetes community and ourselves. There's just a lot happening there. So definitely a project that's moving in the positive direction, and we're really happy to be working with the team. So I also included a link here on how we can integrate Flux and Flux 2 with EKS. So please feel free to check that out. But one of the other things that I want to share is that we are seeing other projects begin to consume parts of Flux to enhance their own capabilities. And here, that is with the Spinnaker project. And a couple of my colleagues here at AWS, Nima Kaviani and Rob Hilton and others have been doing a lot of work with Spinnaker. And one of the things that we've been working on is how can we migrate from an imperative approach to a declarative approach? Instead of using pipelines, how can we describe how we want the actual deployment to look? And this is called managed delivery. And what's unique about managed delivery and Spinnaker in general is that this tooling is not Kubernetes specific. And so if you want to use something like a functions platform or a virtual machine platform or a container platform, today you can do that with Spinnaker, which is really interesting. The other thing that we see a lot of is that our customers are using Spinnaker today within their pipelines. And when Netflix open sourced this project in 2015, based on Netflix's learnings and their own capabilities, we've seen quite a bit of adoption. And so we're hearing from our customers is that they don't necessarily want to move to a new platform. They actually want to augment their platform. And so as I mentioned previously with Flux, is that with Keel, we've actually done some work to integrate Flux into Keel, specifically when we do our Helm deployments. So I think there's likely to be some consolidation happening. And folks may say, if we want a great UI, maybe we'll look at Argo. If they want to use a multi-platform or multi-compute primitive, maybe they look at Spinnaker. If they want to use something that has a lot of thought leadership from companies like Weave, and they want to see a lot of complementary tools, maybe it's a component of Flux. So there's a lot of different options here. And we're only getting started on the AWS side with working with these various platforms, and our customers are still getting going. So with that said, where do we go from here? And I just want to think back to 15 years ago when I was working at Sun, and I had to deploy thousands of these devices that are all around the world, and it took me a couple hours, but back then it was taking us 6 weeks before I wrote my spaghetti code. Things like GitOps and the different tools, it just wasn't there yet. And I think respecting what came before of how we used to do it and how what our approach to automation is. And I hope in my slides you're able to see there's this evolution that's happening. And I think we're still seeing that evolution happening where standardization isn't quite there yet. But I think the innovation that's happening across these different projects is something really unique. And I think it's great to see that. So with that, I'm going to wrap up. If there's any questions for me, please let me know. Feel free to ping me in Slack. Otherwise, this is my email address, and you can find me on Twitter. Thank you very much.
Thanks so much. That was really fantastic. And I appreciate the call out. We haven't paid anybody for the call outs around Flux and Weave GitOps, but yeah, it's really great to have these different talks today that compare the different technologies, but very much from different use cases, right? Different kinds of needs. And so it's really cool to see the breakdown. I really appreciate it. And if anybody has any follow-up questions, I'm noticing some questions online. So we will be getting ready to move to our keynote. So with that, hopefully you can ask your questions to Paul either today or in the future. And thanks so much. So with that, we have our closing keynote, which is really exciting to see us and two fantastic GitOps days here. As I mentioned, we have 3 people from the CNCF. And I think, if I don't want to say anything wrong, but I'm pretty sure we have 2 that are in the TOC and 1 that was previously in the TOC. I don't want to get that wrong with Katie, but I'm pretty sure. And again, it was just sort of a shout out in the beginning. Hey, we're planning the 2021 GitOps Days, who'd be interested in speaking. So again, I just feel like it reconfirms over and over sort of these idea, how much it's taken off, how much it's in the foundation, how much you're seeing just these really established and enterprise companies really being serious about how they're taking on and bringing in GitOps into their in the way they operate and what they offer. So with that, we're really excited. Lei, of course, representing Alibaba and also representing the CNCF. We're so glad. Thank you. Hey, Lei, thank you so much for speaking. And I was just thinking, of course, well, we want to have you be the closing keynote. And I'm glad you're I think you're on the West Coast, right? If I'm not mistaken.
Yes,
and so this time totally works for you. I've seen you speak before. And so, yes, it's great to see, obviously, a company at your scale, right? Some of the things that we'll wrap up with and what we've been sort of reviewing is it's not just GitOps, but GitOps at scale. And what better way to end the day and end the event with a company like yours. So take it away.
Sure, thank you. Okay, so we're happy to be here and to talk more about how we, for example, Alibaba, as well as many companies trying to do, is essentially about building the so-called internal developer platform. And so today, I will talk a little bit about how we build a internal developer platform at web scale. So, well, the first question is, what is that kind of system is? Essentially, we call this such kind of system named the Alibaba's unified application infrastructure. So this is how the whole picture looks like. So first of all, we are the platform team, and we build the unified application infrastructure, which is essentially an internal developer platform. That's why we use this platform to serve both the developers from Alibaba Group and the developers from Alibaba Cloud. But again, they are all internal developers. For example, for Alibaba Group, those developers are building the core e-business of Alibaba, the company. For example, Taobao, AliExpress, Alipay, those applications are running on top of this application infrastructure. At the meantime, the developers from Alibaba Cloud, they're also deploying the cloud services, the cloud product to this developer platform at will. And essentially, the external customers will use our public cloud product, and those products are running as application in this infrastructure. That's why we call it a unified application infrastructure, but there are essentially it is a internal developer platform. Also, by referencing the web scale, I mean, we really are trying to run a Kubernetes cluster at very large scale. For example, in one of the largest cluster, we have more than 1 million containers running with more than 10K application deployed per day. And we have, for example, I think a dozen of such clusters running in the whole infrastructure. And we use this unified application infrastructure as a common application deployment and management system on top of the underlying data centers. And these data centers, we call them the runtime infrastructure. They are essentially the machines, right? The machine pools. And those machines, some of them are our internal machines, but some of them are actually the customers' machines. We actually do not care about that because we use Kubernetes as a common abstraction layer. But this platform actually can deploy application to not only Kubernetes, but also any kind of infrastructure, including, for example, Alibaba Cloud. I allow you to deploy application which is running even in other cloud, for example, in AWS or Google Cloud. It's totally possible. So this platform is essentially runtime agnostic. It does not care about what kind of infrastructure, regardless of its Kubernetes or not, or where the cluster is. It does not care about that. It allows you to deploy and manage application in a consistent and a scalable experience to any kind of infrastructure you want. That is also another reason we call this platform the unified app infrastructure. Okay, so a common question is how we did that, how we achieved that, right? So that's actually the main topic I want to share in this talk. It's a project which named it Kubernetes. And this project is a core component behind this internal developer platform in our company. And as I mentioned, it's the foundation for us to serve both developers from Alibaba Group as well as Alibaba Cloud. And it's also a application delivery and management system that works across hybrid environments, regardless of what kind of structure you are trying to use. But it provides you with a consistent and scalable approach to manage or deploy your application. And it's also the solution of how Alibaba scale, how our company, how our teams to adopt GitOps and infrastructure as code. I will explain more about this part. And what's most importantly is this project has been open sourced. So first of all, let's look into detail about this kind of system. So essentially, Kubernetes itself is a control plane component. So it does not run in your runtime infrastructure. On the contrary, if you want to use Kubernetes, you have to have some kind of runtime, have some kind of control plane infrastructure, which in our case we use Kubernetes. And we actually rely on Kubernetes as a control plane implementation. And the reason I will explain more later. But essentially, as long as you have this kind of control plane running, it will actually expose several APIs to the users. And the most important one of it is actually the application. It's essentially a way for developers to define the full deployment plan of this application. And in order to do that, the developers will need to, for example, claim what kind of components they want to deploy and what kind of traits, which are essentially operational behaviors they want to attach to these components. And the Kubernetes actually support any kind of component, including Terraform modules, Helm chart, customized modules, or anything you want that can be run on the runtime infrastructure. And we provide a way for you to claim anything as a deployable component. And this is actually implemented by using Q language. Q is a configuration language, a DSL. We will also introduce it a little bit later. So essentially, you can see here the Kubernetes itself will actually give you the control plane to manage and deploy application in a consistent approach by giving you a higher level API, which is named as application. And all the other systems will have integration with Kubernetes itself, or the end users can directly use this application API. And we also have a bunch of command line tools and a console to make this approach even easier. And for the runtime infrastructures, as I mentioned, it's actually can be anything. It can be public cloud, it can be a Kubernetes cluster, it can be even the edge devices. So, well, this is a high-level architectural design of this platform. Let's go to more details regarding to how to use it. So for developers or end users of this kind of system, their experience is very, very simple because they just need to learn a single API, which name is application. For example, if you want to deploy a full website to, for example, to a production environment, you just need to define a YAML file like this. And in this YAML file, it actually claims two components. The first one is a Helm chart. It's actually a WordPress Helm chart. This is how you define the values for it. And also, there is database component, which is a AWS RDS instance. And for the Helm chart, you can also claim to assign a Canary deployment strategy to it. And this Canary deployment strategy actually supports automatic promotion with metrics analysis. And the implementation of this trait, Canary trait, is actually Flagger. And for the database part, which is more interesting because it is not even a Kubernetes resource, right? It's AWS instance. That's why in the underlying implementation, this component is a Terraform module. So you can see here, this is how we enable the developer to define a real production level application, but without learning a bunch of tools, including Terraform, Kubernetes, Helm. They don't need to learn about that. They are all predefined components or traits in our system, and the user just needs to assemble them together and fill in the values which are already which has already been abstracted without leaking any underlying infrastructure details. And they can just do VLAP app YAML, and the application will be deployed and reconciled and managed by the system. And again, for the developer themselves, they just need to learn several higher level concepts like component they want to deploy, traits they want to attach. And all of these are predefined in the system. But if you want, you can actually define your own component or even your own trait if that meets your requirement. You can totally do that. And this will be enabled by Q language. So one question when somebody see this project always ask is, why use application as a main API? Why not something else, right? Why not just use, for example, Helm as the API, or why not use something more like for example, a workflow, right? A pipeline as an API. Well, so the reason we choose to use application as the main API is that we found that our end users just want to deploy, which means they need a single source of truth to capture a full application deployment. And even with the cloud resources, with the cloud services they want, with every operational behavior they want. They just want to work on a single source of truth instead of working on a bunch of distributed YAML files or even distributed API with countless different systems. They don't want to do that. Similar pattern also happens in Google or many companies. For example, Google has bulk config. So developers just write a small configuration file, which is bulk config, and that bulk config will be a full description of your application you want to deploy. So when you submit that bulk config to the bug system, right, bug will take over the rest of the things based on your descriptions of your application. This is exactly the same idea for Kubernetes. So it gives the way to describe your application deployment, including the component, the operational behaviors, the cloud resources you want to use, or anything else you want to have in order to make your application running. This is the first idea. And second idea is also the reason that we use the Kubernetes CRD as a model of this application is we want to give a declarative experience to the end user, so they can just declare the desired status of this application. This is one of the key features that we leverage to avoid the configuration drift. And this was enabled by the Kubernetes control. This was enabled by Kubernetes control loop, of course, and that's the reason we use Kubernetes as a control plane implementation, because it will reconcile the desired state of your application deployment with underlying resources and the instances on the cloud. And the third reason, but it's actually one of the most important reasons, is this kind of high-level API actually gave an easier but high-level abstraction to our end users, which make them more focused on the needs of the application instead of the details of the infrastructure or orchestration system. So that's why these are the reasons that we introduced a high-level API named application as the main API of our system. So let's do a little bit deep dive into this object, which is very interesting because this application entity is not a traditional, a CRD. Although it looks like a CRD, but it's actually not the traditional CRD because it's essentially a reference to a group of queue modules. For example, the component here, although it's a Helm chart, but in underlying implementation, it's actually a Helm release the queue module. It actually is a queue module describes a Flux Helm release. And similarly for the database component, it's actually a Terraform module, but again, it's described by using queue language. And also even for the trade for the Canaro strategy is actually also a queue module, which actually encapsulate a Flagger resource inside. So you can see here, this application CRD is not a traditional CRD at all. It's a reference of underlying queue modules. And we call those modules definitions. So that's why if you look at the code of the Kubernetes, it gives you some concept like component definition, trace definition, thing like that. So actually all of those definitions are actually queue modules. So essentially this object is a infrastructure as a code object. So by authoring this kind of application resource, you actually assemble several queue modules together into an application and fill in the values that queue modules exposed to you. So you're basically writing code, but the code will be expressed as a declarative API, which is an application resource. That is one of the unique features that Kubernetes is trying to do. So you can see there are some ideas here. First of all, Kubernetes trying to leverage queue as a super glue here. It enables the system to glue everything you want to deploy or anything or everything you want to attach or to use to operate your component. So theoretically, Kubernetes allows you to glue everything, whether it's a Kubernetes resource, a Terraform module, a CloudFormation stack, or anything that you want to use to describe or manage your application. But in the meantime, it always gives you the consistent API like this to assemble those pieces together into the full application deployment. And what's more important is this object is a declarative resource, which means there is a control loop behind this resource to guarantee the deterministic of your deployment. So you don't need to worry about there will be configuration drift, which is a common case in most infrastructure as code systems. That also explains why we use such kind of architecture. I mean, we use infrastructure code behind the CRD, because infrastructure as code like Q, like any other programming language, is perfect for building a highly extensible yet easy to use application deployment experience. But as we can see, the configuration drift is really a problem here, especially when you are trying to use this kind of system in web scale. For example, in our case, we use this platform to serve more than thousands of applications and tens of thousands of developers in the whole organization. If we just provide them with infrastructure as code-based command line tool or lightweight system, there will be tons of cases that configuration drift happen, and that is not acceptable. That's why we use a CRD, we use application resource to wrap all of these infrastructure code modules. And this enables us to leverage Kubernetes as a control plane to reconcile the real status in the clusters and the runtime infrastructures with the desired status, just like any Kubernetes resource can do. But again, this resource, the application, is essentially implemented with Q modules. So that's why it still keeps the benefits of infrastructure code. For example, it's highly extensible. So your application CRD is able to define everything as long as you provide the corresponding Q modules in the system. So it has no boundary, it has no restriction, it has no opinionated way to define the components or your application. So everything is flexible as long as you can write Q modules. That's why we use this kind of mechanism. We use Q to implement the CRD, and then we use Kubernetes control loop, and we use Kubernetes as a control plane to deploy the whole applications to the runtime infrastructure. This is actually, I will say, the main difference between the Kubernetes system with any other application deployment system or platform and service system. But in the meantime, the infrastructure code, the Q modules will be able to do for you to design your own abstractions, which means you can significantly lower the bar for your end users to use this platform. So they don't need to learn about the details of Kubernetes. They don't need to learn about the details of Terraform at all. So this related question is, as I mentioned, this is actually how we adopt GitOps. And the reason we use this kind of system to adopt GitOps is quite straightforward. I just borrowed some pictures from a very interesting blog here. This actually describes our issues very well. So the fundamental issue, I will say there are two main problems. The first is, we are a big company and we are serving a lot of internal departments, and we don't know them at all actually. And they are just like external companies to us. So all of those teams, all of the departments, they have their own way to do CI and CD, especially for CD part. So most of them are not relying on a modern GitOps infrastructure to do that. They don't even know what the GitOps at all. And in most cases, they cannot migrate to for example, a Git-based workflow. They don't even use, some of them don't even do the traditional or typical Git-based workflow at all, not to mention to ask them to use the pull request or commit-based or commit-driven deployment workflow. They don't have, or they don't want to have the concept of configuration repo. For example, some of them just relying on a configuration file as part of their source code. This happens a lot, and some have some other ways, but none of them is a GitOps-based, I would say typical GitOps-based workflow. So it will be very difficult for us to forcibly push another opinionated workflow to them. So this is the first issue, which means the typical full Git-based workflow do not work for many of them. And the second issue is, as long as you are trying to use this platform to manage a large number of applications serve a lot of teams, the complexity of this system will grow very, very fast. For example, the number of the YAML files you have to manage in your GitOps system and the patches and the YAML files you have to manage across different deployment environments, as well as the rollout strategies, the deployment and the rollout policies. Everything actually can belong into different systems. But if you want to manage all of these YAML files, all of these objects in a Git repo, the number is huge and the complexity is very, very high. And that is too much for most of our developers who just want to focus on their applications itself. And not to mention, we have to force them to learn about, for example, a GitOps layout to organize all of these YAML files or call them configuration manifest. So all of these actually raise a very hard bar for these developers to adopt GitOps. And this actually issue will be even worse considering we have so many target environments to deploy and so many applications to manage. So in that case, if we want to go into a pure GitOps workflow, it will actually bring huge burden to the end users, to developers in our company. That's why we build a system, and that system is Kubernetes. There's another reason, which is also I think need to mention, is that all of these teams already have their own CI/CD system, and all of them works very well in their own scenario. But GitOps essentially introduced a new model which is pull-based, but most of the existing systems are push-based. But the users are totally fine with that. We can't change the situation very quickly. So we also need to find a way to have a modern deployment system, leverage GitOps benefit, but it can also work with existing CI/CD system. For example, if they want to use push model, we should still enable this. So all of these issues happens a lot in companies, not only in Alibaba, but also in companies similar to Alibaba itself. That's why we build a system which can solve these issues, or I will say more like a higher level abstraction to hide the complexity and to be able to integrate with existing platforms. So this is our typical workflow looks like. So first of all, we endorse the model to split CI and CD. This is a key part what we want to do in our company. Even though, as I mentioned, there are many blockers for our end user to adopt the full GitOps model, but there are something we insist. This is a clear boundary between CI and CD. So in that case, the existing CI/CD system will also be changed, but just a little bit. So all the CI pipeline they have today, no need to change. They just connect with their source code repo and then generate some kind of artifact in the registry, and they can use existing systems fully in this case. But the reason we said there is a boundary between CI and CD is that whenever they want to do CD, they need to decide which kind of model they want. They can go with push model just like today. This is one feature that Kubernetes enabled, because if they want to go push, so in this step, they just push an application YAML to a Kubernetes cluster instead of to the runtime cluster. So in the old times, they will do kubectl apply a configuration file to the runtime cluster, for example, the production or test cluster. But in this case, they continue push. They don't need to change, but they will push a application YAML to a Kubernetes cluster, which is a control plane. So Kubernetes will then take over the rest of the application delivery workflow, and then distribute the application to the runtime cluster by exactly leveraging the GitOps workflow. For example, to leveraging Flux, and we call this subscription. So the runtime cluster will subscribe with certain artifact distributed channel, and the implementation in this subscription is actually GitOps toolkit. So that's why Kubernetes itself is always trying to leverage the GitOps benefits. But it gives the flexibility for our users to choose if they want to do push model or not. So if they choose to go to the modern way, then it will be a very typical GitOps workflow. So they will actually manually or automatically configure a configure repo. And in that repo, again, there will be a application YAML stored there. And the Kubernetes will sync this YAML file to itself. And again, the subscription channel will be responsible to pull the artifacts to runtime clusters. But as I mentioned, Kubernetes also support Terraform, support CloudFormation. So even for the cloud services, there is a subscription channel for them. Another benefit of this pipeline is, just as we mentioned, the developers always work on an application YAML instead of a bunch of underlying runtime resources. They're too much for them. So no matter how complex your application is, the developer only need to work on one manifest to describe the deployment plan, even it's across environments. For example, from test to staging to production, the strategy here can also be described in this manifest. And then Kubernetes will take over the rest of the workflow with full leverage of the GitOps toolkit. So this is how our pipeline looks like. It actually trying to use Kubernetes as a control plan, as application delivery control plan here, which gives the most of the benefits of GitOps, but enable some legacy scenarios, but also support the modern GitOps workflow at the meantime. So more and more features regarding to this model is also coming. For example, how to do promotion from environment to another environment with patch per environment to be defined. And we are also working on monitoring the login traits, so the developers can attach a monitoring traits to the application. And we are also trying to open source our command line tool and UI console, and to open source some integration with existing CD pipeline. For example, you can define a CD workflow in this case, and these things are already happening in open source community. So a summary here is that the Kubernetes system, the project, is a modern application deployment and management system across hybrid environment. Itself is use Kubernetes as a control plan, and itself is also a control plan level component. It leverages GitOps by default, but with a lower onboarding bar with legacy system supported. And the core idea behind Kubernetes is programmable. So it's everything in Kubernetes is Q-module. It's highly extensible and very efficient to respond to user needs. For example, if they want a new component, if they want to have some change on existing trait, on existing components, they can do that by themselves, just to change the several lines of the Q file. And the reason we do that is we really don't want to create some in-house or inextensible platform in our company. And of course, our customers always change their ideas very frankly. So we need to have the very, very extensible way to respond to that. And last but most important is that we use Kubernetes as a control plan. We use the reconcile loop to manage all of these infrastructure code modules. And we expose a declarative API to our end users to fill in the values. And this brings us with full automation and deterministic built by Kubernetes control loop. Well, this is everything I want to share with you today, and we're welcome to look at this project, and any feedback are all welcome. Okay, so this is the end of my today's talk, and you can reach out to me through Twitter or through GitHub. So, well, thank you very much.
Thank you so much, Lei. That was really fantastic. What a great way to end a two-day event. And just a reminder to you, if you want to stay backstage for a little bit, Cornelia and I will be doing a quick wrap up, and then we'll be doing kind of a group photo. So if you don't have another meeting to run off to and you want to join our photo, then just hang out backstage, or you can just actually hang out right here with your camera off. And yes, in the meantime, if anybody has questions for Lei, it was fantastic example and all the technologies that you guys have been building, then please throw it in the Slack channel. So thanks so much, Lei. And with that, we'll bring Cornelia on board, and we'll do a little recap and reflect on where we are with GitOps and how these last couple of days have been. I threw some notes in on slides, just like we did yesterday. And like we said, right after this, we'll have our staff and wonderful people who brought this event together, and some of our speakers to come say bye on a goodbye slide. So thanks, Cornelia. Try to make sure I didn't lose you in my view. There you are.
I'm still here, I think.
Yes, you're there. It zoomed did a little funny thing. But thanks, everybody. Thanks to staff who put this together. Thanks for everybody who attended. It's great to see all the active conversation in Slack, as well as a lot of the, my Twitter has just been blowing up with a lot of people retweeting and liking stuff. But really, it's such a great place to be able to see all these fantastic speakers and all the technologies represented, and from all over the world too. A lot of people in later time zones, so they stuck around for America's time zone event. So thank you so much, and we really appreciate all that you brought to bring this great event together. So with that, I wanted to kind of review, if any of you, we wanted to make sure we had a recap that was there for people who, maybe you were busy working and you just couldn't make it. Of course, we have the recordings. We'll have them sitting for a little bit, and then Stacy will be diligently editing and creating playlists from that. But I thought we'd recap, and if we could go to the next slide. Yeah, I thought we had a recap yesterday, sort of looking at the various focus areas. And today I felt like looking at the whole event together, it's really, we really are in a midstream of this journey to GitOps. It was good to reflect on the past, and I was telling Cornelia, I don't have a crystal ball. It's great to hear people like Justin Cormack saying what he wishes he'll see in the next 5 years. But I thought maybe we'd kick off a little bit. Cornelia, you were able to start today with such a fantastic panel. I was just saying, I wish we'd put more time added to it, but I think it's just the beginning, that we'll have many more of these types of discussions with these fantastic speakers like Kief and Sneha, like sharing their different perspectives. But yeah, Cornelia, if you wouldn't mind kind of looking back and reflecting on the panel itself and your thoughts from that panel of where we are with what we had in the past, and in some ways, maybe it was partially its journey to GitOps, but why in many ways it wasn't GitOps.
Yeah, I first of all, I thought the panel was great. And the thing that's so great about panels is you don't know exactly where they're going to go. If you have some idea, you have some plan, some storyline, which I think can kind of form a core and a basis, but then the brilliance just happens in the serendipity of the moment. And so I agree with you. I think that the panel kind of reflecting back on the past and noting that the goals of infrastructure as code were very, very similar, are very similar, almost identical to the goals that we are aspiring to with GitOps. And that GitOps is really just kind of an evolution of that, I think was one of the things that came out of the panel so significantly. But reflecting on kind of that overall the several days, I mean, I started the whole event yesterday reflecting on the past, looking at what we had done kind of with software engineering in the past and where the inflection point was there. And then, as you said, Justin Cormack did something similar. Paul Roberts, just an hour ago, did something similar. Always looking back on what are the challenges, what are the problems that we've been trying to solve for some time. And there's this optimism that I felt across all of those different talks, that something's different now. These problems that we've been trying to solve for quite some time, there's a new ingredient. There's a new ingredient that's going to help us make a really significant difference, not just a little tiny step forward, but a significant step forward. And that's what it felt like to me. And the other thing that I liked about the panel, which was also kind of similar to some of the things that we saw with like the GitOps maturity model yesterday, was this very pragmatic approach of, hey, we have some things that are working to some degree. We want to make them better, but we're not going to desert those things. We're going to make our way there incrementally. So it's the past, but then slowly incrementing towards a little bit more modern now.
Definitely. And that sort of leads to sort of this event and being part of this present. I was saying, there are many technologies. In some ways, I'll put it out there, like, right, there isn't one that's really dominating. Of course, we're very excited about our own Weave GitOps as a company that's being able to be in the middle of this and be able to be so engaged with fantastic companies that are adopting GitOps and trying to understand what GitOps means for them. So I think we're innovating from a place of that great visibility. And I'll be honest, that's part of the reason I love working at Weaveworks. We are known for our innovation. I'm so excited we attracted people like you, Cornelia, to join us. And it's now been, it's a year and a quarter? I can't remember now. I'm losing track
almost
of time.
A year and a half.
Year and a half, yes. And, just the innovation that you have brought as well here. I mean, I think that it's such an exciting place. It's exciting to see where we're going to go. And you, as you reflected a little bit, right, we did accept these different talks that in a lot of ways seem like on the surface they might be similar, that they're comparing the technologies, but I was really excited to accept them because, like Paul's or this morning's, there's these different ones where they're coming from different perspectives, different use cases, different needs. So it's not just like every talk where you're comparing the technologies exactly the same. They are very different. And that's why I was excited to kind of pace them out throughout the day and see, starting with Viktor in the morning and ending with Paul and the others in the middle. I think that there were some great comparisons and people, a lot of people having their own clients. So thinking about their clients in mind. So it was really great to see that. So with that, the future, what do you feel reflecting on these 2 days? For me, I put in parentheses, use cases, thinking about I really, not to pride our own, but Paul Curtis is so great. And I just really was sitting there yesterday, such a great talk on ML ops. It's so clear, right? So clear what you have to think about, and so clear just pragmatically what you need to be thinking about, like with storage, if you're going to be thinking about GitOps. And there's, so many more, of course, Katie was talking about Edge. So what do you think? I mean, just considering how much has changed in the last 12 months, what is your personal crystal ball?
Yeah. So, I agree that across the talks that we saw, particularly today, all the different use cases, all the different kind of perspectives of use of these various technologies and tools, what I think that reflects is a whole bunch of creative people figuring out those patterns, figuring out what the best practices are, and figuring out what is new and different here. And I was, again, reflecting a little bit on the past and now kind of looking towards the future. I am quite certain, and I wasn't super active in this community, but I'm thinking maybe 15, 20 years ago, when people first started automating things like automatic tests during the software development life cycle, and then some of the other automation, I'm sure that there were things like scripts that were put in place and a whole host of variable technologies. But there wasn't this overarching pattern, but there is now, and we call that CI. And so if we look across this relatively mature, space where we have things like Circle CI and GitHub Actions and Jenkins and all of those things, what has emerged is there is in fact a CI platform now. And we're starting to see, so GitOps, of course, we also talked a little bit about the paradigm of GitOps and what the principles of them were. We talked about the GitOps working group, which is something that got created since last year this time. And I was super excited to see Harry just now talk about infrastructure as code, going back to how we kicked off the day this morning, going back to infrastructure as code and saying infrastructure as code, we need to add something else to it, which what he was talking about was he was adding to it the notion of convergence. He was adding to it this convergent pattern. So these concepts of convergence and what GitOps is are definitely solidifying. And so what I think we're seeing now and where we are, we're at the beginning of the future. And I mean that somewhat dramatically, not just obviously, but I mean it somewhat dramatically in that I feel like the inflection point that we talked about when we kicked off the event yesterday, to a large extent, that inflection point is that GitOps is moving from being just a whole bunch of technology that is being applied by creative innovators, or really early innovators. And what we did yesterday when we announced Weave GitOps is we announced a GitOps platform. So there came a time where CI platforms emerged. Well, that time is now. So it's not just GitOps as a technology, but we have a GitOps platform that allows you to interact with GitOps in a first-class setting, in a first-class way. And so now, again, reflecting back to a couple of talks, Justin Cormack talked about a number of things. He talked about the fact that we don't want machines and humans writing into the same branches in the Git repository. Well, that right there is a super interesting kind of area for us to figure out what the patterns are and build those out in this GitOps platform. And then this morning, our panelists also chimed in with, hey, we need multiple environments and we need scale along different clouds and different axes. And so we now have something in which we can start to bring these patterns in a very regular way. And that's what I think the future is. I think that we've hit that inflection point and we have to. And in fact, you had suggested that I kind of go back to this slide, which is to say, you know what? The future is that we have crossed the chasm and now we need to serve that segment that's in the green on this slide. We need to serve that segment and make it consumable by the masses.
Absolutely. Yeah. And I put on the slide as well to talk about this is GitOps at scale, right? It just was, I had reflected earlier today, like thinking about this even 12 months ago, we had some major companies, we had some people, but it really did feel like an event where they were talking to, they were kind of these rare enterprise companies, but fairly rare, like talking from the future to our very hungry audience that, was just filling tons of questions in Slack. And there's a lot of lively discussion. And that was just really, and then I focused the topic as well, right? On like, I see that you're here because you're very excited, but you're saying, a lot of people are saying, I need help to convince my management. I need to help to convince my stakeholders. And I kind of need help to convince either my team or some, teams that we work with about some of the concerns of the changes that have come. And it just feels like just in 12 months, I'm sure there's plenty of people who are still on that journey. And, we still have the GitOps conversation kit out there for you to help you on your journey there. But, just the types of companies that have stepped up and wanted to speak and share their stories yesterday and today just shows like we really are here. We're not maybe in the middle of the green, but we're definitely in a place where these companies are well past kind of being from the future and sharing that they're still in the middle of trying to work things out. I mean, they've really adopted. And in that, I'm going to actually just take the moment to plug here that, as I've mentioned, for those of you who've been using Flux, we have been working with companies to help them migrate to the latest version of Flux. So I put it in the Slack channel and I'll post it again, but State Farm was one of the companies, a couple of others. And again, when I say we're helping them to get to the latest version of Flux, it's our team, my developer experience team is involved, but we're very much representing the CNCF for those, and you'll see if you fill out the form, we're representing the CNCF, we're representing the Flux project to both, help people move through and get a lot of the feedback that we wanted to get to improve the docs. But in that process, we're able to see just the maturity level of these types of companies, how they're thinking about GitOps, like where they want it to be happening, how they're organizing themselves across teams to make that happen. It was very, very exciting. The types of people who showed up at the migration workshop across different teams, right? And the level of questions they're asking, they're really thinking about GitOps across where they have it right now and where they want to take it. So yes, it's very exciting. On that, I don't know, Cornelia, did you have any final thoughts about GitOps at scale? Because as I'd mentioned, it wasn't just the companies talking about it, but the cloud providers understanding that's where they want to insert themselves, right? That's where they want to provide these offerings so that people don't have to be tentative about GitOps. They know that there is a whole industry and ecosystem out there making sure that this is going to happen well.
Yeah, one of the things that I always like to point out when we start thinking about GitOps at scale is whatever axis, whatever trajectory you're thinking about moving to scale. So for a lot of people, it is the number of Kubernetes environments, the number of clusters. That's only one area that you're going to ultimately need to scale in, is the number of clusters or the number of namespaces, the number of environments. It's also going to scale along axes of the number of applications, or the number of teams that are using this, or the number of specific locations where you're going to be running those assets. So we heard Katie talking about edge, right? So there's going to be scale along the different edge locations. And then we also have seen, of course, this morning, we saw Sneha talking about the number of clouds and those types of things. And so what we want to do here is we want to offer a consistent model. And the GitOps, the great thing about GitOps is it's a model that applies consistently across all of those axes. It isn't just restricted to the number of workloads. It's all of these other things. And we talked about that at the end of the day yesterday, which is you can apply GitOps to all the things. And so it's scaling on lots of different dimensions. That is super interesting.
Definitely. And with that, of course, we have to wrap up with We've GitOps, right? We're very excited. I'm glad that you were out there demoing, and we want to make sure, yes, it really is. It's not only the easiest way to get started with GitOps, but it really, we're working to build, it's the easiest way to GitOps, right? It's really the easiest kind of platform that we're building out. And of course, like, you know, for me, what I've mentioned many times, what's exciting for me is that it's built on Flux, right? Like we definitely have done our work. We're in the CNCF. Like I said, we're getting close to graduation. We're going through those steps. So like we have amazing people that we get to work with, not only in the company and in the community, to make Flux what it is, you know, especially the latest version is just really fantastic. And it's just so exciting to see this, the energy in the Slack channels talking about Flux. So of course, to build We've GitOps on top of that, it's just really, it's the most trusted base that you can imagine to have a product that will put out there for a wide range of users. And so we're really, really excited about that. Cornelia, do you want to say any last things before I call out the calls to action on how people get started with We've GitOps?
No, please.
Okay, so as we've shown, right, we have our product page. It is open source and free, so please try out We've GitOps. Here's the link. You can take a screenshot. We also obviously have it in the Slack channels, and we do have a Slack channel now, which is We've GitOps in our Weaveworks community Slack. So please make sure to go there. When you go through the steps, if you get stuck, if you have questions, please ask us. And we'll be kicking off our, we have our Weave user group, the meetup group that's been around now for years. And we'll be kicking off on Tuesday, a session where we can walk you through it again. Please get your laptops ready, come join us. Let us know if you've already gotten stuck somewhere. You know, we want to find out, or if you're not stuck at all, or you want to just get started, we want to make sure that we go through it and you know, make sure our docs and guides and that more use cases are being addressed in the docs. So please show up for that, and we'd love to see you there. So with that, as it's, I can't say it's a tradition because it was kind of like this impromptu thing that we did last year, and it's a little bit of an impromptu thing that we're doing now. But we'll close now with a thank you, and with I believe Stacy and team will join us. I think we can stop sharing our slides.
I'm trying.
Yes, you stop sharing.
Did I? Okay, thank you, Stacy.
And I know that it was late for a lot of people who joined us from Europe, but you can all open your cameras, I think, right? And we definitely want to say a thank you to Stacy. This event would not happen if it weren't for Stacy. Stacy, you see in the names there, it says producer. Oh, I noticed that my my Zoom is backward. Is my background backward?
not for us.
Okay, it just looks like it to me. We're just still figuring out the Zoom parts here. But yes, we really appreciate Stacy putting this together. Daniel, of course, has now gone to bed out in Berlin, but provided the music. And I want to just kind of have a shout out here to Kingdon and Scott, who's on our team. You've seen them speak before, but they were in the back room, making sure that everything worked with our speakers. And Lee, of course, you saw speak, and we, you know, impromptu just reached out to a few speakers. Dan, of course, joined us. Thanks for joining us, Dan. And we got Jeff here, who's our background here, who's, if you want, We've GitOps, definitely talk to Jeff or many of the others on his team, right? So yeah, with that, Stacy, I don't know if you had some music you'll be playing. We'll just sort of wave goodbye, and thanks everybody. I can't hear it. Oh, started hearing something.
Coming in.
Yes. So thank you, everybody. Appreciate it. Thanks. I'm gonna watch the YouTube channel.
Everybody smile for like a half of a second and I'll get a screenshot of us all.
Yes.
We have just
We lost Pop.
Who did we lose?
Right number
Oh, did
for the Brady Bunch.
did
I'm
did
looking
Pop
at it.
freeze?
Right.
Oh, I think
There
Pop's
he
coming
is.
back. All right, we
There
gotta
he
do
is, okay.
screenshots.
All right, here we go, everybody. Okay.
Gotta put my hands in. Cool. Well, thank you, everybody. We will see you at the next event. And with that, I think Stacy's gonna shift to the. Stacy's got all the OBS magic going on.
Thanks, everybody.
Bye, all.
Thank you.
Bye.
Special shout out to Kingdon and Scott for working the magic in the backstage and doing all the speaker handling. Thank you guys.
Yes.
I missed seeing you today, but I know we were chatting it up in Slack.
Yes.
Next time. See you tomorrow.
Cool. So now do we switch off?
Yep.
That splash against my hollow bones that rocks my soul. That splash against my hollow bones that rocks my soul.